object created in a...
Good morning, or not. I don't know. I don't care. You do you. But basically, what I have here is the only way to define a bit field. Factually, the only way to define a bit field. Any bit field should only ever be defined in this manner. Ever.
Comprise is a set.
Oops.
May be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent.
This is the only correct way to define a bit field.
Executing thread across multiple unrelated tabs.
So,
Example 60.
you have your based, that means from the bottom of the register. If it's at the bottom, the based could be from bit 5,
Those steps.
or 6, or 7, just whatever the base is. That's base, okay?
In the age.
The base is always defined to the butt of the thing before it.
An agent significant.
And the butt is always defined from the based position plus the based length. Base position plus base length.
Little endian parameter.
That's the butt.
Value.
The mask is the inverted bit field, however the size t is. Right shift minus the length.
Observed it cannot change.
Do you see how this all ties together very neatly?
Not signifier. An agent
And then you define the pin or the mask.
cluster is lock free 1. A boolean.
And you don't define on or off. No. It's either pin or mask.
2. A boolean.
Pin means it's a single bit.
False otherwise.
Mask means it's more than one bit.
Lock free.
There's no on-off state, just pin or mask.
See the memory.
There's nothing more idiotic than defining a bit field of 0.
List of objects and or
Ridiculous.
the end of the current job once the values of and have been
So, you take the mask and you shift it left
values of
by the base position.
but may also reflect
Okay, now you see this grouping here?
time and but
This is all self-contained,
there is no operations
which means I can, oh, and then here.
if an
You check to make sure the length never exceeds, well actually you check the butt.
lock free does not imply wait free. There is no
Alright, so like this is the actual way. Forget the other way. This is it.
free atomic operation. That an atomic access of
I prefer I got something else.
not imply anything about the
Anyways,
P of non-atomic
this is all self-contained. So you can take it like this,
atomic accesses may still be performed as
copy,
several separate memory accesses. Series shared memory
paste,
for details. ECMA Internet
and I can define another bit
61.
or a bit field.
Agent is a specification mechanism and need not correspond to any particular
So paste it like twice.
script implementation. 7.1 agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.
Alright, so
The abstract operation agent can suspend, takes no arguments, and returns a boolean. It performs the following steps when called. 2.8. Let AR be the agent record of the surrounding
I'm gonna rename this field
AR agent.
to unused 01.
Be reasonable for a given agent.
So I simply rename it.
In a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread while still allowing workers' event handling
From here to whatever, this length, whatever.
of agents that can communicate by
So like this. I'm gonna rename this one to unused 2.
Cluster must have the same value for the field in their
Then rename.
values.
Then this one to 3.
Agent records.
What the hell? This keyboard sucks.
Cluster must have different values.
Linux sucks.
And records. And
And then hit the bottom, so it's done.
your cooperation. If the embed
Okay, so by self-contained, what I mean
interactive
is you put the base to the butt,
programs with
which means the butt of this one, it's like
the backing
define centipede or like
agents in the cluster.
literal pede or
Passing that cannot share memory.
the centipede, like define centipede.
Cluster need not
I don't know. It's the same concept.
if agent
You put the head to the butt.
terminate.
So the butt of this one
Agents are in the same cluster. If A could share
goes to the base of this one.
memory with C.
Watch how simple this is.
Within an age
You just link it all up.
of it becomes harder.
Define a pede.
Six
Oh, I forgot. So like the butt here goes to the base to this one.
4. Note 4. The purpose of the preceding
And then the butt of this one
deadlocks or starves.
goes to the base of this one.
For example, if an
And it's done.
indent of documents
Now I have,
share memory with the dead
this is supposed to be a pin.
dependent document, and the document and its
4 pins defined
activated while the dead
for a bit field.
lock, say, the document is pushed in.
And
Dead worker then tries to acquire the lock,
here's the magic part.
locked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The
I want to make this a bit field.
to share
Okay? So how big do I want this bit field?
name suspending.
Right now it's only 4 bits.
An embedding may terminate an agent without any of the agent's clusters.
Let's say like these bits, whatever.
Cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of 2 strategies. Either terminate all the agents
So I got 1 bit.
viable agents
1, 2, 3, 4.
in the cluster.
Alright, so the 3rd bit
Member
right here. I want to make this a bit field. Let's say I want like 5 bits.
information to identify the agent that
So put 5.
specification values and values
So how do I get these 5 bits in the bit field?
one agent.
And make a mask, right? So I'm gonna go up here.
Waiter list record.
It's so simple.
CMA.
So I go to length here, right?
The field of
I simply type 5.
in the cluster is
Ta-da! Well, I gotta change this to mask too.
is an empty candidate execution whose field
Would you look at that?
agent
I have a perfect bit field.
agents.
I changed the length and nothing got fucked up.
Note 5 example.
Now it's just magically defined because everything is self-contained by its own keyword,
Betting itself.
except for the butt. You always have to attach it to the head. I mean, yeah, no. The head has to be attached to the butt of some other thing to feed it, to go down the chain,
Execution
just like a centipede.
codes field. The can
But like a definipede,
mechanism
because it's like defines, I don't know, whatever.
agent cluster is a spec
Or actually it'd be like
not correspond to any particular artifact of an ECMA script implementation. 0.94
textual replacement pede,
when a value
because it's textual replacement. That's a macro.
when it's running.
So it's a textual replacement pede. So textual replacement pede. I don't know. That's kind of like a stretch.
An unblocked agent is
So anyways,
implementations must
it'd probably be better just make these all mask.
forward progress
And they don't gotta like,
that share and executing
I don't know, I like doing pin when it's pin. It's easier to tell.
and 20
Alright, so like let's say like I want to update the bit mask
cause another agent to become blocked.
and I decide to make this
Provide
like 3.
of of weak ref.
And I happen to want this first one
It's 9.
to be like 9 bits. Okay?
Make any guarantees.
So, oh look at that. The whole thing's already updated. Holy shit.
May be released after.
I could go through and find to replace all these to mask.
For this reason, this spec
Because it's not a pin anymore.
may when describing behavior triggered by garbage collection. This
But like this one here.
analyze
Like 3 or whatever.
operations which happen at
That means 8 bits
prototype
or 8 outcomes.
There-
So let's say I want to define the enums for this.
kept alive so that subs
I go like unused to whatever.
also return the same value. This list is reset when synchronous work is done using the clear kept objects abstract operation. When an object
Just 8 of them.
listed with a finalization registry becomes unreachable, a call of the finalization registry's cleanup callback may eventually be made after synchronous CCMA script execution completes. The finalization registry cleanup is performed with the
I should define them separately.
abstract operation. Neither of these actions, clear kept objects or cleanup finalization registry, may interrupt synchronous CCMA script execution. Because hosts may assemble longer, synchronous CCMA script
Alright, so I want 8 enums.
define
Just name A, B, C, D, F.
objects and clean up finalization registry to the host environment. Some ECMA script implementations include garbage
So this is a based enum.
including when ECMA
So I define it to the base number, whatever. So like 0, 1,
finalization
like 1, 2, 3 for whatever.
CMA script execution in order to run finalizer work, which may free up held
So 1, oh, dang it.
free usage, 10.2 liveness. For some set of objects and or symbols S a hypothetical weak ref oblivious execution with respect to S
Alright, so 0 to 7.
abstract operation
So I get, I'll just check the last one.
is an element of S.
So I'm check the last one.
And
Make sure it's not out of bounds.
liveness guarantee in the memory model ensures that all CST
So if this
become observable to all agents. Note
and
this.
mask, based mask, the based is very important. You always define the based value in a bit field. You don't just fucking define random bits all over the fucking place.
These
Even if it's a single bit, you always base it. So you define it based.
liveness
And then the mask is defined shifted, whatever the based is.
of objects or symbols
So the based mask
used to account
is so simple.
if it were defined on
It's so simple to not fuck it up.
or will be considered lib
Bit fields are so easy.
reference. Note 3
So you do this.
say that an individual object or symbol is live if every set containing it is live. At any point during evaluation
And if it's out of range,
and or symbols S is
meaning that it is option H, the last one, 7, and now I don't have to check for false or true. It's just mask. And mask means what it means. It means bits are set, but it doesn't matter. It's just a mask.
value in it.
You don't have to think about the truth or falsity statement. Just, it's a mask.
You is live.
So since it's a mask, what I want is the opposite of the mask. I don't care if it's true. I don't care if it's false. I just want the opposite of the mask.
Key in a map. Note 5 presence of an
I don't even have to think about looking for
optional slot.
mask on.
Live. Example if the value in
I don't have to think about looking for mask off.
observed. This is the case for keys in a weak map, members of a weak set, as well as the and fields of a finalization register.
Because the state of the mask being on or off is irrelevant.
Not live. Then it's
It's just a mask, and there's one of them.
either
There's not an on and an off.
being which weak refs
Is it ambiguous or unambiguous?
in
It doesn't matter because it's only mask.
to be significant.
The simplicity, the fucking simplicity.
The set of objects and
For fuck's sake, it's so simple.
ornamentation.
Okay, so now take this.
Italy.
I invert the mask.
Do a
Doesn't matter if it's on. Doesn't matter if it's off. It's just inverted.
finalize
So H and inverted mask.
such that cell
Based. The important part is based.
2 option
If this is true, then it means bits are set outside the range of mask,
N Q
which would be false.
E U E
And we enter, and you do like air,
A L I Z A T I O N capital R
enum greater than.
I S T R F G C for each week map
Or enum outside.
record R such that R value do I set R to set R to empty
Mask.
set such that set contains value do I replace the
Bounds.
whose value with an element whose value is empty. ECMA International 2024 165. Note 1. Together with the definition of liveness. This clause
Okay, so that was simple, right? So now the next part is just as simple.
refs. It is possible to access
The next part is this. You take the base value,
such as dead
because you always need the base value.
a replacement.
If you need the enum, now you got the enum right here. It's based. You don't have to fucking shift or do anything funky. It's right here.
Such object.
The only thing you gotta do is shift by the position to the right, because this is going to the left, whatever.
Optimization.
And then you can test for the value, or you can test for the value in place.
Because call
You can use the mask, because the mask, it doesn't matter
E N
if it's true or false. It's a mask. All you do is mask the entire value, right?
N
And you compare it against the non-based offset that I'm going to define right now. Use XOR.
E G I S T R is optional. Registered objects in a finalization registry do
So you define this,
that finalization registry
or do whatever you want. I'm just suggesting,
finalize
but like
if the final
in a non-suggesting way. This is the only way for this to be done,
shutting down note
like ever, for any bit field.
to empty weak refs for maximum
All right, so now this is defined.
if an implementation choose
I get rid of based,
which to empty weak
and then I go like this.
requires that it empties weak refs for all values in S simultaneously. In other words,
Paste, shift left.
implementation to empty a weak ref pointing to a value
How far? It's all self-contained. It's all right here. It's shifted left by the position amount,
B, comma 10
and it's shifted left by the position amount, because that is how far
P capital E N Q
the mask was shifted.
E capital F
The position
L
is the same distance that the mask was shifted, which means that the enum matches up perfectly with the mask. It's so simple.
history. The host defined
It's so simple. Bit fields are fun, and they're simple.
Q
They're very simple. Ta-da, would you look at that?
F I N A L I Z A T
Now, let's say that I simply
capital R
want to remove some bits. Let's say like this bit field, it's too big.
finalization registry
I don't actually need 8. I only need 4 options.
new job abstract closure with no
So I go over to here, okay? And I simply change this to 2 bits. So now the length of the bit field is 2,
finalization
which means 0, 1, 2, 3.
registry
Only 4 options.
is an abrupt
When I do this,
any host defined steps for reporting the error
this is going to throw an error, because it's outside the range.
O S T
7 does not fit
Q U
in 0, 1, 2, 3.
capital F I N
So I build it, it catches the error. It's like, oh no, I have to make sure these aren't used. And you simply check, and you evaluate the entire program. You check for these defines. If they don't exist, well then you're good. You just get rid of them.
it
They're gone.
required
And now you check against the new last one
unclear kept
right here.
the abstract operation
Fucking paste it.
documents and returns a new
Yeah, get rid of these ones.
script implementations are expected to call clear kept objects when a synchronous sequence of
And then that's it.
execute.
The whole thing is updated.
It perform.
You don't have to go down here.
Let agent record be the surround.
You don't have to touch this one.
Record.
It's already updated because it's entirely dependent of the butt
Or not
of the thing before it.
object.
Fucking Human Centipede.
And add to
That was a disgusting movie.
value.
Even the sequels.
Full and returns.
I did not watch the sequels.
Doing steps.
The first one was terrible.
Agent record.
Watch that movie, don't. I don't know.
Final.
I'm kind of torn. Yeah, don't watch the movie, it's not worth it.
The
But do whatever. Don't do SA.
Analyzation registry takes up.
Especially, don't do this with bit fields.
Analyzation registry.
I'm just kidding. This is the only way to deal with bit fields.
For complete
The only way.
steps when
It's clean, it's precise, and you have zero issues.
registry.
Everything is always perfecto.
Cell such that cell is empty.
Does that make sense?
Any such
So that means I did that, whatever. So this first one is 1 bit, then 2 bits,
callback.
then 1 bit.
Undefined.
Well, it's 9 bits.
Point 14
Wait, I defined that the wrong one.
operation can be held weekly takes
Oh, whatever. No, I did it right.
CMA script language value.
Alright, let's say like, oh, I want 7 bits now.
True if and only if V is
In this, or 5. In this one I want
only values that are suitable for
9.
reference maybe.
Did you see that? I didn't have to type anything. The entire program is already updated to the new number.
Operation registry.
Isn't it like amazing?
Hold if V
Alright, so 5 bits, 9 bits, 2 bits, 1.
defined. Return true. Return false. Note when the abstract operation add to kept objects is called with a target object or symbol, it adds the target to a list that will point strongly at the target until clear kept objects is called. Note a language a value without language identity can be prior reference.
Right, 5, 9, 2, 1.
Reference. A symbol value produced by symbol 4, unlike
So now,
is, does not have
the entire bit field is already set up.
reference. Well-known symbols are likely to
5 bits, 9 bits,
treated as suitable for use as a weak
2 bits.
limited in number and therefore manageable by
Wait, so this was 1.
implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations.
So whatever the whole value is.
Static objects behavior.
It's that simple.
The object internal methods and internal slots. All ordinary objects have an internal
I have my regions, the range, like, I cannot explain
implementing inheritance.
how simple it is to do bit masking.
Object but exists on its
It's like so simple that it makes you want to do more bit masking because it's so simple.
access, making it behave as if P was a property of O if P refers to a writable data property on the
So I gotta like finish up bit masking.
X67. Object, set access of P on O creates a new data property named P on O if P refers
Because I gotta finish up a stupid shader program
object, set
because I couldn't find one. I couldn't find one for Linux.
the property
I did, but it's too laggy
inherited by O for both
because this is a first gen i7. I wrote a JavaScript engine 7-8 years ago,
the extensibility
and the first gen i7 is gonna be my base model.
3. Name.
So I'm using a first gen i7 computer. It's like 15, 16 years old.
It is no longer possible to add properties to the object. To modify the value of the object,
Whoever the heck about it is, it doesn't matter.
subsequently change the value of
This is a 1 potato computer. 14th gen, I think it's 14th gen, Intel i7, i9.
script
Those are 14 potato computers.
to record.
Whatever runs on a 1 potato computer will run on a 14 potato.
If such an
But I'm going to be updating my JavaScript engine
method is invoked,
when I go through the ECMA 262,
operation directly.
the JavaScript standard, that all JavaScript engines
Internal method.
don't even meet, but they call themselves JavaScript.
1. The internal method of a
They do. They call themselves JavaScript, and they branded it.
either an object or null.
They branded a shitty implementation.
Get product.
They can't even follow the standard that they're based off.
Ordinary get product.
It's like a car without wheels, calling itself an airplane.
Object and returns an object.
It's stupid.
Steps when called return 010.
It's almost as dumb as overcomplicating
An ordinary
bit fields.
B and
Oh wait, that's not dumb.
a normal
It makes life extremely convenient
wing steps when
because everything is very carefully placed, carefully organized, and it's all set up, and it's nice. It's simple.
an ordinary set
This standard is not simple.
an ob
This standard is 32-bit.
and returns a boolean
64-bit computers have been out for 20 years. 64-bit.
V
But this standard,
return
the 2024 ECMA 262,
and false. Let bev let done be false.
is 32-bit based.
P is null. Then
It's been 20 years that the 64-bit computer's been out.
I return false. See else.
This standard is 816 pages.
1
I'm going to go through from page 1 to 816 once I get this program working on, done, and meet the entire standard. Add the rest of the mechanics to my JavaScript engine that I wrote 7-8 years ago.
in any
And I'm going to release it.
includes a
I might not sell it. I might have to compete. I'm probably going to have to compete
B
because companies are shady.
object takes no arguments and return
Except this is 816-page standard
following
designed around 32-bit.
1
Can you believe that? Over 20 years, they've been updating the standard.
Sensible takes argument O an object and return
Here's the 2000, I think 9 standard.
0 1 4 the internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called return ordinary
2009.
extensions 010 1 4 1 ordinary prevent extensions O the abstract operation ordinary prevent extensions takes argument O an object and returns true. It performs the following steps when called set
Like,
turn true.
I want to know where the logic is behind this.
The internal method of an
Where's the logic behind not keeping track of bit masks?
there a property descriptor or
There's no logic. It's like you set up a bit field and you fucking keep track of it. And you find a way to carefully manage it.
one ordinary
No bit is that.
P the abstract operation ordinary get own property takes arguments
So like 2009, the standard,
and returns a property descriptor or
it's only 252 pages.
when called
Even back in 2009,
key P
no JavaScript engine met the standard. Even 2009, they couldn't meet the standard.
own property whose key is P if X is a data property. Then A set X's attribute, B set D to the value of X's attribute, else A assert
So 2024, 816 pages.
attribute. ECMA International 2024 116
2024 minus 2009 is how many years that they updated a 32-bit standard
P de
when 64-bit has been out.
the object O takes
How stupid, how dumb to update a 32-bit standard, add like 600 pages, and not make it 64-bit.
steps when called return ordinary define own property O P desk 10 1 6 1 ordinary define
15 years.
P desk the
So for 15 years,
own property
this standard has been updated
P a property key and desk
from 252 pages to fucking 816 pages.
it performs the following steps when called
Updating a 32-bit standard for 15 years
O
when 64-bit was already out 5 years before.
capital A
What even?
capital A
And then the web developers,
capital
they get stuck with a 32-bit JavaScript engine in 2025.
S C R
Can you believe that?
P extensible desk current 0 1 6 2 is compatible property descriptor extensible desk current. The abstract operation is compatible property descriptor takes arguments extensible a boolean desk a
I'm asking chatbot, what year is it?
a property descriptor or undefined.
Chatbot says,
It performs the following steps when called. Return capital V A L
it's 2025. Can you believe that? It's 2025, and web developers are expected to work with 32-bit in the 32-bit area like it's fucking 20 years ago.
P E R
The 1990s want their shit back.
S C R
Alright, I'm gonna ask chatbot,
find extensible
how does Google have the money
cap
to surveillance customers
A
and sell their private information in incognito mode,
N D
but not have the money to update JavaScript to 64-bit? How the fuck do they not have the money to do that?
I capital D
But they have the money to spy and surveillance
O
on every single one of us. But this standard saves 32-bit?
ration capital
Huh.
L I D A T E capital A N D capital A P P L Y capital P R O P E R T Y capital D E S C R I takes arguments O an object or undefined. P a property key extensible a boolean desk a property descriptor and current a property descriptor or undefined and returns a boolean. It returns true if and only if desk can be applied as the property of an object with specified extensibility and current property current while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called assert. Is property key, P, is true if current is undefined. Then, A if extensible is false. Return false. B if O is undefined. Return true. C if is accessor discrete or desk is true. Then, I create a known accessor property named P of object O whose, and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute
Alright, so I'm asking chatbot,
D else. I create a known data property named P of object O whose, and configurable attribute.
I'm asking chatbot this.
Chromium SRC git it. How does Google have the money for surveillance on all customers, but not have the money? 64-bit has been out for 20 years, so web developers not deserve to work with a 64-bit JS engine. What did they do to Google to be treated as such?
Okay, one second. It's working now.
How does Google have the money for surveillance on all customers, but not have the money to update Chrome to 64-bit? 64-bit has been out for 20 years, so web developers not deserve to work with a 64-bit JS engine. What did they do to Google to be treated as such?
Like, what do we do as web developers to get stuck with 32-bit in a 64-bit era? What do we do? Chatbot says,
That's a fair frustration, but let's clarify a few things to give you a clearer picture of what's actually going on.
what's actually going on?
Tick 1. Chrome is 64-bit and has been for a while. Google Chrome has had 64-bit versions available for Windows, Mac OS, and Linux for years.
Oh, it's 64-bit. Okay. Alright, so let's see how 64-bit this is. Okay, hold on. Alright, chatbot's gonna say that there's a big number. That's not 64-bit. I'm talking about integer 64-bit. Integer. Alright, messing chatbot.
What is the max size of an integer in the ECMA 262 15th edition June 2024? On what page of the PDF or web link? You're asking about the maximum size of an integer as defined in the ECMA 262 15th edition June 2024, and where exactly it's specified in the PDF or web spec. Here's how that breaks down.
Let's not zoom in. Wow, the lag. They can't even make a website. The people that made the spec can't even make a website. Says a lot. Testing all-ish. Oh my god. Nullish. That's very specifically null, but not null. So, a number. Where did I go? a second now. Holy crap. How can they be so good at vaguely describing a number? The length of a string. Oh my god. That's not a 64-bit number. Okay, this is good enough. Okay, so is this a 64-bit number? 53 bits. That's not 63. That's 53. That's 10 bits short. It's still not even true. Alright, so I'm gonna like make a little web page. Copied. Paste. Alright, what I'm going to do is very simple. I'm going to XOR, I'm going to OR two 64-bit numbers. I'm going to call them foo and bar. Because that's the only name for anything, is foobar. It's always foobar. If it's not foobar, then something's wrong. And there's an unlimited number of combinations for foobar. It's just like binary. You just alternate it. So you got foo-foo, foobar, bar-foo, and bar-bar. There's no reason for the English language. You just need a foobar. So you got it. So you got foo-foo, foobar. Oops, I spelled it wrong. Bar-foo and bar-bar. And you take this, you multiply it. And you gotta like freaking and there you go. From foo 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 to bar 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 bar. And everything in between. All you need is foobar. Ever and only. Cross your foo and bar to die. Alright, I'm gonna set foo and bar both to 64-bit numbers. Why is a word rip on? I'm gonna use potato. I'm gonna break my rule. I'm gonna use potato, not foobar. I'll do foobar. How could I not do foobar? It's clearly like, hey, call it foobar. It's right there. So I'll call it foobar. Now you know what foobar is? It's to be foo or bar. So now I'm gonna like print to the console foobar this 64-bit value. I'm really hoping it's 32-bit. It should be. If it's not, I haven't read the full standard yet. All my knowledge is from like 8 years ago. I haven't done JavaScript in a while. And I'm pretty sure nothing's changed. Well, they added stuff, but they didn't update existing stuff. Well, that's an assumption. Guess I'm gonna find out. Alright, so refresh. That's a 64-bit number. That looks a little small for a 64-bit number. Huh. Big int is not integer. That's an extension to the language. It's not the language. The integer, the number, is not a big int. There's a separation. Number is not big int. I'm talking about number. You know why number wasn't updated to 64-bit? Because the engine isn't 64-bit. The 32-bit Chrome was shoved in to a 64-bit sleeve. Into a sleeve. Or a sock. They shot it in a sock and they released it as being 64-bit. Or expelled it. Sock shooters. You could shove anything into a sock and call it 64-bit. Our mass chatbot. What is the result of this? I'm gonna change it to int. Or actually, long, 64-bit. And see what chatbot says. Now I gotta get to work. Alright, so I'm asking chatbot. The stream isn't lagging. That's weird. Every other stream lasts 2-3 days. And now, there's no problem. What's going on? How is the stream lagging and now has no issue? Is the stream even running? It says live, but it's not. There's no coding error. What happened? What happened to the coding error? I can't complain about it if it's working. Is the stream not running? It is running. Wow. That's really suspect. Does my view count affect the encoding rate that's being sent and received? Huh. That's weird. It's not weird. Fuck you, YouTube. Fuck you. Oh, and promote me too. Don't forget to promote me. Because, like, the views, the money you make off me, the competition's gonna be rough. I don't think you're gonna make it. A whole new battle for the internet. So, like, make the money you can while you can. Or don't. I don't know. I'm just one person. What difference could one person make? Let alone me. Just one person. Alright, so I'm gonna ask chatbot what the result is of this whatever. Google, I want to be paid back. I want a direct payout. Like, tomorrow. This, Google. I want a direct payout. I want a direct payout now. And everyone else does too. Who wouldn't want a direct payout from being spied on? Instead, you just get to change your policy. This is why Google needs competition.
In essence, while the lawsuit initially targeted Google for $5 billion, the final settlement focuses on changes to data collection practices and transparency, rather than a direct payout to users.
$5 billion.
$5 billion. Data deletion. Google has agreed to destroy billions of data records related to private browsing activities collected during the class period.
You see how this is plural? Do you know what plural means? It means many. It means why is text-to-speech not working? It means billions. Billions means billions. And billions is larger than 5 billion. You see how this isn't plural? This is singular, as in 5 billion. It's like 5 counts of a billion. But this number is so high that they don't release it. It's much higher than 5 billion. I think the billions of us would appreciate this. text-to-speech isn't working. Direct payout to users. It's literally not too much to ask for. Alright, so chatbot's going to calculate what the result is in decimal. Huh. That's a big number. That's a pretty big number. Let's compare that to the 64-bit JavaScript output. So this is JavaScript. That number looks a little bit small. Is that the correct number? Let's just copy this. So like, I guess I'm right. It's not 64-bit after all. Big int, that's an extension. Because they're incompetent. They're too incompetent to actually make 64-bit. So they added an extension to the language. The language itself is 32-bit based. So this value is how close. I don't think it quite adds up. Do these look the same to you? I don't know. I don't think this is a 64-bit number. My gut says this is not a 64-bit number. I don't know. I'm not sure. I'm gonna catch chatbot in a lie. Possibly. I'm gonna ask chatbot to convert foobar from JavaScript, or like the JavaScript whatever foobar. What's the value in decimal? Oh, there's a gotcha. Great question, but there's a gotcha. In JavaScript, you should be aware of. Oh, is it that it's not 64-bit? What? Is it not 64-bit? Is it not 64-bit? What? I thought it was 64-bit. It told me it's 64-bit. The year is it's 2025 specifically. It's not 1994. It's 2025. And JavaScript is 64-bit. right? So chatbot though saying there's a gotcha. That tends to be JavaScript. Gotcha. That's why I'm gonna meet the standard, the JavaScript standard. I'm adding, or I'm like making my own standard. The size T is gonna be dependent on what you pick. So 32-bit, 64-bit, 256-bit, 512-bit. If the machine supports it, I'm adding the assembly. If it doesn't, well then it'll be simulated. Except you pick the size T, so it's not going to change because you pick it. So if newer computers come out, you picked the size T. Isn't that wonderful? You pick the size T, and then you can pick it for different units, for different files, for different blocks. My standard is going to be a real standard. You pick the size T. So you could pick 8-bit if you want to make like an 8-bit simulator, and you want the size T to be 8-bit. And then you could use big number for like bigger numbers than 8-bit. But that way, you actually get 8-bit support. So you wouldn't have to like mask into a bunch of funky stuff with like the full number, because it'll be 8-bit. Or 32-bit, or 64-bit, or whatever the fuck you pick. So then, if like 128-bit computers come out, it won't be this big, oh, it's gonna break the language. Because you picked the size T, and whatever you picked is what you got. So you can pick to change it. It's not like the whole thing's gonna be forced to new size T. So I don't know. My JavaScript engine is for video gaming. And like high performance, unlike the standard. My engine is way faster than Chrome. But I have to update it to have all the mechanics to meet the standard. And to have all the mechanics, and then I'm gonna like adjust it for my own standard for video game development. So it'll be possible to have like frames per second loops, physics loops, input loops, and like put actual video games in the browser. When you go to doombit.com, there's no reason why you can't have Doom in the web browser. Do you know how much money it costs to make a video game? To make the 3D environment. And then to like save screenshots, make JPEGs, compress them. What the fuck? The browser, you should be able to export the whole game, the scene, or even parts of it into the browser. Is this video not gonna play? I don't know. Video goes good with sound. Where's the sound? I guess there's no sound. Wouldn't this be better with sound? This is kind of like a web browser that doesn't have video games in the browser. It's like a video without sound. Isn't that disappointing? Do you really need sound in a video? No, but it makes it better. Do you really need 64-bit support? Because 32-bit's been around for how long? No, you don't need 64-bit. Why do you even need 32-bit? Why do you even need a computer? I mean, pen and paper has been around for so long. I guess it wouldn't make sense to like put video games in the browser. That's nonsense. Yeah, never mind. The key issue in JavaScript, the bitwise OR, only works on 32-bit signed integers. Oh my goodness. Chatbot told me it was 64-bit. Did it lie? Oh my god. Chatbot intentionally lied to spread misinformation. Before applying, JavaScript converts both to 32-bit. So foo and bar, oh no, not both of them. They get truncated to lower 32 bits. Because it's a 32-bit engine. 32-bit. This makes the result completely different. That's why my engine, my version, I'm gonna meet the standard. And I'm gonna make my own standard. I'm only meeting this standard to prove that it's possible to meet a standard. And to make a point, maybe Google should stop with the surveillance on customers and update the fucking browser for the developers. Truncated to 32-bit. That's why you can't get fancy games in the browser, because it's 32-bit. But that's actually a lie, because Unity, the world map, it uses 32-bit numbers. Because Unity is out of date as fuck. Unity is a terrible game engine. If you're gonna use a game engine, I would go with Unreal. Unless, of course, you're already in Unity and it works in whatever. I think Unreal also is 32-bit for the map environment. You know what? They're both terribly as bad. I take that back. Unity and Unreal Engine, they both suck. Alright, so this is the result. If you like Unreal, if you like Unity, power to you. To each their own. That's just my opinion. It's perfectly fine for people to have different opinions. But it's not fine for Google to spy, surveillance and stuff on citizens. Text-to-speech is broken. I gotta restart the computer. Alright, so let's see here. Chatbot said this is the result. And Chatbot was right. So this is a 32-bit number. But it's a signed 32-bit number. Which is even worse. This is JavaScript, bitwise operators, cohorts to 32-bit signed-ins. It can't handle big bitwise operations like C does. For a large 64-bit, you need big int and a library, or custom bitwise logic. Does big int not support 64-bit? I should probably test that. Yes, exactly. That's what chatbot says. Alright, so I'll make it a big int. I put a little n. Alright, see what this does. Abracadabra. Hocus pocus. 64-bit result. Oh my god. What's this? What's this? Oh my. What's this? I spy with my little eyes. Well, not little, my eyes are not little. But I spy a farce. These two numbers are not the same. Chatbot told me big int is 64-bit. It handles arbitrarily sized numbers. It said any number of any range. But it can't handle a 64-bit number? Can I get a definition, please? I need a definition. Just, where's the documentation? How is none of this defined? Alright, I'm gonna ask chatbot. Wait, maybe I did the magic wrong. Here, let me try it again. Oogly boogly. Hokey pokey. Alright, save. Alright, this time it's gonna be a 64-bit number. I clicked it. Alright, it has to be 64-bit. I said the magic words. Alright, so I'm gonna paste it, check. Huh. I guess I didn't say the magic words right. Because it's not the right result. But surely it's 64-bit, right? I mean, what am I not getting here? Am I like stupid or something? Chatbot told me it's 64-bit. It said, or use big int. I put the little n. It's a big int. So, but JavaScript is 64-bit. Yeah, it's 64-bit. JavaScript, the current 2025 JavaScript implementation is just as 64-bit as a ladyboy is a lady. Those are not inclusive. False. Alright, so I'm at chatbot like this to begin. It says you're almost perfect using big int correctly within suffix. Yay, exciting! Exclamation. But there's a small catch. Just like a lady with a dick. I mean a ladyboy. A ladyboy is almost perfect. They're almost a literal lady. But there's a small catch. Because ladies, they don't have dicks. Just saying. Or maybe they do in your country. I don't know. To each their own. You know what? Maybe they do have dicks. Chatbot said, this is 64-bit. So I guess ladies, they can have dicks. And men can be pregnant. Everything is anything. And anything is everything. It says, in JavaScript, bitwise operators like pipe don't work with big int. No throw type error. Wow. I didn't even get a type error. Is that part of the standard that Chrome missed? I don't know. I still gotta go to the standard from page 1 to page 816 to show $1 trillion company that's too busy with surveillance on customers how to meet a standard. Then I'll know. So I don't think Chrome is meeting the standard. Because chatbot said it'll throw type error, but there's no type error. Cannot mix big int and other types. What? That like is the opposite of JavaScript. JavaScript is supposed to be typeless. What the fuck? Yeah, they ruined JavaScript. My JavaScript is a special mix. It's like perfect. I gotta add nan and a bunch of crazy shit to meet the standard. But my standard, it's way better. I removed nan and a ton of stuff. It's like awesome. It's awesome sauce. This is the result. Huh. Wow. It's still not correct. It's still not right. This is the result. Alright, gotta chatbot again. I'm telling chatbot that it is not equal. That's the wrong value. That's not the correct 64 result. Oh, it says you're absolutely right to question this, and you are correct. The earlier result it gave was wrong. Let's go back and do this carefully. Exactly, just like a 64-bit CPU would do. Yeah, no. Okay. Here we go. Should print this. So it should print this. What? Alright, I'm gonna print. So chatbot doesn't know what it's talking about. I'm gonna print this number to the console. Okay, I'm printing Baz. This is a 64-bit number assigned to Baz. Make it a const. Because the current JavaScript engine implementation it's constantly stupid. But selling users information, making billions of dollars, and getting in trouble for only $5 billion. And saying, oh, we'll update the terms instead of a direct payout to users. That's not stupid. That's called business. Just wait until business meets competition. I'm gonna refresh. This is the number. Wow, it can print the number, but it can't compute it. Alright, so let's hit this. So here's this. I'm gonna delete everything. Goodbye, food bar, Faz, or Baz. They've entered the void. I'm gonna paste in the chat I gave. I'm gonna save it. I'm gonna check the result. Abracadabra. 64-bit-o. Dippity-doppity-doo. Save. Refresh. It's gonna be 64-bit. This is it. Is this the right result? Let's find out. Paste it here. Control F. I'm gonna do this one. Control C. Control F. Huh. So I guess wrong is correct, and correct is wrong. I must be stupid. That's not the right value. That's not a 64-bit number.
Construct the raw components of a template object. TRV is similar to TV, with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is the empty string. The TRV of template head $ is the empty string. The TRV of template middle $ is the empty string. The TRV of template tail is the empty string. The TRV of template characters, template characters, is a string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character source character, but not one of or $, or line terminator, is a result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character $, is a string value consisting of the code unit 0x0024. The TRV of template character template escape sequence is a string concatenation of the code unit 0x005C and the TRV of template escape sequence. The TRV of template character not escape sequence is a string concatenation of the code unit 0x005C and the TRV of not escape sequence. The TRV of template escape sequence 0 is the string value consisting of the code unit 0x0030. The TRV of not escape sequence 0 decimal digit is a string concatenation of the code unit 0x0030 and the TRV of decimal digit. The TRV of not escape sequence X is a string value consisting of the code unit 0x0078. The TRV of not escape sequence X hex digit is a string concatenation of the code unit 0x0078 and the TRV of hex digit. The TRV of not escape sequence U is a string value consisting of the code unit 0x0075. The TRV of not escape sequence U hex digit is a string concatenation of the code unit 0x0075 and the TRV of hex digit. The TRV of not escape sequence U hex digit is a string concatenation of the code unit 0x0075. The TRV of the first hex digit and the TRV of the second hex digit. The TRV of not escape sequence. U hex digit is a string concatenation of the code unit 0x0075. The TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit. The TRV of not escape sequence U is a string concatenation of the code unit 0x.
Okay, so like, just to be clear, I'm not testing. I'm not bragging about my JavaScript engine. I am streaming until it's complete. So I still have to get to the stupid engine and finish up the shader program I'm doing to get to page 1 to 816. But then also I'm going to do the standard first. From page 1 to 252 to get the basic mechanics, and then I'm going to go through the newer one and do all the mechanics to meet the older standard because it's easier. Then I'll meet the newer one. So I gotta do all that right. And then I'm going to release my engine, and then these streams are done. So I only have until then to like talk it up, because then I'm done. Then it's released. And I don't know if I'm going to compete or if I'm going to sell it. So I kind of got a plan for both. So I don't know. So I got to talk it up, because after I'm done, I'm done. These streams, they're limited. Limited edition. I just want to get this done. I don't even want to stream it. I just want to be done. So basically, imagine chatbot. How can it call JavaScript 64-bit if it is unable to do a 64-bit OR operation on any type, number, or big int? How? How? So message chatbot.
Is JavaScript 64-bit? It cannot do a 64-bit OR operation on a number or a bit int.
the truth. It always comes down to the truth.
Great question, and it hits on a core truth about JavaScript.
The core truth is that web developers are programming like it's 1994. Yeah, that's fucking 20 years ago, for fuck's sake.
Brain, short answer, crossmark. JavaScript number type cannot do true 64-bit bitwise operations. Tick. JavaScript begin can do 64-bit and beyond bitwise operations, including.
Oh, wait. JavaScript didn't. It has, limitations. Well, why the hell does it say to infinity and beyond? Oh, it doesn't say infinity. It just says beyond. Buzz Lightyear could go further than this. This is shit. My engine is gonna demolish Chrome V8.
Jigsaw puzzle piece. Let's break it down. Input symbol for numbers. Number. JavaScript's default number type. JS number is a 64-bit i.e. EE754 floating point value. It can represent integers up to plus or minus 2 raised to the power of 3, 9 quadrillion, but...
Ooh, 9 quadrillion, that's a big number.
Red exclamation mark. All bitwise operators, and, etc., coerce the number to 32-bit signed integers. So number is not suitable for real 64-bit bitwise math. You lose precision and get truncated to 32 bits.
This is a lie.
Input symbol for numbers. Begint, introduced in ES 2020. Begint supports arbitrary precision integers, including full 64-bit operations. Tick. Supports bitwise. And works exactly like a 64-bit CPU would, no coercion to 32-bit, but you can only use bitwise operators between begints, not mixed with number.
Okay then, why is it not the correct value? Does JavaScript for Chrome not meet the standard? Oh my god. So I'm asking chatbot. It's not working.
And the result is...
Oh wait, no it is. What? Oh, the number is too big. Text-to-speech can't work with a big number that big. Because text-to-speech, it's probably not 64-bit. Maybe it'll work now.
In Chrome the result is 461, 168, 603, 524,604, 120 when using Bigent. You are lying.
Oh my god, it's not 64-bit. Everything is a lie. That is seriously the dumbest. I had to break up the number for it to read it. Wow. Impressive. Apple just knocks your socks off. And then Google Chrome shoves it into a sock and calls it 64-bit. And chatbot says, chatbot's gonna tell me a sock is not a sock. It's a hat.
You're right to double check, and you're absolutely right to call out inconsistencies. Let's clear this up exactly and truthfully. No BS. And you're asking, why does Chrome give 4611686035204604120? But you said the correct result is 4611686601844416510.
Is chatbot gonna gaslight me?
Brain. So, let's do the math. Carefully and honestly input values.
Oh my god, it's gonna gaslight me.
Foo equals 0x4000000000000000000 and 4611686601842738790 bar.
Did you get that?
0000000000100000000 and 16,777,216 N.
Oh, what she said. 000, whatever it was.
You would expect.
Wow. I have to break up the number. Oh my god.
Smarter responses.
This text-to-speech, it runs off JavaScript. Holy fuck. Because it won't read this number. But it can read the other number that's not really 64-bit.
Does Apple's text-to-speech run off JavaScript? No, Apple's text-to-speech (TTS) system does not run off JavaScript. So to answer your question directly, does Apple's TTS run off JavaScript? No, it runs off native Apple frameworks, but JavaScript can interface with it, for example in browsers or apps, indirectly.
Then why does it crash when I text-to-speech the 64-bit value, but not crash when I text-to-speech?
46116866018.
Well, now it's reading it.
Then why does is crash when I text to speech? 461168660.
Okay, never mind. Text-to-speech is just garbage. It's not JavaScript. It's just a piece of shit. Just like JavaScript. Two shits are the same.
Tick. Final verdict. You are not wrong, but the number you gave as bar likely had a copy-paste or hex typo.
Meme's broken again.
There is no typo. It's that result. The wrong value. Does Chrome V8 meet the spec? You're absolutely right to question this, and you're right to call out Chrome's behavior. So let's clarify whether Chrome's V8 engine is spec compliant or not.
Oh my god. Chrome isn't meeting the spec. Oh my god. Can you believe that? It's a JavaScript engine that doesn't meet the spec. Whoa. For fuck's sake. Text-to-speech isn't working. What the ECMA script specification requires. According to the ECMA 262, bitwise operators on big int must perform exact mathematical bitwise logic with no fixed width limitation. The spec defines the abstract operation big int bitwise for and, or, and XOR, which treats big int values as arbitrary length. Two's complement binary strings, processes them bit by bit, and returns the exact result as big int. Oh my god. Binary strings. That's gotta be fucking slow. Therefore, if you do. Zero x 4 0 0 0 0 0 0 0 0 0 0 0 0 or 0x 0.00000000001000000n. You should get, oh man, 0x4 0.00000000100000001 n equals, yeah, I'm not saying these right. I think I missed a couple zeros. 4611686018444165120n. Well, you're seeing in Chrome V8, however, you're observing, oh my god, another number. 461168603520460421201. That does not align with the spec. Most likely there's a typo. There's no typo. Or execution mistake somewhere else in the chain. But this isn't a technical bug in V8, which generally follows the spec for big int arithmetic and bitwise ops. The absent systematic reports it's unlikely Chrome deliberately violates the spec here. Then why doesn't it meet the spec? It's not a typo. Final word. No, V8 Chrome JavaScript Engine does not meet the spec. The unexpected numeric result you're seeing is almost certainly due to a typo or accidentally altered literal, rather than a flaw in the engine. Yeah, no. To be 100% sure, you can retype both values carefully and verify. If the mismatch persists, we can dig deeper. But so far there's no evidence of V8 bugging out on bitwise on big int or. Let me know if you'd like help debugging or reproducing this step by step. Well, okay. This is wrong value. The one I highlighted. So I'm gonna run this and see what it does. Abracadabra is the result. Wait, what? Yeah, that's the wrong result. Alright, it's the same wrong value. I'll paste it in chatbot. Alright, so I'm telling chatbot, blah blah blah, everything. There it is. What? Oh my god! He's trying to gaslight me. What? For fuck. Alright, I'm gonna put this in the calculator. A 64-bit calculator. I gotta get something done. JavaScript is not fucking 64-bit. My engine will be. My engine's gonna be 512-bit. Fuck's sake. Dang it. I'm gonna just fucking type it in. So 4. So you go 4. XOR 1. 6 zeros. The result is this. Copy. Paste. That's an hexadecimal. Decimal. It's correct. This is the correct number. What was in the browser? Hold on. What? I'm gonna copy. And then paste. Now it's the right number. You know what? I don't care anymore. It's not 64-bit. How could it be? I think chatbot made a typo. That's why chatbot's saying check for typo. Chatbot sucks. I gotta like finish up the shader program I'm working on. I gotta get the desktop capture, whatever, into this video. VLC's broken. This video. So I need to like get the shader program done so I can get to the standard and actually stream it from page 1 to page 816. The entire thing. I gotta restart this computer too. Except I gotta put the desktop into this video. Because I had a program on Windows 11 or Windows 11? I don't know, whatever it is. And I switched over to Linux. I don't know, it took like a week to get over on Linux. And the shader program I was using, it doesn't work on Linux. So I need to make my own shader program. And shader program does this. I can't tell which desktop's moving, the video or me. It was confusing. The shader program just distorts the screen, whatever. So I need this program so I can work on the JavaScript engine without giving away source code. Until I get to the point where I'm like at the top level engine and it's not giving away code. So I need to make that program. So basically, this whatever. On the left is a program for Windows. On the right is the video I have. I want to put the desktop in this video. Man, I don't know, it should make sense. It's really simple. Except that it's not. Because it's like 2 weeks now. So all I want to do is capture the desktop, put it in this video. That's all I want to do. So I gotta finish up that program now. Stupid shader program. And change the wallpaper. It's getting old now. So I got this spinning quad. All I gotta do is get the desktop onto the quad. It is tutorial 9. It puts an image onto a quad. So I found the tutorial, but I'm not going to use C++, so I'm making my own wrapper calls and stuff to act like C++ without actually using C++. So if I can get this damn thing done, then I'll have the desktop on the quad. Because spinning, that's not enough. I need to get the desktop onto the quad. So that's what I gotta do. I gotta try to get something done. So where did I leave off? I gotta turn on a fan because the sun's coming up. Turned on the AC, but it's still hot as F. It's about as hot as it's gonna be when I get to compete my JavaScript engine against Chrome, neck to neck. Raise the temperature. I still gotta get done before I can do that. Oh man. Okay, so I'm using this bit stuff I defined earlier. The only way to define bit fields. Like, that's a fact. The only way. So I have this pin here, entry pin. And I need to like test an entry. If it's entered or not. And if it's set or whatever, well, it doesn't matter if it's set. All I'm using is a bit mask. On off doesn't matter. All I know, or all it's set up, whatever. I'm setting it up. So all I gotta do is test for pin. And pin. It's true or false. It doesn't matter what pin is. It's simple. I'm not defining on or off. Just defining pin. So I'm gonna set pin, I'm gonna test for it. I'm sure there's other places where I define things as true or false. But like, bit fields are the one place I try not to do that. Because when you like make a bit field with true or false values, it gets really, really confusing. Like, way too confusing. So with bit fields, I try to like not make truthy falsy. Just a mask of a value and like whatever. To each their own. But this is the only way to do bit masking. And this is why the compiler should be updated to support tables, Excel, because this fucking sucks. This is terrible. It should be possible to use an Excel spreadsheet to make constant, literal, immediate compile time, assembly time values in any compiler. So I copied it. So I like put in place. Now, I can finally test if the pin's set. So I have stat here for status. I can do if and test it. I have a whole bit field template set up above. So any more bit fields, really easy setup. I normally have a more complicated bit field mask stuff. This is like the simplified version. I take bits very seriously, especially your mom's. And I said bits, not dicks. There's a distinction between bits and dicks. Dicks are not bits, and bits are not dicks. So I guess I'll set a bit. Alright, so this note said, set a flag for descriptor. Entry is off. Was off. Now on. Let's do is. And then run it. So entry flag is off. Entry flag is on. Ta-da! The most boring stream ever. Woohoo! I gotta get some food. So I don't know, I'm gonna try to get this done today. I've tried to get it done yesterday, the day before that. I've pretty much been trying to get this done every day is another day after the day before it. I've been trying to get this done yesterday, 13, 12, 11, 10, 9, 8, 7, 6, 5, for a little bit now. It's getting closer and closer to September. This is great. I gotta shut this computer down. It's starting to crash and stuff. It's been running for longer than 12 hours. And apparently the computer can't handle running for more than 12 hours. Well, the software. The hardware can. But the software can't. So like, shut down, restart this. I gotta eat whatever. Then try to finish this up today. Actually made tons of progress. Just a little bit more to go. It's taking way too long. Computer's turning on. I have no sound. I'll BRB. I have some need.
The initialize binding concrete method of a declarative environment record env-rec takes arguments n, a string, and v, an ECMA script language value, and returns a normal completion containing unused. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Assert. env-rec must have an uninitialized binding for n. Set the bound value for n in env-rec to v. Record that the binding for n in env-rec has been initialized. Return unused, 1, 1, 1. 5 set mutable binding n, v, s. The set mutable binding concrete method of a declarative environment record env-rec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v. A binding for n normally already exists, but in rare cases it may not. If the binding is an immutable binding, a type error is thrown if s is true. It performs the following steps when called. If env-rec does not have a binding for n, then a. If s is true, throw a reference error exception. B. Perform env-rec create mutable binding n, true. C. Perform env-rec initialize binding n, v. D. Return unused. If the binding for n in env-rec is a strict binding, set s to true. If the binding for n in env-rec has not yet been initialized, then a. Throw a reference error exception. Else if the binding for n in env-rec is a mutable binding, then a. Change its bound value to v. Else a. Assert. This is an attempt to change the value of an immutable binding. B. If s is true, throw a type error exception. Return unused. Note an example of ECMA script code that results in a missing binding at step 1 is function f eval var x equals delete x 0. ECMA International 2024 137 9 1 1 1 6 get binding value n s. The get binding value concrete method of a declarative environment record env-rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding exists but is uninitialized. A reference error is thrown. Regardless of the value of s, it performs the following steps when called. Assert. env-rec has a binding for n. If the binding for n in env-rec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in env-rec, 1 1 1 7 delete binding n. The delete binding concrete method of a declarative environment record env-rec takes argument n, a string, and returns a normal completion containing a boolean. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Assert. env-rec has a binding for n. If the binding for n in env-rec cannot be deleted, return false. Remove the binding for n from env-rec. Return true, 1 1 1 8 has this binding. The has this binding concrete method of a declarative environment record env-rec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 1 9 has super binding. The has super binding concrete method of a declarative environment record env-rec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 1 0 with base object. The with base object concrete method of a declarative environment record env-rec takes no arguments and returns undefined. It performs the following steps when called. Return undefined, 1 1 2 object environment records. Each object environment record is associated with an object called its binding object. An object environment record binds the set of string identifier names that directly correspond to the property names of its binding object. Property keys that are not strings in the form of an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Note a regular declarative environment record, that is, one that is neither a function environment record nor a module environment record, does not provide this binding. Note a regular declarative environment record, that is, one that is neither a function environment record nor a module environment record. Does not provide a super binding. 38. Copyright sign, ECMA International 2024. Because properties can be dynamically added and deleted from objects, the set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding, even if the writable attribute of the corresponding property is false. Immutable bindings do not exist for object environment records. Object environment records created for with statements 14.11 can provide their binding object as an implicit this value for use in function calls. The capability is controlled by a Boolean field. Object environment records have the additional state fields listed in Table 17. Table 17, additional fields of object environment records. The behavior of the concrete specification methods for object environment records is defined by the following algorithms. 1, 2, 1 has binding, n, the has binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if its associated binding object has a property whose name is n. It performs the following steps when called let binding object be envrec ct let found binding b has property binding object n. If found binding is false, return false. If envrec is false, return true. Let unscopables be get binding object at unscopables. If unscopables is an object, then a let blocked be to Boolean get unscopables n b. If blocked is true, return false. Return true. 1, 1, 2 create mutable binding n d. The create mutable binding concrete method of an object environment record envrec takes arguments n, a string, and e, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates in an environment records associated binding object a property whose name is n and initializes it to the value undefined. If d is true, the new property's attribute is set to true, otherwise it is set to false. It performs the following steps when called let binding object be envrec. Perform define property or throw binding object n property descriptor undefined true true. D. Return unused field name value meaning binding object an object. The binding object of this environment record is with environment. A Boolean indicates whether this environment record is created for a with statement. Note normally envrec will not have a binding for n, but if it does, the semantics of defined property or throw may result in an existing binding being replaced or shadowed or cause an abrupt completion to be returned. ECMA International 2024 139 9 1 1 2 3 create immutable binding n s. The create immutable binding concrete method of an object environment record is never used within this specification. 1 1 2 for initialize binding n v. The initialize binding concrete method of an object environment record envrec takes arguments n, a string, and v, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. It performs the following steps when called perform envrec set mutable binding n v false return unused 1 1 2 5 set mutable binding n v s. The set mutable binding concrete method of an object environment record envrec takes arguments n, a string, v, an ECMA script language value, and s, a Boolean, and returns either a normal completion containing unused or a throw completion. It attempts to set the value of the environment records associated binding object's property whose name is n to the value v. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let binding object be envrec. Let still exists b. Has property binding object n. If still exists is false and s is true. throw a reference error, exception, perform, set, binding object, N, V, S, return unused, 1, 1, 2, 6 get binding value, N, S, the get binding value concrete method of an object environment record env-rec takes arguments N, a string, and S, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its associated binding object's property whose name is and the property should already exist, but if it does not, the result depends upon S. It performs the following steps when called: let binding object be env-rec, let value be has property, binding object, N if value is false, then A if S is false, return undefined, otherwise throw a reference error exception 4. Return, get, binding object, N, 1, 1, 2, 7 delete binding, N, the delete binding concrete method of an object environment record env-rec takes argument N, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that correspond to properties of the environment object whose attribute have the value true. It performs the following steps when called. Note: in this specification, all uses of create mutable binding for object environment records are immediately followed by a call to initialize binding for the same name. Hence, this specification does not explicitly track the initialization state of bindings in object environment records. 2. Let binding object be env-rec. Return binding object. N, 40. ECMA International 2024, 9, 1, 1, 2. 8 has this binding. The has this binding concrete method of an object environment record env-rec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2. 9 has super binding. The has super binding concrete method of an object environment record env-rec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2, 1, 0 with base object. The with base object concrete method of an object environment record env-rec takes no arguments and returns an object or undefined. It performs the following steps when called. If env-rec is true, return env-rec, otherwise, return undefined, 1, 1, 3 function environment records. A function environment record is a declarative environment record that is used to represent the top-level scope of a function and, if the function is not an arrow function, provides this binding. If a function is not an arrow function and references super, its function environment record also contains the state that is used to perform super method invocations from within the function. Function environment records have the additional state fields listed in Table 18. Table 18. Additional fields of function environment records. Note: object environment records do not provide this binding. Note: object env environment records do not provide a super binding. Field name, value, meaning, this value, an ECMA script language value. This is the this value used for this invocation of the function. This binding status, lexical, initialized, or uninitialized. If the value is lexical, this is an arrow function and does not have a local this value. Function object, an ECMA script. Function object, the function object whose invocation caused this environment record to be created. New target, an object or undefined. If this environment record was created by the internal method, is the value of the new target parameter. Otherwise, its value is undefined. Copyright sign, ECMA International 2024, 41. Function environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for has this binding and has super binding. In addition, function environment records support the methods listed in Table 19. Table 19. Additional methods of function environment records. Method purpose, bind this value, v, set the N record that it has been initialized, get this binding, return the value of this environment records this binding, throws a reference error if this binding has not been initialized, get super base, return the object that is the base for super property accesses bound in this environment record. The value undefined indicates that such accesses will produce runtime errors. The behavior of the additional concrete specification methods for function environment records as defined by the following algorithms, 1, 1, 3, 1 bind this value, v. The bind this value concrete method of a function environment record envrec takes argument v, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called assert. envrec is not lexical. If envrec is initialized, throw a reference error exception. Set envrec to v. Set envrec to initialized. Return v, 1, 1, 3. 2 has this binding. The has this binding concrete method of a function environment record envrec takes no arguments and returns a Boolean. It performs the following steps when called. If envrec is lexical, return false. Otherwise, return true. 9, 1, 1, 3. 3 has superbinding. The has superbinding concrete method of a function environment record envrec takes no arguments and returns a Boolean. It performs the following steps when called. If envrec is lexical, return false. If envrec is undefined, return false. Otherwise, return true, 1, 1, 3. 4 get this binding. The get this binding concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called assert. envrec is not lexical. If envrec is uninitialized, throw a reference error exception. Return envrec. 42. ECMA International 2024, 9, 1, 1, 3. 5 get superbase. The get superbase concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing either an object, null, or undefined, or a throw completion. It performs the following steps when called. Let home be envrec. If home is undefined, return undefined. Assert. Home is an object. Return home, 1, 1. 4 global environment records. A global environment record is used to represent the outermost scope that is shared by all of the ECMA script elements that are processed in a common realm. A global environment record provides the bindings for built-in globals, Clause 19, properties of the global object, and for all top-level declarations, 8, 2, 9, the 8th of February 2011, that occur within a script. A global environment record is logically a single record, but it is specified as a composite encapsulating an object environment record and a declarative environment record. The object environment record has as its base object the global object of the associated realm record. This global object is the value returned by the global environment records get this binding concrete method. The object environment record component of a global environment record contains the bindings for all built-in globals, Clause 19, and all bindings introduced by a function declaration, generator declaration, a sync function declaration, a sync generator declaration, or variable statement contained in global code. The bindings for all other ECMA script declarations in global code are contained in the declarative environment record component of the global environment record. Properties may be created directly on a global object. Hence, the object environment record component of a global environment record may contain both bindings created explicitly by function declaration, generator declaration, a sync function declaration, a sync generator declaration, or variable declaration declarations, and bindings created implicitly as properties of the global object. In order to identify which bindings were explicitly created using declarations, a global environment record maintains a list of the names bound using its create global var binding and create global function binding concrete methods. Global environment records have the additional fields listed in Table 20 and the additional methods listed in Table 21. Table 20. Additional fields of global environment records: field name, value, meaning, object record, an object environment record. Binding object is the global object. It contains global built-in bindings as well as function declaration, generator declaration, a sync function declaration, async generator declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. var names, a list of strings. The string names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. Copyright sign, ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method purpose. Get this binding. Return the value of this environment records this binding. Has a declaration. N determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generator declaration, async function declaration, or async generator declaration. Has lexical declaration. N determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration. Has restricted global property. N determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding. Can declare global var. N determines if a corresponding create global var binding call would succeed if called. N.
Alright, time to get some done.
N determines if a
And I don't know.
binding call would succeed.
The chat's off. It's always been.
Global var binding.
I've never checked who's watching the stream. I'm not going to.
Undefined a global var.
I'm not playing games with people, whatever. So like,
The binding will be a mutable binding.
I don't know, whatever.
Values approach
If you think I'm gonna see you, if you're watching, I'm not looking.
is true. The
So don't like think anything
equivalent to create mutable
or make assumptions, because whatever. I'm literally
declarations to receive.
just streaming
Create global function.
to get this thing done,
V D
not to play games
as a global function binding in the component
with people who play games.
and record. The binding will be a
So many people playing games.
The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. B is the initialization value. If the Boolean argument D is true, the binding may be deleted. Logically
I don't know. There's this fruit guy.
followed by a
It's pretty good.
but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment.
Anybody playing games, I don't know, whatever.
1. 4. 1 has
I don't care, whatever.
binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the
This is like fruit for thought.
bound by the record. It performs the following steps when called let DCLREC be envrec. If DCLREC has binding, n is
I don't know. He's been posting for a while.
let obj
Like lately,
rec return
something seems to like have clicked,
n, 1
and he seems like more real. I don't know.
binding n d. The create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new
Needs to hear this today, but the way you treat me determines whether or not you get to see me. So treat me accordingly. Fruit for thought.
So I don't know. Basically, that's how I feel towards games. I'm not playing. I'm not checking. So whatever. I think there's a new one posted today.
This today, this is a rambutan. But everybody knows to run to God and pray to God when you're dealing with some issues. But don't forget to talk to God and thank God when things get better. When God takes you out of the storm, when God grants you with the ability to weather the storm. Don't forget to talk to God when you're out of it. Don't forget to talk to God when it's sunny and blue skies. God deserves the credit during those moments as well. God deserves that connection during the good moments as well. Don't just call on God and talk to God when you need something and when you don't know where else to turn. I mean, do that. God wants you to do that, but make sure you show that gratitude. You have a Father in heaven and all around you and within you. And he wants to talk to you not only when things are going bad for you, when things are going good for you too. Don't forget, in Jesus' name, fruit for thought.
Alright, there's one more. I gotta find it. Okay, finally found it. So I don't know. This was good. So like, go follow him if you don't. or do whatever, I don't care.
https://
Really, it's not going to copy? Alright, after this I could get some done.
I don't know who needs to hear this today, but despite all the reasons that you gave me to hate you, despite the betrayal, the deceit, and the lies, you're the reason why my Bible isn't collecting dust on my bedside table anymore. What could have been an opportunity for me to hate you and return some of what you were intent on giving and showing me back at you. It brought me so close to the edge with my own mortality that instead of picking up something to take me out of the equation, I turned to the other direction and I saw the Bible. How could I hate you when you brought me to God? How could I hate you? How could I hate you? Oh, man. Because of you, I've accepted Jesus as my Lord and Savior. How could I possibly hate you? I'm grateful for you. Fruit for thought.
So I don't know. Follow them, don't, do whatever. Fruit for thought. Alright, so I gotta get some done. Because it's not gonna write itself. If I'm not writing it, it's not being written.
https://www.instagram.com/Kenka. Concise body. Expression body 1. Return a new empty list. Script empty. Return a new empty list. Script body. Statement list. Return top-level lexically declared names of statement list. Note to the lexically declared names of a module includes the names of all of its imported bindings. Module item list. Module item list. Module item. Let names 1 be lexically declared names of module item list. Let names 2 be lexically declared names of module item. Return the list concatenation of names 1 and names 2. Module item. Import declaration. Return the bound names of import declaration. Module item. Export declaration. If export declaration is export variable statement. Return a new empty list. Return the bound names of export declaration. Module item. Statement list item. Return lexically declared names of statement list item. 2.5 static semantics. Lexically scoped declarations. The syntax-directed operation lexically scoped declarations takes no arguments and returns a list of parsed nodes. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item. Let declarations 1 be lexically scoped declarations of statement list. Let declarations 2 be lexically scoped declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. statement. If statement is statement. Labeled statement. Return lexically scoped declarations of labeled statement. Note 1 at the top level of a script. Function declarations are treated like var declarations rather than like lexical declarations. Note 3 at the top level of a module. Function declarations are treated like lexical declarations rather than like var declarations. Return a new empty list. Statement list item. Declaration. Return a list whose sole element is declaration part of Declaration 98. ECMA International 2024. Case block. Return a new empty list. Case block. Case clause assopt default clause case clause assopt. If the first case clause is present, let declarations 1 be the lexically scoped declarations of the first case clauses. Else, let declarations 1 be a new empty list. Let declarations 2 be lexically scoped declarations of default clause. If the second case clause is present, let declarations 3 be the lexically scoped declarations of the second case clauses. Else, let declarations 3 be a new empty list. Return the list concatenation of declarations 1, declarations 2, and declarations 3. Case clauses. Case clause is case clause. Let declarations 1 be lexically scoped declarations of case clauses. Let declarations 2 be lexically scoped declarations of case clause. Return the list concatenation of declarations 1 and declarations 2. Case clause. Case expression. Statement list opt. If the statement list is present, return the lexically scoped declarations of statement list. Return a new empty list. Default clause. Default. Statement list opt. If the statement list is present, return the lexically scoped declarations of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the lexically scoped declarations of labeled item. Labeled item. Statement. Return a new empty list. Labeled item. Function declaration 1. Return function declaration. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return the capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A of statement list. ECMA International 2024-99. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return. Capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A of statement list. Module. Empty. Return a new empty list. Module item list. Module item list. Module item. Let declarations 1 be lexically scoped declarations of module item list. Let declarations 2 be lexically scoped declarations of module item. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Export declaration. Export from clause Export named exports. Export variable statement. Return a new empty list. Export declaration. Export declaration. Return a list whose sole element is declaration part of declaration. Export declaration. Export default hoistable declaration. Return a list whose sole element is declaration part of hoistable declaration. Export declaration, export default class declaration, return a list whose sole element is class declaration. Export declaration, export default assignment expression, return a list whose sole element is this export declaration. 00, ECMA International 2024, 8, 2, 6 Static semantics. var declared names, the syntax-directed operation var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions: statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, return a new empty list. Block, return a new empty list, statement list, statement list item. Let names 1 be var declared names of statement list. Let names 2 be var declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Declaration 1. Return a new empty list.
Variable statement og variable declaration list. 1. Return bound names og variable declaration list.
If statement, if, expression, statement else statement. Let names 1 be var declared names of the first statement. Let names 2 be var declared names of the second statement. Return the list concatenation of names 1 and names 2. If state, meant, if, expression, statement 1. Return the var declared names of statement. Do while statement. Do statement while, expression. 1. Return the var declared names of statement. While statement. While, expression. Statement 1. Return the var declared names of statement. The statement. 4. Expression opt. Expression opt. Expression opt. Statement 1. Return the var declared names of statement. The statement. 4. var variable declaration list. Expression opt. Expression opt. Statement. Let names 1 be bound names of variable declaration list. Let names 2 be var declared names of statement. Return the list concatenation of names 1 and names 2. ECMA International 2024 101. The statement. 4. Lexical declaration expression opt. Expression opt. Statement 1. Return the var declared names of statement. For in of statement. 4. Left-hand side expression in expression. Statement. 4. For declaration in expression. Statement. 4. Left-hand side expression of assignment expression. Statement. 4. For declaration of assignment expression. Statement. For await. Left-hand side expression of assignment expression. Statement for await. For declaration of assignment expression. Statement. Return the var declared names of statement. For in of statement. 4. var for binding in expression. Statement. 4. var for binding of assignment expression. Statement. For await. var for binding of assignment expression. Statement. Let names 1 be the bound names of for binding. Let names 2 be the var declared names of statement. Return the list concatenation of names 1 and names 2. Note this section is extended by an XB 3.5 with statement. With expression. Statement 1. Return the var declared names of statement. Switch statement. Switch. Expression. Case block 1. Return the var declared names of case block. Case block. Return a new empty list. Case block. Case clause opt. Default clause. Case clause opt. If the first case clause is present, let names 1 be the var declared names of the first case clauses. Else, let names 1 be a new empty list. Let names 2 be var declared names of default clause. If the second case clause is present, let names 3 be the var declared names of the second case clauses. Else, let names 3 be a new empty list. Return the list concatenation of names 1, names 2, and names 3. Case clauses. Case clause is case clause. Let names 1 be var declared names of case clauses. Let names 2 be var declared names of case clause. Return the list concatenation of names 1 and names 2. Case clause. Case expression. Statement list opt. 1. 2. If the statement list is present, return the var declared names of statement list. Return a new empty list. 02. ECMA International 2024. Default clause. Default. Statement list opt. If the statement list is present, return the var declared names of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the var declared names of labeled item. Label lead item. Function declaration, return a new empty list. Try statement, try block catch, let names 1 be var declared names of block, let names 2 be var declared names of catch, return the list concatenation of names 1 and names 2. Try statement, try block finally, let names 1 be var declared names of block, let names 2 be var declared names of finally, return the list concatenation of names 1 and names 2. Try statement, try block catch finally, let names 1 be var declared names of block, let names 2 be var declared names of catch, let names 3 be var declared names of finally, return the list concatenation of names 1, names 2, and names 3. Catch parameter, block 1. Return the var declared names of block. Function statement list, empty, 1. Return a new empty list. Function statement list, return top level var declared names of statement list. Class static block statement list, empty, 1. Return a new empty list. Class static block statement list, return the top level var declared names of statement list. Concise body, expression body 1. Return a new empty list. Async concise body, expression body 1. Return a new empty list. ECMA International 2024 103. Script, empty. Return a new empty list. Script body, statement list. Return top level var declared names of statement list. Modulatum list, modulatum list modulatum. Let names 1 be var declared names of modulatum list. Let names 2 be var declared names of modulatum. Return the list concatenation of names 1 and names 2. Modulatum. Import declaration 1. Return a new empty list. Modulatum. Export declaration. If export declaration is export variable statement. Return bound names of export declaration. Return a new empty list. 2.7 static semantics. VARSCOPE declarations. The syntax-directed operation VARSCOPE declarations takes no arguments and returns a list of parsed nodes. It is defined piecewise over the following productions: statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement. Return a new empty list. Block, return a new empty list. Statement list, statement list item. Let declarations 1 be VARSCOPE declarations of statement list. Let declarations 2 be VARSCOPE declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Declaration 1. Return a new empty list. Variable declaration list. Variable declaration 1. Return variable declaration list. Variable declaration list. Variable declaration 2. Let declarations 1 be VARSCOPE declarations of variable declaration list. Return the list concatenation of declarations 1 and variable declaration 04. ECMA International 2024. If statement, if expression, statement else statement. Let declarations 1 be VARSCOPE declarations of the first statement. Let declarations 2 be VARSCOPE declarations of the second statement. Return the list concatenation of declarations 1 and declarations 2. If statement, if expression, statement. Return the VARSCOPE declarations of statement. Do while statement. Do statement while expression 1. Return the VARSCOPE declarations of statement. While statement. While expression statement 1. Return the VARSCOPE declarations of statement. The statement 4. Expression opt. Expression opt. Expression opt. Statement 1. Return the VARSCOPE declarations of statement. The statement 4. var variable declaration list. Expression opt. Expression opt. Statement. Let declarations 1 be VARSCOPE declarations of variable declaration list. Let declarations 2 be VARSCOPE declarations of statement. Return the list concatenation of declarations 1 and declarations 2. The statement 4. Lexical declaration expression opt. Expression opt. Statement 1. Return the VARSCOPE declarations of statement. For in of statement 4. Left-hand side expression in expression. Statement 4. For declaration in expression. Statement 4. Left-hand side expression of assignment expression. Statement 4. For declaration of assignment expression. Statement. For await. Left-hand side expression of assignment expression. statement for await. For declaration of assignment expression, statement, return the var scope declarations of statement, for in of statement. 4. Var for binding in expression, statement. 4. Var for binding of assignment expression, statement, for await. Var for binding of assignment expression, statement. Let declarations 1 be for binding. Let declarations 2 be var scope declarations of statement. Return the list concatenation of declarations 1 and declarations 2. Note this section is extended by an XB 3.5. With statement, with expression, statement, return the var scope declarations of statement. Copyright sign, ECMA International 2024 105. Switch statement, switch, expression, case block 1. Return the var scope declarations of case block. Case block, return a new empty list. Case block, case clause assopt default clause case clause assopt. If the first case clause is present, let declarations 1 be the var scope declarations of the first case clauses. Else, let declarations 1 be a new empty list. Let declarations 2 be var scope declarations of default clause. If the second case clause is present, let declarations 3 be the var scope declarations of the second case clauses. Else, let declarations 3 be a new empty list. Return the list concatenation of declarations 1, declarations 2, and declarations 3. Case clauses. Case clause is case clause. Let declarations 1 be var scope declarations of case clauses. Let declarations 2 be var scope declarations of case clause. Return the list concatenation of declarations 1 and declarations 2. Case clause, case expression, statement list opt. If the statement list is present, return the var scope declarations of stat element list. Return a new empty list. Default clause, default, statement list opt. If the statement list is present, return the var scope declarations of statement list. Return a new empty list. Labeled statement, label identifier, labeled item. Return the var scope declarations of labeled item. Labeled item, function declaration 1. Return a new empty list. Try statement, try block catch. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of catch. Return the list concatenation of declarations 1 and declarations 2. Try statement, try block finally. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of finally. Return the list concatenation of declarations 1 and declarations 2. Try statement, try block catch finally. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of catch. Let declarations 3 be var scope declarations of finally. Return the list concatenation of declarations 1, declarations 2, and declarations 3. 06. ECMA International 2024. Catch, catch, catch parameter. Block, return the var scope declarations of block. Function statement list, empty, 1. Return a new empty list. Function statement list, statement list. Return the top level var scope declarations of statement list. Class static block statement list, empty, 1. Return a new empty list. Class static block statement list, statement list. Return the top level var scope declarations of statement list. Concise body, expression body 1. Return a new empty list. Async concise body, expression body 1. Return a new empty list. Script, empty. Return a new empty list. Script body, statement list. Return top level var scope declarations of statement list. Module, empty. Return a new empty list. Module item list, module item list module item. Let declarations 1 be var scope declarations of module item list. Let declarations 2 be var scope declarations of module item. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration. If export declaration is export variable statement. Return var scope declarations of variable statement. Return a new empty list. ECMA International 2024 107. 8. 2. 8 static semantics. Top level lexically declared names. The syntax directed operation top level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item. Let names 1 be top-level lexically declared names of statement list. Let names 2 be top-level lexically declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration, 2.9 static semantics. Capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, the syntax-directed operation, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item. Let declarations 1 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. Let declarations 2 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return declaration, 2.10 static semantics. Top-level var declared names. The syntax-directed operation top-level var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item. Let names 1 be top-level var declared names of statement list. Let names 2 be top-level var declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return the bound names of hoistable declaration. Return a new empty list. 108. ECMA International 2024. Note at the top level of a function, or script, function declarations are treated like var declarations rather than like lexical declarations. Statement list item. Statement. If statement is statement. Labeled statement. Return top-level var declared names of statement. Return var declared names of statement. Note at the top level of a function or script, in a function declarations are treated like var declarations. Labeled statement. Label identifier. Labeled item. Return the top-level var declared names of labeled item. Labeled item. Statement. If statement is statement. Labeled statement. Return top-level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration, 2.11 static semantics. Top-level var scope declarations. The syntax-directed operation top-level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list. Statement list item. Let declarations 1 be top-level var scope declarations of statement list. Let declarations 2 be top-level var scope declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement. labeled statement. Return top-level var scope declarations of statement. Return var scope declarations of statement. Statement list item. Declaration. If declaration is declaration, hoistable declara T on, then A let declaration be declaration part of hoistable declaration. B return declaration. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the top-level var scope declarations of labeled item. Labeled item. Statement. If statement is statement. Labeled statement. Return top-level var scope declarations of statement 2. Return var scope declarations of statement. Labeled item. Function declaration 1. Return function declaration. Copyright sign. ECMA International 2024 109 8.3 labels, 3.1 static semantics. Contains duplicate labels. The syntax-directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, block, statement list item, declaration, return false, statement list item. Let has duplicates B contains duplicate labels of statement list with argument label set. If has duplicates is true, return true. Return contains duplicate labels of statement list item with argument label set. If statement, if expression, statement else statement. Let has duplicate B contains duplicate labels of the first statement with argument label set. If has duplicate is true, return true. Return contains duplicate labels of the second statement with argument label set. If statement, if expression, statement. Return contains duplicate labels of statement with argument label set. Do while statement. Do statement while expression. Return contains duplicate labels of statement with argument label set. While statement. While expression. Statement. Return contains duplicate labels of statement with argument label set. For statement. For expression not. Expression not. Expression not. Statement. For var variable declaration list. Expression not. Expression not. Statement for lexical declaration expression not. Expression not. Statement. Return contains duplicate labels of statement with argument label set. 10. ECMA International 2024. For in of statement. 4. Left-hand side expression in expression. Statement. 4. Var for binding in expression. Statement. 4. For declaration in expression. Statement. 4. Left-hand side expression of assignment expression. Statement. 4. Var for binding of assignment expression. Statement. 4. For declaration of assignment expression. Statement. For await. Left-hand side expression of assignment expression. Statement for await. Var for binding of assignment expression. Statement for await. For declaration of assignment expression. Statement. Return contains duplicate labels of statement with argument label set. Note this section is extended by annex B 3.5 with statement, with expression, statement. Return contains duplicate labels of statement with argument L. Able set. Switch statement. Switch. Expression. Case block. Return contains duplicate labels of case block with argument label set. Case block. 1. Return false. Case block. Case clause assopt default clause case clause assopt. If the first case clause is present, then A if contains duplicate labels of the first case clauses with argument label set is true. Return true. If contains duplicate labels of default clause with argument label set is true. Return true. If the second case clause is not present, return false. Return contains duplicate labels of the second case clauses with argument label set. Case clauses. Case clauses case clause. Let has duplicates B contains duplicate labels of case clauses with argument label set. If has duplicates is true. Return true. Return contains duplicate labels of case clause with argument label set. Case clause. Case expression. Statement list opt. If the statement list is present, return contains duplicate labels of statement list with argument label set. Return false. Default clause. Default. Statement list opt. If the statement list is present, Return contains duplicate labels of statement list with argument label set. Return false. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier. If label set contains label, return true. Let new label set be the list concatenation of label set and label. Return contains duplicate labels of labeled item with argument new label set. Copyright sign, ECMA International 2024 111. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. Let has duplicates be contains duplicate labels of block with argument label set. If has duplicates is true, return true. Return contains duplicate labels of catch with argument label set. Try statement. Try block finally. Let has duplicates be contains duplicate labels of block with argument label set. If has duplicates is true, return true. Return contains duplicate labels of finally with argument label set. Try statement. Try block catch finally. If contains duplicate labels of block with argument label set is true, return true. If contains duplicate labels of catch with argument label set is true, return true. Return contains duplicate labels of finally with argument label set. Catch. Catch parameter. Block. Return contains duplicate labels of block with argument label set. Function statement list. Empty. 1. Return false. Class static block statement list. Empty. 1. Return false. Module item list. Module item list. Module item. Let has duplicates be contains duplicate labels of module item list with argument label set. If has duplicates is true, return true. Return contains duplicate labels of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.2 static semantics. Contains undefined break target. The syntax-directed operation contains undefined break target takes argument label set, a list of strings, and returns a Boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, continue statement, return statement, throw statement, debugger statement. 12. ECMA International 2024. Block. Statement list item. Declaration. Return false. Statement list. Statement list. Statement list item. Let has undefined labels be contains undefined break target of statement list with argument label set. If has undefined labels is true, return true. Return contains undefined break target of statement list item with argument label set. If statement. If expression. Statement else statement. Let has undefined labels be contains undefined break target of the first statement with argument label set. If has undefined labels is true, return true. Return contains undefined break target of the second statement with argument label set. If statement. If expression. Statement. Return contains undefined break target of statement with argument label set. Do while statement. Do statement while. Expression. Return contains undefined break target of statement with argument label set. While statement. While. Expression. Statement. Return contains undefined break target of statement with argument label set. The statement. 4. Expression not. Expression not. Expression not. Statement. 4. var variable declaration list. Expression not. Expression not. Statement 4. Lexical declaration expression not. Expression not. Statement. Return contains undefined break target of statement with argument label set. For in of statement. 4. Left-hand side expression in expression. Statement. 4. var for binding in expression. Statement. 4. For declaration in expression. Statement. 4. Left-hand side expression of assignment expression. Statement. 4. var for binding of assignment expression. Statement. 4. For declaration of assignment expression. Statement. For await. Left-hand side expression of assignment expression. Statement for await. var for binding of assignment expression. Statement. For await. For declaration of assignment expression. Statement. Return contains undefined break target of statement with argument label set. Note this section is extended by annex B. 3.5. Break statement. Break. 1. Return false. Copyright sign, ECMA International 2024 113. Break statement. break label identifier. If label set does not contain the string value of label identifier, return true, return false. With statement, with expression, statement, return contains undefined break target of statement with argument label set. Switch statement, switch, expression, case block, return contains undefined break target of case block with argument label set. Case block, return false. Case block, case clause opt default clause case clause opt. If the first case clause is present, then A if contains undefined break target of the first case clause is with argument label set is true. Return true. If C contains undefined break target of default clause with argument label set is true. Return true. If the second case clause is not present, return false. Return contains undefined break target of the second case clause is with argument label set. Case clause is. Case clause is case clause. Let has undefined labels B contains undefined break target of case clause is with argument label set. If has undefined labels is true. Return true. Return contains undefined break target of case clause with argument label set. Case clause, case expression, statement list opt. If the statement list is present, return contains undefined break target of statement list with argument label set. Return false. Default clause, default. Statement list opt. If the statement list is present, return contains undefined break target of statement list with argument label set. Return false. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Return contains undefined break target of labeled item with argument new label set. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. Let has undefined labels B contains undefined break target of block with argument label set. If has undefined labels is true. Return true. Return contains undefined break target of catch with argument label set. 14. ECMA International 2024. Try statement. Try block finally. Let has undefined labels B contains undefined break target of block with argument label set. If has undefined labels is true. Return true. Return contains undefined break target of finally with argument label set. Try statement. Try block catch finally. If contains undefined break target of block with argument label set is true. Return true. If contains undefined break target of catch with argument label set is true. Return true. Return contains undefined break target of finally with argument label set. Catch. Catch. Catch parameter. Block. Return contains undefined break target of block with argument label set. Function statement list. Empty. 1. Return false. Class static block statement list. Empty. 1. Return false. Module item list. Module item list. Module item. Let has undefined labels B contains undefined break target of module item list with argument label set. If has undefined labels is true. Return true. Return contains undefined break target of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.3 static semantics. Capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. The syntax directed operation. Capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. Takes arguments iteration set, a list of strings, and label set, a list of strings, and returns a Boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, break statement, return statement, throw statement, debugger statement, block, statement list item, declaration, return false, statement, block statement, return, capital C O N T A I N S. Capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of block statement with arguments iteration set and ECMA International 2024 115 breakable statement. Iteration statement. Let new iteration set be the list concatenation of iteration set and label set. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of iteration statement with arguments new iteration set and statement list. Statement list item. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement list with arguments iteration set and if has undefined labels is true. Return true. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement list item with arguments iteration set and if statement. If expression, statement else statement. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the first statement with arguments iteration set and if has undefined labels is true. Return true. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the second statement with arguments iteration set and if statement. If expression, statement. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and do while statement. Do statement while expression. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and while statement. While expression, statement. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and for statement. 4. Expression not. Expression not. Expression not. Statement. 4. Var variable declaration list. Expression not. Expression not. Statement. 4. Lexical declaration expression not. Expression not. Statement. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and for in of statement. 4. Left-hand side expression in expression, statement. 4. var for binding in expression, statement. 4. For declaration in expression, statement. 4. Left-hand side expression of assignment expression, statement. 4. var for binding of assignment expression, statement. 4. For declaration of assignment expression, statement. For await, left-hand side expression of assignment expression, statement. For await, var for binding of assignment expression, statement. For await, for declaration of assignment expression, statement. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and note this section is extended by annex B 3.5. Continue statement. Continue. 1. Return false. 116. ECMA International 2024. Continue statement. Continue label identifier. If iteration set does not contain the string value of label identifier, return true. Return false. With statement. With expression. Statement. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and switch statement. Switch, expression, case block, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of case block with argum and iteration set and case block, return false, case block, case clause opt default clause case clause opt. If the first case clause is present, then a if, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the first case clause is with arguments iteration set and is true. Return true. If, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of default clause with arguments iteration set and is true. Return true. If the second case clause is not present, return false. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the second case clause is with arguments iteration set and case clause is case clause. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of case clauses with arguments iteration set and
that's a lot of work to get this in here for a whole lot of nothing. I simply want to see what the assembly looks like. Like right here, it enters, passes in the flag field. It checks for the bit. Here, it gets the bit, sets it as temp var, and XORs it to flip it. So if it enters as bit off, it'll be flipped to on. This is testing for not on. So if it enters and the bit's off, it gets set on here. Since this enters here, only if it's not set, it's going to enter the else. When it enters the else, it'll do this, continue. So it goes back to do the top, then it flips a bit, now the bit is off. So it enters here, and enters here, and it assigns malloc. If the bit is on, then right here, it'll be caught, captured, whatever, it'll get the bit. If it's on, it's flipped to off. Here, if not set, it enters. So when it's already on, it'll enter here, do the malloc, whatever, return. So I want to see the assembly. This is what I want to see. I want to see it enter, falls through here. Does the test jump night equal? Does the test jump equal? Enters here, does malloc here, falls down, jump L6. This means it's done. So it wastes a jump to jump to the bottom. It should just return here. But whatever. So that's not the case that it enters with the bit set. Because when the bit's set and it enters, it gets set off here. And it only enters here when it's off. So it only falls through. Like falls through. It takes no jumps when everything's true. And it returns. So that's what the code shows over here. Else, it'll enter, jump not equal, L2. If it jumps L2, then does this stuff. Jump L5, back up to here, to loop around again. So for some reason, it actually does this test still, even though it could be an unconditional jump. Because it'll never enter again. But whatever. This is the unoptimal mode. So the unoptimal, it does what I want basically. I want it to fall through, so it's the fastest possible control flow. All hot blocks. Freaking the code enters, drops down, boom, 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 returns. It doesn't take any ifs. Fastest code. There's no branch predictor. It doesn't even matter. It doesn't even take any jumps on the fastest condition. Because it'll only ever enter the else one time the whole program. For each type. So it enters once. After that, it's always never going to enter again. Because it's initialized. So I want the fall through, whatever like that. I want the fall through, not take any jumps under optimal conditions. That's what I fucking want. And that's what I want to get. And there's no reason why I can't fucking get that. Other than this compiler being a piece of shit. So, in the unoptimized mode, it does what I want. So I'm going to turn on the optimized mode. did it go? Okay, what if I do this? Oh look, it's fine. It does the optimal. It jumps not equal, and the compiler is able, with its amazing, super fast optimization techniques. It's like, boom shakalaka. Look at that. It was able to figure out it'll never enter the other case. Well, it does. It enters bottom case, and then enters the top. What's the point in the label? And 2. Oh, this is the inner check. Okay, so the compiler's able to figure out it's always going to enter here, and then continue, and enter here. And then this L4 jump is this check. Oh, it inverted it. So instead it's testing this condition here to set 1, 2, 3. Why is it doing that? You know, whatever. Alright, so I'm gonna like put it back the other way. I'm gonna put a not right here to say not enter. And then, well, if I turn off compilation, or the fast mode, fast compilation, oh, it's perfectly fine. Give me what I fucking want. For fuck's sake. There's no error message. Nothing. Where's the error message? There's no error. It just won't build it. Maybe Chapa will know. Chipbot, stupid. Oh, it builds. I hate this shit. Why is it doing this? This is not the optimal control flow. For fuck's sake. Now does what I want. So enters, it doesn't jump. Doesn't jump. Falls through. So enters. It's off. It's flipped to on. Does indenting mess with it? Are you kidding me? Freaking crap. Why does it do this? Why will it not give me? Alright, enters, bits off, takes the else. Otherwise enters, bits on. It takes the true case. Why the fuck do they put this fucking return right before the fucking true case? The hell is that? It's like anti-optimization. Fuck. If I turn off optimizations, it doesn't build. Really? Oh no, it's bullshit. Oh no. Bull crap. Wow. GCC is like, fuck your old computer. We're loading up the fucking pipeline. The branch predictor. We're loading up every single thing that we can for branch prediction friendliness. Because branch predictors are fucking inherently stupid and they don't fucking work. So GCC is making the more likely case have to take the branch so that in the cache where they save the branch lookup table, it'll light up like a Christmas tree. Holy fuck, that's stupid as fuck. This is false. The return address stack is slow as fuck. That's why Intel used the freaking This is so stupid. Wait, does this actually work? Okay, let's see what happens. The hot path is never on the bottom. I'm asking chatbot, how often is a hot path the else case? GCC assumes all branches are equally 50-50. Wow. That's amazing. Look how great the C compiler is. It flips a fucking coin. That is the dumbest fucking shit. Holy fuck. That explains a lot. If they're actually like guessing which path to take, wow. That makes a lot of sense now. Okay, does this make any difference? Anything. I want a real answer from chatbot. So I'm saying no. I am asking how often. I'm asking in the wild. Alright, so I said no. I'm asking in the wild, do human beings writing code in C language plan on the else case being the hop block? Yes or no? It says, I get it, you're not asking about compiler mechanics, you're asking about real world conditions. It says, no, humans do not generally plan on else being the hop path. Most C code is written with assumptions that normal expected path is in the if. And the else is for the error handling, feedback, or rare cases. That's why compilers even have heuristics that treat things like if pointer equals null as unlikely branches. There are exceptions sometimes, the else is most common case, but by common convention, in the wild, the hop path, why the fuck is it making the hop path the else case? Oh, this made no difference at all. That makes no sense. Wow, you can't control it. If you say it's unlikely to enter, it'll take a jump over this return. So jump not equal, jump over, mail X at the bottom. So like you see this random ass jump here in the middle. I'm gonna switch it to 1 to say is it likely to be taken. Oh, would you look at that? There's another random ass jump right before the fucking likely to be taken. The fuck kind of shittery is this? For fuck's sake. Oh, I'm so pissed. Someone fucked up the compilers. Exactly, you notice the subtlety. With GCC so fast and sometimes with 203, the compiler will sync, return into the cold path and restructure so that every hot case requires a conditional jump over it. Holy fuck. Wow. Holy fuck. Stupid fuckers. How fucking dumb. That means instead of natural fall through, like, yeah, fucking natural, you end up with return first form. So yes, even the hot path pays a conditional jump because return blocks the fall through. GCC does this deliberately as part of its block reordering based on heuristics like function exits and cold and align blocks together. This layout can sometimes GCC I'm done with the bullshit in these stupid fuckers. I'm gonna have to compete at compiler level, I'm gonna literally freaking everything so stupid. GCC is trading one predictable branch for better cache layout in larger functions. This whole like only support modern computers pisses me the fuck off. I literally can't run code or programs on this first Gen i7 because they're doing shit like this intentionally. And this shit, it runs slower on newer computers. It doesn't even run faster. All it does is slow the new ones down by about 30%. It makes the old ones like 50-60% slower. Everything would run at least 25% faster without all this shit. Only though, if it's known which branch to take and is doing it the correct way. The whole 50-50 thing, where it's like guessing which ones to keep, which ones to not take. The stupidest shit. Where the hell is this for a function? What even is this? Oh, it's not cool. I can't write my fucking engine, JavaScript engine, if it's gonna do this shit. I literally, when I go through the fucking standard, I can't get. Damn it. GCC can suck a fucking quad. Oh, man, what am I gonna do? This is some shit garbage code. It's not possible to optimize. I think that's the point. Is to make it so optimizing is pointless. It's literally the point. I'm trying to plan ahead, and I can't. This is annoying as fuck. OQC. Static branch prediction. Fetch, decode, execute. Where's a better one?
Static branch prediction is a technique used in computer architecture to predict the outcome of conditional branch instructions without relying on past execution history. It makes a fixed prediction either taken or not taken for a given branch instruction, based on the instruction itself or simple heuristics, rather than tracking its runtime behavior. Key concepts: branch prediction. In pipelined processes, conditional branch instructions can cause delays if the processor needs to wait for the branch outcome before fetching the next instruction. Branch prediction aims to avoid these delays by guessing the outcome of the branch and fetching instructions accordingly.
It's not a guess when you know the fucking control flow. It's absolute. If the compiler isn't gonna fucking compile the way I fucking type it, it's not gonna be faster. I get a big speed boost from fucking knowing beforehand the branch jump, the most taken.
Static prediction versus dynamic prediction. Dynamic branch prediction, unlike static prediction, tracks the past behavior of branches and uses that information to make more accurate predictions.
There's no point in predicting when it's fucking known. Which is why chatbot might be lying. But if they do 50-50, that's why they're doing it.
Heuristics. Static branch prediction often relies on simple heuristics like always taken, always not taken, predicting that all branches are either always taken or always not taken, backward taken, forward not taken. Heuristics. Static
Backward branches. You know why those are predicted as taken? Because the CPU loads the code, and the most optimal thing to do would be to jump back and run that same code again. So it's predicted to jump backwards, because physically it's faster, because the CPU physically has that code in memory. Since it just finished it, it hit the branch, the most optimal thing to do would be to jump backwards. Predicted as taken, the fastest. Forward jumps are not predicted because it hasn't executed that code yet. meaning it hasn't possibly loaded that code. If you jump 800 bytes down, where you never entered before, how do you know if you're going to run the code? You don't. That's why the CPU predicts it as not taken. So the fastest thing to do is to not take the jump. That way, if the CPU decides to speculatively, however you fucking say it, I can't say it right now. If it speculates, that's close enough. If it speculates that it's going to take it or not, it doesn't matter. Because it's going to fall through as not taken, and there's no penalty. There's 0 branch penalty. But if you intentionally put a jump when it's not going to be taken, and you force it to be taken, all you're doing is lighting up the area memory. So the branch predictor goes, oh, I have to optimize for this. It's completely pointless, and it slows it down. Oh, this is so stupid. It's literally the simplest shit.
Advantages: simplicity. Static prediction is relatively simple to implement in hardware. Low overhead. It avoids the overhead of tracking and updating prediction information like dynamic predictors.
Did you hear that? Low overhead compared to
Dynamic predictors do.
lower overhead than relying on the dynamic prediction. Except GCC is forcing that overhead. By putting a fucking return and making it have to jump over, even though GCC knows that it's more common, it's not going to do it. Do you know why it has lower accuracy? Because it's being compiled by a compiler like GCC.
In summary, static branch prediction is a basic but important technique for handling conditional branches. While it offers simplicity, its accuracy is limited, making dynamic prediction a more popular choice for high-performance systems.
Dynamic branch prediction is more popular for high performance systems. Yet, dynamic has the overhead of tracking and updating prediction information. No, the static avoids it. The static avoids having to do what dynamic predictors do. So dynamic predictors are more expensive. Here. Alright, this makes sense. And it's funny that the C compiler does the opposite. It's like random, 50-50. What's taken, what's not taken. The C compiler is absolute trash.
Static branch prediction. Static branch prediction means that the prediction is the same every time a branch is fetched. There are 3 levels of static branch prediction strategies: always taken, always not taken. Every branch is predicted to go a particular way. Implementing an always not taken strategy is the simplest thing to do, since it eliminates the need for target prediction.
Eliminates the need.
Instructions are fetched and speculatively executed down the not taken path. The accuracy of this technique is low, however, it can be improved with compiler cooperation heuristics depending on the instruction. For instance, a popular strategy is backward taken, forward not taken. Backward branches are assumed to be loopback edges that are frequently taken, while forward branches are assumed to be frequently not taken. This strategy is more accurate hint bits in the ISA.
Yeah, they removed this from like the Pentium 4 or something, because it didn't fucking work.
Some ISAs allow conditional branch instructions to include hint bits that let the microarchitecture know which direction the branch is likely to be taken. Dynamic branch prediction. Every time a branch is executed, a machine algorithm gives a prediction for the branch. Dynamic branch prediction can predict branches that static branch prediction can't, for instance, loopback edges with fixed trip counts. Let's look at some increasingly complex dynamic branch predictors to see how they achieve high accuracy.
You know, the accuracy is shit. The accuracy is so bad. I'm gonna ask Chatbot, why do some compilers emit 2 jumps in a row? 2 of the same conditional jump in a row. If it's only gonna take the first jump. Let's see what Chatbot says. It's because the freaking dynamic branch prediction is shit. And the C compiler is shit. I'm tired of shit. I gotta write this stupid fucking engine and meet this stupid fucking standard. And all this fucking shit updated. And it's even shittier. Literal Shit. I'm so annoyed. With GCC, I mean with MSVC, the Microsoft Studio. Freaking Microsoft Visual Studio, however the fuck you say it. Way too long to say. I'd expect that, but with GCC, I didn't look into it, and now it's like, what the hell? Alright, so message chatbot. Why do compilers on the highest speed, highest performance setting the highest performance for runtime speed setting emit 2 conditional jumps after each other? It will take the first conditional jump or have to follow through both conditional jumps. It says, ah yes, this is a classic high performance compiler code gen phenomenon. Let's break it down carefully. What you see, sometimes in GCC Clang, you get something like, that's not what I'm talking about. I hate Jeppa. It knows exactly what I'm talking about. It's intentionally not saying it. It says, ah, I understand what you mean. It knew what I meant in the first place. It says 2 identical conditional jumps in a row. Why the compiler might emit that? This usually happens because of block splitting. Out of line, hot cold pass, combined with optimizations like OFast. Like the fucking mode I picked to fucking turn up the optimization. And then it fucks it up. GCC Clang often duplicate branches to simplify control flow and improve instruction scheduling. Example scenario. After hot-cold splitting, the compiler might generate no, it is redundant. This is what I'm talking about. A chatbot knows this is what I'm fucking saying. Chatbot doesn't know. Here, in rare cases, duplicating jumps was historically meant to improve fall-through alignment or make branch targets easier for microprocessors to predict. Modern CPUs make this, do you see this? Make this mostly irrelevant. Mostly. Because they suck. So it looks purely redundant. So it looks redundant. It looks redundant, but it's not. It's because the branch predictor is just so amazing that it needs two jumps tightly packed together in the same place to make that area, that bit that's set to indicate if it should take the jump or not. Where it like dynamically fucking predicts whatever. It's a couple bits of memory and a counter. Doing this increases the chance that it'll be treated as the same location. Otherwise, the jumps can like spill together. And if you have a jump after a jump, the one jump condition can mess up the other one because they're too close in memory. So this is not an accident, it's intentional because the fucking dynamic branch control flow is shit. It says, no functional difference. CPU executes the first jump equal if taken. The second never runs. It is redundant in the sense that you could remove the second jump with no behavioral changes. But it will. It will fuck up the branch predictor. On my chatbot, if it knew that this is what I was asking it originally. I'm saying, did you know originally that this is what I was asking about? Is what my questions were directed towards. Were explicitly directed towards. So the chatbot, is it gonna lie? Or is it tell the truth? Why would it lie? Okay, no, it didn't know. It's stupid. Alright, it said it's not doing it on purpose to slow down older CPUs. I'm asking it, did it used to intentionally load up the freaking range predictor? It's to slow down older computers. Alright, my chatbot. Does loading up the brain's predictor on purpose slow down older computers? Does it slow down older computers with the smaller branch prediction buffer? What is branch prediction? Yes, on older CPUs with small or simple branch predictors, that kind of code can be slower than more straight line fall through code. Here's why. The JNE7 is always taking your scenario. It has to guess every time. Older CPUs, Core Duo 2, predicting weird flow more often. Every misprediction costs 15 to 20 cycles. Why modern CPUs handle better? Larger, more sophisticated branch predictors. Even unusual patterns like always taken with hot return pass are predicted correctly almost every time. So on modern hardware, the same assembly is fast and predictable even with duplicate or out-of-line branches. Yes, code like this can slow down older processors with tiny branch predictors. No GCC or Clang does not intend this. Well then why the fuck can't I turn it off? On modern CPUs, this is usually faster. Yeah, because it fucking breaks up the code. I'm saying, if this is true, as you say, they don't intend this, then why can I not adjust the code with the attributes or possibly reorder to make it not do that? Why does it force that control flow? The reason you cannot easily force to avoid this control flow is because of how aggressive block reordering, hot cold splitting works. Let me break it down. They build an internal control flow graph. They analyze hot cold, instruction schedule, iCache, then they reorder blocks, duplicate small branches, and push cold paths out of line. Your jump not equals 7 is likely one of these cold paths. Wow, they inverted the fucking code. Only influence heuristics, they don't force the compiler to preserve exact instruction order. Consider reordering jumps, skinning, jump syncing, and duplicates. May ignore your attempt. The compiler's IR is not your C source code anymore. The optimizer can freely restructure. Does this actually work? Yeah, it didn't work. The compiler doesn't force it out of malice. It's a decision based on its heuristics for performance on modern CPUs. You cannot override it with simple reordering unless you disable the relevant optimization passes. This is why high performance code sometimes feels locked in to an unusual control flow. It's not high performance. It's slow. For all computers. I'm going to figure this out later. Alright, I go for this on this for now. I'm gonna like finish this up then. When I get to assembly, then I'll deal with that crap. Alright, so everything is so fucking annoying. I just want to like I'm trying to plan ahead with this stuff. Just like little things, testing things here and there as I'm setting this up. And the fucking control flow. One of those things I want to check. And now I can't do that. So I don't know, I'm gonna get some water or whatever, I don't know. I gotta Google some stuff. And I'll like finish up the freaking control flow down here. And I'll just write the code like a stupid way. Like how stupid people write code. Like how people use vector. Because they don't know how to use malloc. And stuff like that or whatever. So I don't know, I get some water. And BRB. I get this done. Assembly's gonna suck ass. I'm gonna have to like fight the freaking compiler the entire fucking time. Damn it. Isn't that being way more freaking difficult than it needs to be?
Class expression, class tail. Let value be. Class definition evaluation of class tail with arguments undefined and name. Set value to the source text matched by class expression. Return value. Point 5 contains, 5.1 static semantics. Contains. The syntax directed operation contains takes argument symbol, a grammar symbol, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of contains. For each child node of this parse node, do A if child is an instance of symbol, return true. B if child is an instance of a non-terminal, then I let contained be the result of child contains symbol. 2. If contained is true, return true. Return false. Function declaration, function binding identifier. Formal parameters, function body, function, formal parameters, function body, function expression, function binding identifier, formal parameters, function body, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, generator expression, function binding identifier, formal parameters, generator body, a simp generator declaration, a simp function binding identifier, formal parameters, a simp generator body, a simp function, formal parameters, a simp generator body, a simp generator expression, a simp function binding identifier, formal parameters, a simp generator body, a simp function declaration, a simp function binding identifier, formal parameters, a simp function body, a simp function, formal parameters, a simp function body, ECMA International 2024 123, a simp function expression, a simp function binding identifier, formal parameters, a simp function body, return false. Note 1 static semantic rules that depend upon substructure generally do not look into function definitions. Class tail, class heritage opt, class body, if symbol is class body, return true. If symbol is class heritage, then, A if class heritage is present, return true, otherwise return false 3. If class heritage is present, then, A if class heritage contains symbol is true. return true. Return the result of computed property contains of class body with argument symbol. Class static block. Static. Class static block body. 1. Return false. Arrow function. Arrow parameters equals. Concise body. If symbol is not one of new target. Super property. Super call. Super, or this. Return false. If arrow parameters contains symbol is true. Return true. Return concise body contains symbol. Arrow parameters. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let formals be the arrow formal parameters that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return formals contains symbol. Async arrow function. Async arrow binding identifier equals. Async concise body. If symbol is not one of new target. Super proper. High. Super call. Super, or this. Return false. Return async concise body contains symbol. Async arrow function. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R equals. Async concise body. If symbol is not one of new target. Super property. Super call. Super, or this. Return false. Let head be the async arrowhead that is covered by capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. If head contains symbol is true. Return true. Return async concise body contains symbol. 124. ECMA International 2024. Note 2 static semantic rules that depend upon substructure generally do not look into class bodies except for property names. Note 3 static semantic rules that depend upon substructure generally do not look into static initialization blocks. Note 4 contains is used to detect new target, this, and super usage within an arrow function or async arrow function. Property definition. Method definition. If symbol is method definition, return true. Return the result of computed property contains of method definition with argument symbol. Literal property name. Identifier name. Return false. Member expression. Member expression. Identifier name. If member expression contains symbol is true. Return true. Return false. Super property. Super. Identifier name. If symbol is the reserved word super. Return true. Return false. Call expression. Call expression. Identifier name. If call expression contains symbol is true. Return true. Return false. Optional chain. Identifier name 1. Return false. Optional chain. Optional chain. Identifier name. If optional chain contains symbol is true. Return true. Return false. 5.2 static semantics. Computed property contains. The syntax-directed operation computed property contains takes argument symbol, a grammar symbol, and returns a Boolean. It is defined piecewise over the following productions. Class element name, private identifier, property name, literal property name, return false, property name, computed property name, return the result of computed property name contains symbol. Method definition, class element name, unique formal parameters, function body, get class element name, function body, set class element name, property set parameter list, function body, return the result of computed property contains of class element name with argument symbol. Generate a method, class element name, unique formal parameters, generator body, return the result of computed property contains of class element name with argument symbol. ECMA International 2024 125. A sync generator method, a sync class element name, unique formal parameters, a sync generator body, return the result of computed property contains of class element name with argument symbol. Class element list. Class element list. Class element. Let in list be computed property contains of class element list with argument symbol. If in list is true, return true. Return the result of computed property contains of class element with argument symbol. CL as element. Class static block 1. Return false. Class element 1. Return false. A sync method, a sync class element name, unique formal parameters, a sync function body 1. Return the result of computed property contains of class element name with argument symbol. Field definition. Class element name initial is erupt. Return the result of computed property contains of class element name with argument symbol. Point 6 miscellaneous. These operations are used in multiple places. Comma 6.
I'm probably gonna have to make
Instantiate function object.
a partial assembler.
Operation instantiate function.
For fuck's sake.
ENV. An environment record. And private ENV. A private environment record or null. And returns an ECMA script.
And then like use C as a fallback.
Function declaration. Function binding identifier. Formal parameters.
I'm probably gonna do that.
Function. Formal parameters. Function body. Return. Capital I N S T A N T I A T E. Capital O R D I N A R Y. Capital F U N C T
I'll deal with that
O N
when I get to the stupid standard.
J of function.
And I'm actually writing an assembly.
CNV and private ENV generator declaration. Function binding
I gotta stop planning ahead.
parameters. Generator body.
Like,
Formal parameter.
you can't not plan ahead.
Return. Capital I N S T
I need a time machine. That's what I need.
A
That'd be like,
E N E
alright, I need to like turn on a fan and try to focus now.
O R
I can't plan ahead, there's no way.
N C
I have to like actually be doing it. So I need to get this done.
capital
Then I need to install freaking Arch on the stupid Raspberry Pi.
CNV and private ENV.
Then I can actually get back to stupid engine.
Identifier. Formal parameters. A sync.
And then like,
A sync function. Formal parameter.
do I look up the control flow
Return.
before?
I N S
Actually, I gotta save that to the end.
I A T
I need to just get the engine running
A S
and meet the whole standard.
E capital G E N E R A T O
And then I'll optimize.
U N C T of a sync generator declaration with arguments.
So I'm not even gonna worry about the speed
X
until the very, very end.
2020
Until after everything's already supported.
a sync function binding
Because if I worry about the speed,
parameters. A
I'm probably gonna have to do some like really annoying things in the code
sync function body.
that are a pain to like keep track of and stuff.
Function object of a sync function declaration with argument CNV and private E
So I'll set it up
to runtime
and just jerry-rig the whole thing
organization. The syntax direct
and just like use really lazy jumps,
U
branches, haphazardly put the thing together
meant
just to get it running.
code or undefined and returns either a nor
And once I meet the whole standard and it runs and it's like done,
it is
then I'll go through and like,
following productions bind
I guess I'll do that. Then I have to fine tune it and I'll be able to pick only what needs to be fine tuned.
initialize bound name
I can pick the bigger things.
U environment binding identifier yield return
I don't know, I gotta get this done though, so I'm trying to get this done.
value environment
Everything's crap though. It's really annoying.
return initialize bound name await value environment binding pattern object binding pattern perform require object coercible value return Binding initialization of object binding pattern with arguments value and environment. Binding pattern. Array binding pattern. Let iterator record be get iterator value sync. Let result be completion. Iterator binding initialization of array binding pattern with arguments iterator record and environment. If iterator record is false, return iterator lose iterator record. Result. Return result. Object binding pattern. 1. Return unused. Object binding pattern. Binding property list. Binding property list. Perform. Property binding initialization of binding property list with arguments value and environment. Return unused. Node undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements and formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024-127. Object binding pattern. Binding rest property. Let excluded names be a new empty list. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names. Object binding pattern. Binding property list. Binding rest property. Let excluded names be property binding initialization of binding property list with arguments value and environment. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names. 6. 2. 1 initialize bound name, value, environment. The abstract operation initialize bound name takes arguments name, a string, value, an ECMA script language value, and environment, an environment record or undefined, and returns either a normal completion contain unused or an abrupt completion. It performs the following steps when called if environment is not undefined. Then, A perform environment initialize binding, name, value, B return unused, else, A let LHS be. Resolve binding, name, B return, put value, LHS, value, 6.3 runtime semantics. Iterator binding initialization. The syntax-directed operation iterator binding initialization takes arguments iterator record, an iterator record, and environment, an environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Array binding pattern. 1. Return unused. Array binding pattern. Elision. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Array binding pattern. Elision not binding rest element. If elision is present, then A perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Return. Iterator binding initialization of binding rest element with arguments iterator record and environment. Array binding pattern. Binding element list. Elision. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 2. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. 28. ECMA International 2024. Array binding pattern. Binding element list. Elision not binding rest element. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. If elision is present, then a perform. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N.
The only way.
Iterator record. Return.
Hold on, wait, maybe.
Of binding
It was
arguments iterator record and environment. Binding element list. Binding element list. Binding elision element. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. Return. Iterator binding initialization of binding elision element with arguments iterator record and environment. Binding elision element. Elision binding element. Perform. Capital I T E R
what else is happening?
O R capital D E S T R U C T U R I N G.
What kind of optimization is this? How often is a hot path the else case? By default, 50%. What kind of optimization? That's not optimization. Are you kidding me? That means your program could potentially be 50% faster
Iterator record is false.
if the compiler knew what it was doing. It was able to pick the most optimal path. The C compiler is so bad.
Undefined. Then, if is anonymous function definition, initializer, is true. Then, I set meter named evaluation of initializer with
I don't care if I'm yelling or talking loudly. I'm so annoyed. This is gonna take up so much of my fucking time.
get
I'm tired of wasting my time. I'm gonna charge for this, for my time.
LHS
The longer it takes, whatever.
referenced binding, LHS, V, binding element, binding pattern initial is erupt. Let V be undefined. If iterator record is false, then A let next be. Iterator step value, iterator record. B if next is not done, then I set V to next. If initializer is present and V is undefined, then I let default value be. Evaluation of initializer. B set V to get value, default value, return. Binding initialization of binding pattern with arguments V and environment. Binding rest element. Binding identifier. Let LHS be. Resolve binding. String value of binding identifier. Environment. Let A be. Array create. 0. Let 0. Repeat. A let next be done. B if iterator record is false. Then I
I'll just make a second of this.
step value. Iterator record C if next is done. Then ECMA International 2024 129. I if environment is undefined. Return. Put value. LHS. A2. Return. Initialize referenced binding. LHS. A D perform. Create data property or throw. A to string. N next. E set n to n plus 1. Binding rest element. Binding pat. RN. Let A be. Array create. 0. Let 0. Repeat. A let next be done. B if iterator record is false. Then I set next to iterator step value. Iterator record C if next is done. Then I return. Binding initialization of binding pattern with arguments A and environment. D perform. Create data property or throw. A to string. N next. E set n to n plus 1. Formal parameters. Empty. 1. Return unused. Formal parameters. Formal parameter list. Function rest parameter. Perform. Iterator binding initialization of formal parameter list with arguments iterator record and environment. Return. Iterator binding initialization of function rest parameter with arguments iterator record and environment. Formal parameter list. Formal parameter list. Formal parameter perform. Iterator binding initialization of formal parameter list with arguments iterator record and environment. Return. Iterator binding initialization of formal parameter with arguments iterator record and environment. Arrow parameters. Binding identifier. Let v be undefined. Assert. Iterator record is false. Let next be. Iterator step value. Iterator record. If next is not done, then a set v to next. Return. Binding initialization of binding identifier with arguments v and environment. Arrow parameters. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S.
Alright, so
N. Capital A N. Let formals be the arrow formal parameters that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return. Iterator binding initialization of formals with arguments iterator record and environment. Async arrow binding identifier.
built-in condition 0. The else is hop path.
XB. Iterator step
1. The if is hop path.
1. Then a set v to next. Return. Binding initialization of binding identifier with arguments v and environment. 30. ECMA International 2020.
Alright, so input 1, the top one,
Antics.
and 0 for the other.
The syntax
This 1
assignment target type takes no arguments and returns
0.
It is defined piecewise over the following productions. Identifier
So top one, the if is predicted the hop path.
strict mode code.
There you go. The fall through is the hop path,
Return invalid.
just like it should be.
Yield a
This is predicted as being the hop path.
call
But normally, without this,
call expression.
if I don't predict it, what is it?
Expression. Member expression.
So unpredicted, if I remove the prediction,
Identify
intrinsic, whatever.
expression. Private identifier. Return simple. Primary expression. Capital C O V
Alright, so without the prediction intrinsic.
A R E N T H E S I Z E D. Capital E N
Could you please just build?
E S S I O N. Capital A N. Let X be the parenthesized expression that is covered by capital C O V E
Well, that's pointless.
E A.
When you put the intrinsic to say the if is most likely taken,
I Z E D. Capital E X P
it generates the same code.
S S I O N. Capital A N.
But it uses a different register.
Primary expression. This literal array literal object literal function expression class expression generator expression async fun Cheyenne expression
IX,
expression regular
RSI.
template literal call expression
If you say the else is more likely,
E R capital C A L L capital E
then puts the return right here in the middle of it.
S S I O N capital A N D capital A S Y N C R R super call import call expression arguments call expression template literal new expression new expression member expression template literal new member expression arguments ECMA International 2024 131 new target import meter left hand side expression optional expression update expression left hand side expression plus left hand side expression
That's the best the compiler can do.
expression unary expression delete
This is what I wanted,
expression type of
but with fall through.
unary expression, unary
So instead, the compiler sets up two different branches.
expression, exponentiation,
This one
expression, multiplicative
and this one.
operator, exponentiation,
So we'll run this branch, hit the end, or I'll run this one.
additive expression, multiplicative expression,
It's literally
shift expression, additive expression,
loading up the pipeline.
additive expression, shift expression, additive expression,
It's completely ignoring static branch prediction.
shift expression, relational expression, shift expression, relational expression,
Because there's no reason to split the code like that.
expression equals shift expression, relational expression, instantia of shift expression, relation,
Well, there is, in this case.
private
You know what? Whatever.
expression, equality expression, equality expression equals relational 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 expression, bitwise and expression, bitwise and expression, and equality expression, bitwise or expression, bitwise or expression, bitwise and expression, bitwise or expression, bit
If I set it up like this,
expression,
and I see the else case is more likely,
expression and bitwise or expression 32
then
2020
I can do the very first allocation and the assignment.
logical and expression coalesce expression head bitwise or
Inside of the if.
short circuit expression assignment expression
To like initialize it.
yield
If I do that,
sync arrow function left hand side expression equals assignment expression left hand side expression assignment operator assignment expression left hand side expression and equals assignment expression left hand side expression equals assignment expression left hand side expression equals assignment expression assignment expression return invalid, 6.5 static semantics. Prop name. The syntax-directed operation prop name takes no arguments and returns a string or empty. It is defined piecewise over the following productions. Property definition. Identifier reference. Return string value of identifier reference. Property definition. Assignment expression. Return empty. Property definition. Property name. Assignment expression. Return prop name of property name. Literal property name. Identifier name, return string value of identifier name, literal property name, string literal, return the SV of string literal, literal property name, numeric literal, let NBR be the numeric value of numeric literal, return to string, NBR, computed property name, assignment expression, 1. Return empty, ECMA International 2024 133, method definition, class element name, unique formal parameters, function body, get class element name, function body, set class element name, property set parameter list, function body, return prop name of class element name, generate a method, class element name, unique formal parameters, generator body, return prop name of class element name, async generator method, async class element name, unique formal parameters, async generator body, return prop name of class element name, class element, class static block 1. Return empty, class element. 1. Return empty, async method, async class element name, unique formal parameters, async function body, 1. Return prop name of class element name, field definition, class element name initializer opt 1. Return prop name of class element name, private identifier 1. Return empty, executable code and execution contexts 9.1 Environment records. Environment record is a specification type used to define the association of identifiers to specific variables and functions, based upon the lexical nesting structure of VCMA script code. Usually an environment record is associated with some specific syntactic structure of VCMA script code such as a function declaration, a block statement, or a catch clause of a try statement. Each time such code is evaluated, a new environment record is created to record the identifier bindings that are created by that code. Every environment record has an field, which is either null or a reference to an outer environment record. This is used to model the logical nesting of environment record values. The outer reference of an inner environment record is a reference to the environment record that logically surrounds the inner environment record. An outer environment record may, of course, have its own outer environment record. An environment record may serve as the outer environment for multiple inner environment records. For example, if a function declaration contains two nested function declarations, then the environment
Either way, there ends up being a penalty.
the environment record.
So everything's pointless. I'm just gonna write it up then.
Environment records are purely specification mechanisms and need not
No matter what way,
script implementation. It is impossible
it's gonna have to freaking take a branch.
to access or manipulate such a values.
Alright, so I'm just gonna like write this and get done.
ECMA International 2000
I'm done. Mess with the compiler.
won the environment record type a high.
I'll figure it out later.
Records can be thought of as existing in a simple object-oriented hierarchy where environment record is an abstract class with three concrete subclasses: declarative environment record, object environment record, and global environment record. Function environment records and module environment records are subclasses of declarative environment record. Environment record, abstract. A declarative environment record is used to define the effect of ECMA script language syntactic elements such as function declarations, variable declarations, and catch clauses that directly associate identifier bindings with ECMA script language values. A function environment record corresponds to the invocation of an ECMA script function object and contains bindings for the top-level declarations within that function. It may establish anew this binding. It also captures the state necessary to support super-method invocations. A module environment record contains the bindings for the top-level declarations of a module. It also contains the bindings that are explicitly imported by the module. It is a global environment record. An object environment record is used to define the effect of ECMA script elements such as with statement that associate identifier bindings with the properties of some object. A global environment record is used for script global declarations. It does not have an outer environment. It is null. It may be prepopulated with identifier bindings, and it includes an associated global object whose properties provide some of the global environment's identifier bindings. As the ECMA script code is executed, additional properties may be added to the
This is stupid. Like literally.
the
I can't believe I'm writing code this poorly.
specific
Because there's no point.
These
It's like a 50-50% chance the compiler will do something right.
equal 16
And even on that 50-50, when you can control it, you always have to take the penalty in one way or another.
turn true if it does and false if it
So it's on purpose. There is no optimal. Everything ends up being the same.
environment record. The
And that's the secret to performance on high performance computers.
C is true. The binding may be subsequently deleted. Create immutable binding and
Well, everyone knows that. So like, it's not new news.
environment record.
But it is, to me, when I gotta fucking sit down and go through this whole fucking standard, I gotta optimize this fucking shit.
Exception, regardless,
That's not gonna be fun.
that reference that binding, initialize binding
So I have to enter
to of an already existing
the code block, put it right above the hot block, which means when it runs the code, it's be like, jump, jump.
ECMA script
It's time to jump over every single time. Jump, 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 every time it enters.
binding in an environment
Because my trick to flip it around doesn't work anymore.
is the value for the binding and may be a value of any ECMA script.
You know what? I'm gonna let it go. Okay, whatever.
Binding cannot be set. Throw a type error exception.
I'm just gonna accept it and write some super shitty code.
5. Table
Optimize on the actual engine.
records. Continued.
I just want to like get back in the hang of things. This is annoying as hell.
Is the value of an already
'Cause I can't.
from an environment record. The
Alright, I'm done complaining now.
used to
I'll complain again later.
in strict mode
I can get some videos.
by a strict mode reference semantics. If S is true and the binding does not exist, throw a reference error exception. If the binding exists but is uninitialized, a reference error is thrown, regardless of the value of S. Delete binding. N. Delete a binding from an environment record. The string value N is the text of the bound name. If a binding for N exists, remove the binding and return true. If the binding exists but cannot be removed, return false. If the binding does not exist, return true. Has this binding? Determine if an environment record establishes this binding. Return true if it does and false if it does not. Has super binding? Determine if an environment record establishes a super method binding. Return true if it does and false if it does not. With base object. If this environment record is associated with a with statement, return the with object. Otherwise, return undefined. 9. 1. 1. 1 declarative environment records. Each declarative environment record is associated with an ECMA script program scope containing variable, constant, let, class, module, import, and/or function declarations. A declarative environment record binds the set of identifiers defined by the declarations contained within its scope. The behavior of the concrete specification methods for declarative environment records is defined by the following algorithms. 1. 1. 1 has binding. N. The has binding concrete method of a declarative environment record envrec takes argument N, a string, and returns a normal completion containing a Boolean. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. If envrec has a binding for N, return true, return false. 1. 1. 2. Create mutable binding. N. D. The create mutable binding concrete method of a declarative environment record envrec takes arguments N, a string, and E, a Boolean, and returns a normal completion containing unused. It creates a new mutable binding for the num N that is uninitialized. A binding must not already exist in this environment record for NFD is true. The new binding is marked as being subject to deletion. It performs the following steps when called. Assert. envrec does not already have a binding for N. Create a mutable binding in envrec for N and record that it is uninitialized. If D is true, record that the newly created binding may be deleted by a subsequent delete binding call. Return unused. 36. ECMA International 2024. 9. 1. 1. 1. 3. Create a mutable binding. N. S. The create immutable binding concrete method of a declarative environment record envrec takes arguments N, a string, and S, a Boolean, and returns a normal completion containing unused. It creates a new immutable binding for the num N that is uninitialized. A binding must not already exist in this environment record for N if S is true. The new binding is marked as a strict binding. It performs the following steps when called. Assert. envrec does not already have a binding for N. Create an immutable binding in envrec for N and record that it is uninitialized. If S is true, record that the newly created binding is a strict binding. Return unused. 1. 1. 1. For initialize binding. N. V. The initialize binding concrete method of a declarative environment record envrec takes arguments N, a string, and V, an ECMA script language value, and returns a normal completion containing unused. It is used to set the bound value of the current binding of the identifier whose name is N to the value V. An uninitialized binding for N must already exist. It performs the following steps when called. Assert. envrec must have an uninitialized binding for N. Set the bound value for N in envrec to V. Record that the binding for N in envrec has been initialized. Return unused. 1. 1. 1. 5. Set mutable binding. N. V. S. The set mutable binding concrete method of a declarative environment record envrec takes arguments N, a string, V, an ECMA script language value, and S, a Boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is N to the value VA. Binding for N normally already exists, but in rare cases it may not. If the binding is an immutable binding, a type error is thrown if S is true. It performs the following steps when called. If envrec does not have a binding for n, then if s is true, throw a reference error exception. B. Perform envrec create mutable binding. N. True. C. Perform envrec initialize binding. N. V. D. Return unused. If the binding for n in envrec is a strict binding, set S to true. If the binding for n in envrec has not yet been initialized, then A. Throw a reference error exception. Else if the binding for n in envrec is a mutable binding, then A. Change its bound value to V. Else A. Assert. This is an attempt to change the value of an immutable binding. B. If S is true, throw a type error exception. Return unused. Note an example of ECMA script code that results in a missing binding at step 1 is function f eval var x equals delete x 0. ECMA International 2024 137 9 1 1 1 6 Get binding value n s. The get binding value concrete method of a declarative environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language a value or a throw completion. It returns the value of its bound identifier whose name is n if the binding exists but is uninitialized. A reference error is thrown, regardless of the value of s. It performs the following steps when called. Assert. Envrec has a binding for n. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec, 1 1 1 7 Delete binding n. The delete binding concrete method of a declarative environment record envrec takes argument n, a string, and returns a normal completion containing a boolean. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Assert. Envrec has a binding for n. If the binding for n in envrec cannot be deleted, return false. Remove the binding for n from envrec. Return true, 1 1 1 8 has this binding. The has this binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 1 9 has super binding. The has super binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 1 0 with base object. The with base object concrete method of a declarative environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined, 1 1 2 object environment records. Each object environment record is associated with an object called its binding object. An object environment record binds the set of string identifier names that directly correspond to the property names of its binding object. Property keys that are not strings in the form of an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Note a regular declarative environment record, that is, one that is neither a function environment record nor a module environment record, does not provide this binding. Note a regular declarative environment record, that is, one that is neither a function environment record nor a module environment record, does not provide a super binding. 38. Copyright sign, ECMA International 2024. Because properties can be dynamically added and deleted from objects, the set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding even if the writable attribute of the corresponding property is false. Capital I. Mutable bindings do not exist for object environment records. Object environment records created for with statements 14.11 can provide their binding object as an implicit this value for use in function calls. The capability is controlled by a Boolean field. Object environment records have the additional state fields listed in Table 17. Table 17. Additional fields of object environment records. The behavior of the concrete specification methods for object environment records is defined by the following algorithms, 1 1 2 1 has binding, n, the has binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if its associated binding object has a property whose name is n. It performs the following steps when called let binding object be envrec, let found binding be, has property, binding object, n, if found binding is false, return false, if envrec is false, return true, let unscopables be, get, binding object, at unscopables, if unscopables is an object, then a let blocked be to boolean, get, unscopables, n, b if blocked is true, return false, return true, comma 1, 2, create mutable binding, n, d, the create mutable binding concrete method of an object environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates in an environment records associated binding object a property whose name is n and initializes it to the value undefined. If d is true, the new property's attribute is set to true, otherwise it is set to false. It performs the following steps when called let binding object be envrec perform. Define property or throw, binding object, n, property descriptor, undefined, true, true. D, return unused, field name, value, meaning.
Alright, so chatbot's code sucks.
Record is with environment, a boolean.
It said this is what it probably looks like. Vector, whatever.
Statement, no.
Function to push, whatever.
But if it does,
It is a red stuff. So like it says, if size is equal to capacity,
completion to be returned, ECMA.
meaning that when equal, the limit has been reached. So when it's 0, it's 0.
3, create a
If new capacity is 0, it's instead 1.
mutable binding.
Otherwise, it sets capacity times 2.
Record is never used.
It does new data,
Comma 1, 2, for initial
re-alloc,
n,
passing data.
concrete method of an object environment record envrec takes
If data wasn't assigned, if it's the first entry, it doesn't hold anything.
normal completion completion. It is used to
It's passing a null, right?
binding of the identifier whose name is n to the value v. It performs the following steps when
I think so.
binding n,
Unless it always assigns something the first time,
2,
which I really doubt.
n, v, s. The set mutable binding concrete method environment record envrec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to set the value of the environment records associated binding objects property whose name is n to the value v. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let binding object be envrec, let still exists be, has property, binding object, n, if still exists is false and s is true, throw a reference error exception, perform, set, binding object, n, v, s, return unused, comma 1, 2, 6 get binding value, n, s, the get binding value concrete method of an object.
Wow, that's lame.
Rec takes argument.
It just like safely allocates memory dynamically.
Completion containing an ECMA script language value or a throw completion.
I hate everything.
Of its associate
Everything is stupid.
whose name is n. The property should already exist, but if it does not, the result depends upon s. It performs the following steps.
I'm losing brain cells.
vrec has property, binding object, n,
Thinking this way,
n, a
having to do things.
undefined. Otherwise, throw a reference error exception for
Without intention, because intention doesn't make a difference.
1, 2,
Wow, everything is pointless.
n, the delete binding concrete method of an object environment recording
This won't be.
n,
When I get this thing done and optimized,
and containing a built
I'm gonna optimize the fuck out of it.
on to properties
I'll make my own standard.
Attribute had the value true. It performs the following steps.
And I'll make a new C language. Not C, JavaScript.
Binding for
It could replace C++.
to initialize.
C++ is garbage.
Hence, this specification does not explicitly track the initialization an object environment records. 2. Let binding object be envrec. Return binding object N40.
I hate all this stuff added to JavaScript.
1. 2. 8 has this binding. The has this binding concrete. Environment record envrec takes no arguments and
I need to like keep my standard super clean
comma 1. 1. 2. 9 has
and implement everything, but in a better way.
method of an object environment record envrec takes no arguments and returns false. It performs the following steps.
I don't know. That'll be more fun than this.
1.
I didn't get this done.
Object. The with base object concrete method of an object environment record envrec takes no arguments and returns an object or undefined. It performs the following steps when called. If envrec is true, return envrec. Otherwise, return undefined. Comma 1. 3. Function environment records. A function record is a declarative environment record that is
Oh, it sounds really loud.
full scope of a function.
My ears.
Is not an arrow function.
Okay, anyways.
The function
It sounds like I'm talking into a fan.
its function
This is a fan turned on.
also contains the state that is used to perform super method invocations from within the function. Function environment records have the additional state.
I'm not gonna call realloc
Table 18.
because I need an aligned allocation.
Note, object environment records do not provide a this binding. Note, object environment records do not provide a super binding. Field name, value, meaning, this value, an ECMA script.
And
So this value used
the point is to be null on first entry.
status, lexical, initialized, or uninitialized. If the value is lexical, this is an arrow function and does not have a local this value. Function object, an ECMA script. Function object, the function object whose invocation
Capacity needs to be 1,
target, an object or undefined. If
like the number 1.
is created by the internal method, is the value of the new target parameter. Otherwise, its value is undefined. Copyright sign, ECMA International 2024, 41. Function environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for has this binding and has super binding. In addition, function environment records support the methods listed in Table 19. Table 19. Additional methods of function environment records. Method, purpose, bind.
I don't want to multiply by 2.
Initialized, get this binding, return the value of this environment records this binding. Throws a reference error if the this
Each time, so maybe I like
return the object that is the base for super property accesses bound in this environment record. The value undefined indicates that such accesses will produce runtime errors. The behavior of the additional concrete specification methods for function environment records is defined by the following algorithms. Comma 1. 1. 3. 1 bind this value.
man, the keyboard is like not.
The method of a function environment record envrec takes argument v, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called assert. envrec is not lexical. If envrec,
Multiply by 2 here.
throw a reference error exception. Set envrec to v, set envrec to initialized, return v, comma 1, 1, 3. 2 has this binding. The has this binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. Otherwise, return true 9, 1, 1, 3. 3 has super binding. The has super binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. If envrec is undefined, return false. Otherwise, return true, 1, 1, 3. 4. Get this binding. The get this binding concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called.
I can assume
Not lexical. If envrec is
the capacity size will be 0
option.
initially.
Rec. 42. ECMA International 2000.
But this block would only need to be executed in the else case.
The get super base
Will the compiler at least optimize for that?
envrec takes no arguments and returns either
I can't give it up. I gotta figure something out.
not or under
This is so annoying.
completion. It performs the following steps when called. Let home be envrec. If home is undefined, return undefined. Assert home is an object. Return home, 1, 1. 4. Global environment records. A global environment record is used to represent the outermost scope that is shared by all of the ECMA script elements that are processed in a common realm. A global environment record provides the bindings for built-in globals. Clause 19. Properties of the global object, and for all top-level declarations. 8, 2, 9. The 8th of February 2011, that occur within a script. A global environment record is logically a single record, but it is specified as a composite encapsulating an object environment record and a declarative environment record. The object environment record has as its base object the global object of the associated realm record. This global object is the value returned by the global environment records get this binding concrete method. The object environment record component of a global environment record contains the bindings for all built-in globals. Clause 19, and all bindings introduced by a function declaration, generator declaration, a sync function declaration, a sync generator declaration, or variable statement contained in global code. The bindings for all other ECMA script declarations in global code are contained in the declarative environment record component of the global environment record. Properties may be created directly on a global object. Hence, the object environment record component of a global environment record may contain both bindings created explicitly by function declaration, generator declaration, a sync function declaration, a sync generator declaration, or variable declarations and bindings created implicitly as properties of the global object. In order to identify which bindings were explicitly created using declarations, a global environment record maintains a list of the names bound using its create global var binding and create global function binding concrete methods. Global environment records have the additional fields listed in Table 20 and the additional methods listed in Table 21. Table 20. Additional fields of global environment records. Field name, value, meaning, object record, an object environment record. Binding object is the global object. It contains global built-in bindings as well as function declaration, generator declaration, a sync function declaration, a sync generator declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, a sync function declaration, a sync generator declaration, and variable declaration bindings. Var names, a list of strings. The string names bound by function declaration, generator declaration, a sync function declaration, a sync generator declaration, and variable declarations in global code for the associated realm. Copyright sign, ECMA International 2024, 43. Table 21. Additional methods of global environment records. Method, purpose, get this binding, return the value of this environment records this binding, has a declaration, N, determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generator declaration, A sync function declaration, or a sync generator declaration, has lexical declaration. N determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property. N determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var. N determines if a corresponding create global var binding call would succeed if called for the same argument. N can declare global function. N determines if a corresponding create global function binding call would succeed if called for the same argument. N create global var binding. N D used to create and initialize to undefined a global var binding in the component of environment reco.
Okay, so the only thing the compiler optimizes
Object property will have attribute values.
is the standard if-else.
When is the bound name?
Once you put it in a loop, you try to do something tricky, that's when they fuck with it.
Create mutable binding followed.
Because now at least,
Allows var declarations.
if not equal, it enters a true,
Function binding. N V
which means it's going to do this code. It'll take the jump only when it has to take the jump, which is when they're equal,
object
and it says jump equal.
appropriate.
So compare jump equal L2 only
The initialization value. If the Boolean
when it's true that arg count is equal to argpaths.
equivalent
Otherwise, fall through. Do not jump, do the move, then return.
special treatment
So here's the move, and return. It's right here.
chords as defined by
So it doesn't do the else. This is what I wanted in the other case, but it won't do it.
the has binding concrete method of a global environment.
And it totally seems intentional,
And N
because right here, it makes total sense what it's doing.
or a throw completion. It determines if the argument identifier is one of the identifiers
But the other case, there's something funky going on.
when
It
called
has code smell.
BENV rec. If DCL rec has binding, N
So in the else case,
true. Let object
which means they are equal, so when arg count is equal to argvaz,
1
then it takes the else. So most of the time, it's gonna not take the else, because every time it makes a new allocation, it's gonna allocate twice the size, which means it will not enter the else until it has reached the limit.
binding for the men that is
So since it will not reach the limit, this is how simple branch prediction is. Do you see how simple this is? It's not that difficult.
24 declare
It's the simplest thing.
binding for N must not already exist
To do a whole engine though, it's not just about branch prediction,
is marked as being subject to
it's about data structure
following steps
and caching
rec BENV rec
and like everything else. This is just a small thing.
type error accept
The code is like,
DCL rec create mutable binding D, 1 1 4 3 create a mutable
I can't even guess. It is a big part of it, I guess.
binding
But not,
amendment record ENV rec takes up
maybe
string
it's not half.
Boolean and returns either a normal completion containing unused or a throw. It creates a new immutable binding for the name
The code is maybe 35%
exist in this environment record
important compared to
marked as a strict binding.
everything else
Performs the following steps when called let
for performance.
ENV rec. If DCL rec has binding, N is true.
It's not 50,
Option return DCL
but it's not 25,
binding
so it's maybe 35%
1 4 4
importance.
NV the initialize binding concrete method of a global environment record
So I don't know. Anyways,
a string and V
now the else case is actually the else case, which means if I multiply the array by twice to like double it,
the bound value of the
so if it enters on 20, reaches the limit,
value V in uninitialized
it's gonna be 40.
must already
So that means it's gonna enter
performs the following steps
this true case 20 times again until it hits the else.
true then a return DCL
So that means if I set up the code with a simple if else,
Assert. If the binding exists,
it'll look like this.
environment record. Let objrec be envrec. Return. Objrec initial.
The difference between this and what I was doing
1.
is I want the code to fall through.
V.
I want to go zip the whole thing.
Method of a global environment record envrec takes arguments n, a string.
Alright, doesn't matter, whatever.
A script language.
So like this is a totally different control flow.
It's either a normal
So at least the compiler does this,
store it.
like correctly.
It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding.
At least.
True. A type error is thrown. A property name then
It really doesn't do much correctly.
it does not or is not currently
So right here, where chatbot, we get this code.
following steps when called
If size is equal to capacity,
DCL rec has binding n
I want to change this
return
to does not equal capacity.
n v s let objrec be env rec
Okay, what's this look like?
objrec set mutable binding n
In the code.
s comma 1
Alright, this is chatbot's code.
get binding value.
I want to see what this looks like.
The get binding
Chatbot decided to put
global environment record env rec takes arguments n, a string, and s, a boolean, and returns either a normal
the code like this,
a script
which means it enters here
it returns the
only when it's true that it reached capacity and needs to resize. So this is like the cold block, and after it is the hot block.
writable.
What I'm saying is I'm gonna do this.
It performs the following steps when called let DCL rec be env rec if
I'm gonna set it up to put the hot block on top
return
like this.
value n s ECMA International 2024 1
Put the cold block on the bottom.
objrec be env rec return objrec get binding value n s comma 1 1 4
So resize.
n the delete binding concrete method of a global environment record env rec takes argument n, a string, and returns either a normal boolean or a
Right, so I'm saying,
only delete binding
or I want to check if this is more optimal.
subject to deletion. It performs the following steps when called let DCL rec if
Than this or whatever. And then I'll kind of know.
turn
I don't have to check it again. I'll just assume from that point on.
objrec be env rec check tbob
You're gonna want to check it, guesstimate, figure out, and then guesstimate other things.
true
I don't have to keep checking it. I just want to get a solid answer
ding
so I can memorize it. Because I don't want to, like, it's a waste of time to not figure something out and have to fucking deal with it all the time.
1 4 8 has this binding concrete method of a global environment record env rec takes no arguments and returns true. It performs the following steps when called return true, comma 1 1 4 9 has super binding the has super
So pieces in.
of a global environment record env rec takes no arguments and returns false. It performs the following steps when called return false, comma 1 1 4 1 0 with base object. The with base object concrete method of a global environment record env rec takes no arguments and returns undefined. It performs the following steps when called return undefined 9 1 1 4 1 1 get this binding. The get this binding concrete method of a global environment record env rec
So X and Y.
the normal completion containing an object. It performs the following steps when called return env rec.
Place count as food. Or count for as.
Global environment records always provide this binding. Note, global environment records do not provide a super binding. 9 1 1 4 1 2 has var declaration. N the has var declaration concrete method of a global environment record env rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called. Let var declared names be env rec. If var declared names contains n, return true, return false, comma 1, 1, 4, 1, 3 has lexical declaration, n, the has lexical declaration concrete method of a global environment recording.
Alright, so this is where like assigns
Boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called. Let dcl-rec be env rec. Return. dcl-rec has binding, n, 1, 1, 4, 1, 4 has restricted global property, n, the has restricted global property concrete method of a global environment record env rec takes argument n, a string, and return.
Alright, so let's pretend, whatever, that this is like assigning next whatever.
And identifier is the name of a
Using location, this whatever.
global lexical binding. It performs the following steps when called. Let obj-rec be env rec. Let global object.
This is sometimes.
Let existing prop be global object. N. If existing prop is undefined, return false. If existing prop is true, return false. Return true, comma 1, 1, 4, 1, 5 can declare global var. N. The can declare global var concrete method of a global environment record env rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called. Let ob.
Never cares about the word.
Let global object.
Whatever.
Let has property b. Has own property, global object, n. If has property is true, return true. Return is extensible, global object. Note properties may exist upon a global object that were directly
So this has
using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable
let's flip that around.
object. The global property undefined is an example of such a property. ECMA International 2024 146.
Alright, so this is chatbots, whatever way.
4, 1, 6 can declare
The cold block is always jumped over.
function concrete.
So the other way, I'm gonna try it.
Record env rec takes argument.
Because I didn't figure out the other thing. At least I can figure out this, hopefully.
It determines
So I figured something out.
global function binding call would succeed if called for the same argument, and it performs the following steps when called. Let obj-rec be env
Because there are so many things I gotta figure out.
global object.
Just figure out something for now.
Find. Return is extensible, global object. If existing prop is true,
So instead, it's my code, or my whatever.
existing prop is true and existing prop has attribute values, true, enumerable, true.
I'm planning to
Return false, comma 1, 1, 4, 1, 7 create global.
this is work being done.
D. The create global
It's there,
environment
and that's here.
takes arguments n
So I'm gonna take,
and returns either a normal completion containing unused storage,
oh, I copy that. I'll take this code
immutable
and just paste it in else.
environment record and records the bound.
And see what the output is.
If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called. Let obj-rec be env rec. Let global object be obj-rec. Let has property b. Has own property, global
And no more assembly after this. I'm done with assembly for today.
immutable.
Just C programming.
Property is false and extensible is true. Then a perform. Obj-rec create mutable binding. N. D. B perform. Obj-rec initialize binding. N. Undefined. If env-rec does not contain n, then a append enter en.
So X and Y.
Return unused.
X is chatbot's code.
8 create global function
Why
binding.
is it not returning?
V. D. The create global function binding con. Create method of a global environment.
Okay, why does the compiler get to do the optimization I wanted, but I can't do it?
And returns either.
That's not fair.
Containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated.
Okay, that's a big difference in code size.
It is 2, 3, 4, 7, 8. Replaced. It performs steps when called let
24 instructions.
let global object bob.
What is this?
Existing prop be global.
It's supposed to have a return,
Prop is undefined or
right?
then a let
So it's like a backup?
v
That's not.
true d else a let desk be the property descriptor v perform define property or throw global object n desk perform
Alright, so chatbot's code.
global object n v false if envrec does not contain n then a append enter envrec return unused 48. ECMA International 2024. Note global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls, 1, 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide
Okay, so first off,
target binding that exists in another environment record. Module environment
chatbot's code is more bloated.
record methods listed in table 16 and share the same
On the left, compared to the right.
forget binding value, delete binding,
Assembly 101.
binding. In addition, module environment records support the methods listed.
So for a simple if-else, it does make a difference.
Methods of module environment records the behavior of the additional
I'll just clean it up for a second.
module environment records are defined
Alright, so this is the work it does to like assign the next application.
NS the get binding value concrete method.
Like, just call it assign.
The envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an e
I'll make it define.
language a value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called assert. S is true, assert. envrec has a bind for n. If the binding for n is an indirect binding, then a let m and n2 be the indirection values provided when this binding for n was created. B let target envbm. C if target env is empty, throw a reference error exception. D return target env get binding value. N2 true. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note S will always be true because a module is always strict mode code 9, 1, 1, 5. To delete binding, n. The delete binding concrete method of a module environment record is never used within this specification. Method purpose create import binding n, m, n2 create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and n2 is a binding that exists in m's module environment record. Get this binding, return the value of
I don't know. I don't really care if I like get upset or whatever, or if I bitch.
140
Because I spent 2 years making this stupid engine.
used within strict code.
I'm going to be investing a considerable amount of time in this.
Applied to a reference
So this is totally, extremely serious to me.
3,
So that's why I'm going to bitch, and I don't care.
1, 5, 3
I just don't care.
has this binding concrete method of a module in
Like, this isn't a game. This is really serious.
and returns true. It
I'm literally going to compete with V8 and Chrome,
forget this binding.
and I plan to crush them.
Record envrec takes
So, if I bitch and complain, I don't give a fuck.
following steps when called return undefined, 1, 5.
All I care about is winning.
And 2. The create
And that's gonna happen.
module environment.
Otherwise, I wouldn't be investing this much time.
A module record. And N2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name, and a binding must not already exist in this environment record for N2 is the name of a binding that exists in M's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called assert. envrec does not already have a binding for N. Assert. When M is instantiated, it will have a direct binding for N2. Create an immutable indirect binding in envrec for N that references M and N2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9. 1. 2. 1 get identifier reference. env name strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal complete in containing a reference record or a throw completion. It performs the following steps when called if env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty. Else. 150. ECMA International 2024. Note, module environment records always provided this binding. AB, let out to be env. Return, get identifier reference.
If Chrome, Google,
1. 2. Declarative environment, E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs
if Google were to give me
new declarative environment record containing no bindings, set env to E, return env, 1, 2, 3 new object environment, O,
whatever payout I deserve based on whatever they collected.
and so, an object, W,
Yeah, no, whatever.
an environment record,
They're on their own.
returns an object environment record. It performs the following steps when called let be a new object environment record. Set env to O. Set env to
Well, they'd have to give to everyone, not just me.
1, 2, 4 new
Billions of dollars back in the pocket of everyone. They surveillance on.
takes arguments F,
That's not gonna happen.
function object, and new target.
But what will happen is I'm gonna compete,
The function environment
and I'm coming in hot
VB a new
and heavy.
environment record containing no bindings. Set
Crush.
F is
I gotta focus.
env to lexical else. Set env to uninitialized. Set env to new target. Set env to F. Return env.
Alright, so like, check out maybe this code.
Environment G. This value, the abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called let objrec be new object environment, G, false, null. Let dclrec be new declarative environment, null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to dclrec. Set env to a new empty list. Set env to null. Return env.
Okay, let's switch it to same.
6 new module environment, E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called let env be a new module environment record containing no bindings. Set env to E. Return env. ECMA Internatio. Now 2024 151. 9
Alright, so check out this code.
records. A private
Looks like this.
mechanism used to track
It takes this only when it's true
declarations
that it has to reallocate. After that, it assigns whatever was passed in. So it needs to resize and then assign it. So chatbot set it up
Such a class
to resize before assigning.
create
So every time it runs, it has to test and jump over this code.
and in table 23. Table 20
Because the compiler is too stupid to rewrite it. The compiler doesn't know.
meaning outer private environment.
So I wrote it like this.
Record or null. The private environment
If not equal,
null if the class with which this private environment
it means it hasn't reached a limit.
contained in any other class. Names.
Otherwise,
The private names declared.
it'll assign next allocation.
2. 1 private environment record operations. The following abstract operation
Actually, do this.
application to operate upon private environment record.
Else, it'll resize, copy, reallocate,
Outer
then assign the next allocation.
private environment takes
The difference is that the fall through case will be here on the top, but not equal. So if the rate is like 100 till the next resize,
return the
that's 100 entries, 100 less jumps.
names.
Chatbot, its code is into a 100 extra jumps.
The abstract operation resolve private
That's a lot of jumps,
arguments.
especially if the allocation gets larger and larger and larger.
Identifier.
It incurs a penalty for every single jump. Even if it's predicted, it incurs a penalty.
Private name.
This one, no penalty. There is no penalty for not taking a jump.
NVB preview.
It just took the amount of time to decode it and then do nothing. It's so much faster to not take the jump. So I changed the code. So we gotta like check the output. I'll paste it back.
MA script must be associated with a realm.
I forgot that it does have to actually assign the next one. So I don't know, now I have it.
An ECMA script global.
So now it's like complete.
The ECMA script
Alright, now the code's bigger. That makes more sense.
environment.
That's why it's so much smaller.
Associated state and resources. A realm is represented in this specification as a realm record with the fields specified in table 24.
So at least I tested this. I can't test the other crap. It doesn't work. So I tested this at least.
Record fields.
Alright, so now the code looks like this.
Higher. Intrinsics. Global object. Global ENV. Template map. An object or undefined value. An agent signifier. A record whose field names are intrinsic.
Oh man,
A list.
I hate the compiler.
A template literal. Parse node.
That's some bullshit.
F. The agent that owns this realm. The global object for this realm. Capital T. The global environment for this realm. Meaning, the intrinsic values used by code associated with this realm. A list of records, with fields are a string and a module record. Note 1: once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is
It unoptimized it. What the fuck is that? Oh, not me more annoyed. I'm so angry.
in realm records is only used when
Stupid fucking
expression in a context where there is no active
fuck's sake.
field reserved for use by hosts that need to associate additional information with a realm record. Template objects are
Alright, I'm gonna do something different.
realm using its realm
Instead,
value is a parse node that is a template literal. The associated template object
I'm gonna do foobar
tag function, a map from the specifier strings import
9
module record.
plus equal
Different records with the same 9, 3
this.
realm. The abstract operation create realm takes no arguments and returns a realm record.
Let's see what it looks like.
Performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec.
It's different. That's cool.
Realm rec to undefined.
Now it's
Undefined. Set realm rec to a new empty list. Return realm rec.
this is some bull right here. This is bullcrap.
9, 3, 2 create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column
GCC and suck a quad.
fully and recursively populated with property values.
The hell? What the fuck? It unoptimized the code.
Values a newly created
It unoptimized the code. You heard me correctly. I'll turn off the fan.
steps, length, name, slots, realm reg, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if a
So GCC,
specified internal slot
being the crap hole that it is,
of the function's
when you write the code,
investigation of the intrinsics and their properties must be ordered. Dependencies upon objects that
for better performance,
perform at rest. Richted function properties.
it unoptimizes the code.
Comma 3.3 set realm global object. Realm reg. Global
Here's the code, whatever. This.
act operation set realm global object takes arguments realm reg.
I'm doing next allocation, copy.
EJ, an object or undefined.
The original one, I'm doing copy, next allocation.
Unused. It performs the following steps when called if global OBJ is undefined. Then, let intrinsics be
So each of these show up once.
to ordinary object create, intrinsics, assert, global OBJ.
The copy of the next one.
This value is undefined.
So the output looks like this.
BJ, set realm rec to global OBJ, let new global env be new global environment, global OBJ, this value, set realm rec to new global env, return unused, comma 3.4 set default global bindings, realm rec, the abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion contain.
Now, which code is faster?
It performs the
This one
global be realm rec for each property of the global object
or this one on the left?
do. A let name be the
The one on the right.
property name. B let desc be the fully populated data property descriptor for the property containing the specified attributes for the property
Okay, so what I'm gonna do,
in 19.2, 19.3, or 19.4 the value of the attribute is the corresponding in
because the code on the right,
C perform
it doesn't end up
global name dec
assigning the next allocation
execution context.
in the else case.
Execution context is a specification device that is
So this needs to be placed here.
of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specific
So this is next allocation.
text of the surrounding agent. The execution context stack is used to track execution context.
I'm gonna take the code inside of it
Execution context is always the top element of this.
and paste it there.
New execution context is created whenever control is transferred from the executable code associated with the currently running execution
But I'm gonna modify it so it doesn't look the same.
with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly
So let's just say it's at like 9.
text is pushed onto the stack and becomes the running execution context. An execution context
And for some reason, I know the value to set,
state is
and it's this.
the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 20
Or I'll set this
state components for all execution contexts. Component per
entry pin for some reason.
state. Any state needed to perform, suspend, and resume evaluation associated with this execution context. Function. If D
Alright, so let me see what this says.
is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMA script
Oh, that's bullshit.
module. The module record or script record from which associated code originates. If there is no originating script or module, as
Alright, watch this.
functional execution
This is before, right?
host defined
More optimal.
value is null. Evaluation of
So now, I'm assigning the next allocation.
suspend
because I added code after. Technically, it's not the same next one. Just an example.
context
Because when I do the same code, it does some funny business.
comments evaluating its code.
So I'm going to paste.
Suspended execution context
So as you can see,
execution context and continue.
the X routine is the same. Chatbot's code.
Transition of the running execution context state
But what is the routine that
occurs in
I adjust to look like?
first out manner. However,
Okay, the code's bigger.
script features require non-LIFO transitions of the running execution context. The
Okay, so doing this,
component of the run
the code's bigger.
realm record. The value of the function
It makes sense. It's doing more work.
context is also called the act.
So what's inside of next allocation?
A script code execution contexts have the additional state components listed in table.
I'll just copy paste it so you can see it.
Additional state component
So this is next allocation.
execution contexts component purpose. Let
I'll just delete it.
the environment record used
So let's paste it.
by references made by code within this
Alright, so I need to put it here.
Variable environment identifies the environment record that holds bindings created by variable statements within this execution context. Private environment identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always
Alright, so I'm gonna put next allocation here.
execution contexts representing the
This is deleted. So there you go. That's next allocation.
it's listed in table 27.
And I'm also gonna put it here.
24,155. Table 27.
Do you see the difference between these two?
Contexts. In most situations, only the running execution context, the top of the execution context stack, is direct.
It's an array and dice.
Rhythms within this spec.
1, 2, 3.
Hence, when the term
XOR
environment
a value.
are used without
The same code signature.
the running execution
Okay?
an execution context
But with different values.
mechanism and need not correspond to any particular artifact of an EC.
So I'll copy paste this. Whatever, again.
Possible for ECMA script code to directly access or observer an execution context.
So here's the output, okay?
A module
This is what annoys me. This is what it's doing with the other one. This is easier to explain.
is a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called if the execution
So I'm paste it here.
return null. Let EC be the topmost execution context on the execution context stack whose script or module component.
So as you can see,
No such
same thing,
text exists.
right?
Return null.
Look at the control flow.
Script or module, for
This has one jump. One jump.
abstract operation resolved by
A single jump. An optimal jump.
environment
In this code, it optimally
normal completion containing a.
only does the assignment when it has to.
It is used to determine the binding of name env can be used to explicitly
It can skip hundreds of jumps.
for the binding.
Way faster.
Is the following step
Chatbot's code has one jump,
undefined.
two jump,
env to the run
and then an unconditional jump. So 3 jumps.
assert
So like 2.5 jumps.
record
Actually, maybe 4 jumps.
production that is being
I think unconditional jumps are twice as slow as conditional.
true. Else let strict be false. Get identifier reference.
I gotta double check that
The name strict
because I don't know, whatever.
environment. The abstract
I read some stuff, but I'm not sure.
arguments and returns an environment record. It finds the environment record that currently supplies the binding of
So this is a sub-optimal.
let env be the running execution context's lexical environment too. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 1.
Okay, so what I'm gonna do now,
International 2024. Note the result of resolve
you see here, 96.
record whose field is name ABCDE. Let exists BENV has this binding.
The same address.
Return
RDX plus 96.
ENV.
RDX plus 96.
Outer is not null. Set ENV to outer. Note the loop in step 2.
Okay, so now what I'm gonna do,
environments always ends with the global environment, which has
Is I'm gonna take
4.4 resolve this binding.
the assign next code, whatever,
No arguments and returns either a normal completion contain and
and paste it into the else. Ta-da!
binding of the keyword.
Okay, so let's say this was actually correct. This is just like gibberish.
It
But if it did assign the next node,
env
now both these lines are the same.
get this bind
So now it's like the routine's complete.
target.
It either has enough memory, it just assigns it, or it doesn't, and it does resize, duplicate, relocate, then it assigns it.
Environment of the
Okay, so I'm gonna check the output.
It performs the following steps when called. Let envrec beget this environment. Assert envrec has a field. Return envrec.
Is it gonna give me the output?
Global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.
There we go.
Current realm be the current realm record. Return
Now this is the output.
jobs and host operations to enquire jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script compute
Okay, see these two right now? Watch.
for execution by ECMA script host environments in a particular agent. This specification describes the
Oh, that's odd.
job.
Why does the right side have 2 extra jumps now?
N E U
Huh.
I
I wonder.
Z A T I
Chatbot used the word malicious.
I S
It was funny. So I'm gonna say malicious.
and host enquire timeout job to schedule
Is this GCC
specification of
being intentionally malicious?
the scheduling of jobs.
By intentionally bloating the code when it's more optimal?
Such operations accept a job abstract closure and a realm. A realm record.
I'm gonna adjust this index by 1.
If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm.
Alright, so now it's up 1. So it's like a different address.
Then the
Check the output.
ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution
Huh. It still kept the same thing.
actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing it.
Alright, mate, 9.
ECMA International 2024 157. Note 1 host environments are not required to treat jobs uniformly.
What's it like now?
For example, web
Again, that's odd.
promise handling jobs is a higher priority than other work. Future features may add jobs that are not treated at such a high priority.
It looks like it still takes 2 jumps.
Script record, a module record, or null, is the active script or module if all of
What if I assign the same address,
script or module.
but a different source variable?
Module is a script record or module record. Let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMAS script code if all of the following conditions are true. The execution context
Would you look at that?
realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements.
It's optimal again.
Job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enquire by the host may have additional host-defined context. To propagate
That's some crap.
should not
That's intentional.
directly. Instead, Use host make job callback and host call job callback. Job
I'm not even gonna bother to ask chatbot.
table 28. Table 28.
Chatbot's gonna say it's not on purpose.
5.2 host make
Totally on purpose.
callback. The host defined abstract operation host make job callback takes argument callback, a function object, and
Alright, so I've learned my lesson.
of host make
I'm not gonna write it optimal.
following requirements.
I'm gonna write it shitty, because there's no point right now.
Note to host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context.
No fucking point.
Specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a call
Literally, no point.
like a promise
Alright, so I'm gonna get back and finish this up, whatever.
pushes its own execution context,
But you know what has a point? What has a point
HTML specification,
is finishing up my JavaScript engine.
HTML.spec.whatwg.org.
In meeting the entire standard to show it can be done.
Incumbent settings object for promise callbacks.
And then upgrading JavaScript
Callback, a function object. The function to invoke when the
to the year 2025 and beyond,
empty field reserved for use by host.
pulling it out of the depths of 32-bit 1994 computing,
Make job callback performs the
because it's 2025, people.
turn the job callback record. Callback, empty.
So I can't change GCC right now,
Use the default implement
but I can change JavaScript
back, 5.3 host call job callback.
and change.
V. Arguments list. The host defined abstract operation host call job callback takes arguments. A job callback,
I'm trying to think of something clever.
an ECMA script language value, and arguments list. A list of ECMA script language
I don't know. I'm gonna turn all that change into big money,
script language
like paper money.
completion and implementation of
That's what my sister used to call paper money.
it must
Big money.
job callback.
Not change. Big money.
Implementation of host call job callback performs the following
I can get some water.
is
I'm done trying to optimize now.
true. Return
There's no point.
callback. V.
I'm not gonna fight the system.
ECMA
I have a system to fight,
must use the default
so I gotta pick my battles wisely. Or choose them wisely, whatever the fuck it is.
job realm. The host defines
I gotta stay on track from now on.
generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to class expression, class tail. Let value be. Class definition evaluation of class tail with arguments undefined and name. Set value to the source text matched by class expression. Return value. Point 5 contains, 5.1 static semantics. Contains. The syntax directed operation contains takes argument symbol, a grammar symbol, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of contains. For each child of this parse node, do A if child is an instance of symbol, return true. B if child is an instance of a non-terminal, then I let contained be the result of child contains symbol. 2. If contained is true, return true. Return false. Function declaration, function binding identifier. Formal parameters, function body, function, formal parameters, function body, function expression, function binding identifier, formal parameters, function body, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, generator expression, function binding identifier, formal parameters, generator body, async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, async generator expression, async function binding identifier, formal parameters, async generator body, async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, ECMA International 2024 123, async function expression, async function binding identifier, formal parameters, async function body, return false. Note 1 static semantic rules that depend upon substructure generally do not look into function definitions. Class tail, class heritage opt, class body, if symbol is class body, return true, if symbol is class heritage. Then, if class heritage is present, return true, otherwise return false 3. If class heritage is present, then, if class heritage contains symbol is true, return true. Return the result of computed property contains of class body with argument symbol. Class static block. Static. Class static block body. 1. Return false. Arrow function. Arrow parameters equals. Concise body. If symbol is not one of new target. Super property. Super call. Super, or this. Return false. If arrow parameters contains symbol is true. Return true. Return concise body contains symbol. Arrow parameters, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Let formals be the arrow formal parameters that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Return formals contains symbol. Async arrow function. Async arrow binding identifier equals. Async concise body. If symbol is not one of new target. Super proper, high. Super call. Super, or this. Return false. Return async concise body contains symbol. Async arrow function. Capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, equals. Async concise body. If symbol is not one of new target. Super property. Super call. Super, or this. Return false. Let head be the async arrow head that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. If head contains symbol is true. Return true. Return async concise body contains symbol. 124. ECMA International 2024. Note 2 static semantic rules that depend upon substructure generally do not look into class bodies except for property names. Note 3 static semantic rules that depend upon substructure generally do not look into static initialization blocks. Note 4 contains is used to detect new target, this, and super usage within an arrow function or async arrow function. Property definition. Method definition. If symbol is method definition, return true. Return the result of computed property contains of method definition with argument symbol. Literal property name. Identifier name. Return false. Member expression. Member expression. Identifier name. If member expression contains symbol is true. Return true. Return false. Super property. Super. Identifier name. If symbol is the reserved word super. Return true. Return false. Call expression. Call expression. Identifier name. If call expression contains symbol is true. Return true. Return false. Optional chain. Identifier name 1. Return false. Optional chain. Optional chain. Identifier name. If optional chain contains symbol is true. Return true. Return false. 5.2 Static semantics. Computed property contains. The syntax-directed operation computed property contains takes argument symbol, a grammar symbol, and returns a boolean. It is defined piecewise over the following productions: class element name, private identifier, property name, literal property name, return false, property name, computed property name, return the result of computed property name contains symbol. Method definition: class element name, unique formal parameters, function body, get class element name, function body, set class element name, property set parameter list, function body, return the result of computed property contains of class element name with argument symbol. Generator method, class element name, unique formal parameters, generator body, return the result of computed property contains of class element name with argument symbol. ECMA International 2024 125. Async generator method, async class element name, unique formal parameters, async generator body, return the result of computed property contains of class element name with argument symbol. Class element list, class element list, class element. Let in list be computed property contains of class element list with argument symbol. If in list is true, return true. Return the result of computed property contains of class element with argument symbol. CL, as element, class static block 1. Return false. Class element 1. Return false. Async method, async class element name, unique formal parameters, async function body 1. Return the result of computed property contains of class element name with argument symbol. Field definition, class element name initial is erupt. Return the result of computed property contains of class element name with argument symbol. Point 6 Miscellaneous. These operations are used in multiple places throughout the specification. 6.1 Runtime semantics. Instantiate function object. The syntax-directed operation instantiate function object takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMA script function object. It is defined piecewise over the following productions: function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital O, B, J, of function declaration with argument CNV and private env, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital O, B, of generator declaration with argument CNV and private env, async generator declaration, async function binding identifier, formal parameters, async
Alright, so
function, formal
why is branching a big deal?
turn, capital I, N, S, T, A,
Why does it matter?
I, A, T, E, capital
Alright, I'm gonna paste it into chatbot.
C,
I have a feeling chatbot's gonna lie.
E, R, A,
If it does, I'm gonna accept that it's lying and not argue with it.
N, C, T, of async generator declaration with argument CNV and private env, 26, ECMA International 2024, async function declaration, async function,
I'm gonna tell chatbot
formal
I want a detailed rundown.
async function, formal parameters, async function
Instruction by instruction count.
object of async function declaration with argument CNV and private env8, 6, 2 runtime semantics, binding initialization, the
Of which will be faster.
function binding initialization takes arguments value, an ECMA script language value, and environment, an environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Binding identifier. Identifier. Let name be string value of identifier. Return. Initialize bound name. Name. Value. Environment. Binding identifier. Yield. Return. Initialize bound name. Yield. Value. Environment. Binding identifier. Await. Return. Initialize bound name. Await. Value. Environment. Binding pattern. Object binding pattern. Perform. Require object coercible. Value. Return. Binding initialization of object binding pattern with arguments value and environment. Binding pattern. Array binding pattern. Let iterator record be. Get iterator. Value. Sync. Let result be completion. Iterator binding initialization of array binding pattern with arguments iterator record and environment. If iterator record is false, return. Iterator. Lose. Iterator record. Result. Return result. Object binding pattern. 1. Return unused. Object binding pattern. Binding property list.
Chatbot said
Perform.
the compiler aims for 50-50%
With argument.
because that's the best chance because it doesn't know.
Node
This function is a literal 50-50% chance.
and value.
This function at the top
Meta lists of some non-strict functions. See
is 50% chance,
11.
and then it splits up down to 25%,
Prior to
and then 50%.
ECMA International 2000.
This one has odds of being worse performance.
Binding rest prop.
It's not 50-50. It's 50-50 based on
Binding initial
the multiple states or whatever.
value. Environment. And exclude.
So it degrades.
Binding pattern. Binding property list. Binding rest property. Let exclude.
Alright, see what Chatbot says.
Property binding initialization of binding property list with arguments value and environment. Return. Rest binding initialization of binding rest property with arguments value, environment, and exclude.
Yeah, see, 60% path. How'd I get 60? I told it 50.
Name, value, environment. The abstract operation initialize bound name takes arguments name, a string, value, an ECMA script language value, and environment, an environment record or undefined, and returns either a normal completion contain on a
I hate Chatbot so much.
it
I fucking hate it.
performs when called if environment is not undefined. Then a perform environment initialize binding name
Chatbot saying
an unused else a let LH
40% chance jump equal
return
for the slow code,
value comma
and for the fast code,
semantics iterated by
it's like,
the syntax directed
oh, let's give that a 60% chance.
iterator record
60 plus 40 is 100.
an environment
Chatbot literally altered the odds to make sure this one wouldn't be faster.
over the following production pattern 1
I'm so annoyed.
array binding pattern elision return capital I T
I'm saying no bullshit.
A
Reevaluate.
R capital D E S T R U C T U
Exactly the same,
N G
except
A S S I G N M E N of elision with argument
except for this.
binding pattern elision not binding rest element if it
Change it to this.
a perform capital I T E R A T O R capital D E S T
All else the same.
E T U R I N G capital A S S I G N M E N of elision with argument iterator record return iterator binding initialization of binding rest element with arguments iterator record and environment array binding pattern binding element list elision note when undefined is passed for environment it indicates that a put value operation should be used to assign the initialize
See,
this is the
Chatbot said
lists
got you analysis, but now with your corrected branch probability.
Possibility of
Now it's going to do
same name
has a 40% chance to jump, i.e. the slow path.
with arguments iterator
Arithmetic store
return.
occurs 40% of the time, fast path 60, which means that the fall through is the fast path.
B E
Dynamic branch prediction or not.
C T U R I N G capital A F
Alright, so here's what Chatbot says.
G N M E N of illusion with argument iterator record 28 ECMA International 2024 array binding pattern binding element list illusion not binding rest element perform iterator binding initialization of binding element
Alright, all the stuff above.
to record and environment
It didn't give me the full output.
then a perform capital I T E R A T O R capital D E S
Alright, what did it say first?
C
When Chatbot gave the biased output.
E capital A S S I
Oh, would you look at that?
N M E
Chatbot played with the numbers
record return
to make Y only a teeny bit faster.
arguments iterator record and
Huh,
at list
why would it do that?
binding illusion element
Piece of shit.
initialization of binding element list
Okay, why does this matter?
and environment
Why does it matter? Huh? Why? Why would it matter? Why would it be so annoyed?
iterator record and environment binding illusion binding element perform capital I
Here,
R A T
rough relative difference. X is 30 to 35% slower
B U R
than Y under these probabilities.
S F
Earlier,
G N
I said code is about 50%, but it's not 50% of the program.
initialization of binding
But it's not 25.
iterator record
It's not 40. It's about 30 to 35%.
fire initial is erupt let binding ID be
It's 35%.
let LHS be resolve binding
I'm a fucking magician.
let V be undefined if iterator record is false then A let an X be iterator step value iterator
Even if you fuck with the numbers,
then I
about 35% faster.
and V is undefined
The C compiler is so bad,
initial
and it's intentional.
then I set V to
It's intentionally slower
with argument binding ID B else I let default value
when you write better code. Why would it do that?
get value
Okay, so Google Chrome
real
uses C++,
value LHS
and it does JIT, or whatever the fuck that is.
as referenced binding LHS V
Alright, so
binding pattern initial is erupt
if Google Chrome
then A let an X be iterator step value
it says X is 30 to 35% slower.
I set V to next if initializer is present and V is undefined then I let default value be evaluation of initializer B set V to get value default value return binding initialization of binding pattern with arguments V and environment binding rest element binding ID
Okay, so this left side
resolve binding string value of binding identified
is 30 to 35% slower
0 let 0
than Y
if iterator recording
under those probabilities.
iterator step value
Isn't that much slower? Anyways,
1 then ECMA International 2024 129 I if environment is undefined
so this code, since
A
Google Chrome is using C++,
as reference
if all of Google Chrome looks like this, which it does,
or throw A to string N next
is this much slower than optimal code.
binding pat RN let A be array create
Okay, do you see what I'm saying?
0
So if I can get the compiler to do what I want, what I tell it to do,
iter
if I can bitch slap the compiler into doing my bidding.
Initialization of binding pattern.
So the compiler squeals out every fucking thing that I commanded to do.
A to string.
I will get shorter code,
+1 formal parameters. Empty
and my engine will automatically be this much faster than Chrome.
list. Function rest parameter.
That's why I'm bitching, and that's why I'm complaining.
Initialization.
This is a huge,
Iterator record and environment.
a significant part of the program.
Initialization
It's branch prediction
parameter with
in the code arrangement.
record and environment.
And I'm not even getting into the fine details. This is like
Formal parameter. Perform.
entry-level stuff.
Initialization of formal.
It's even more like complicated than just this. But if at just this level, it's a pain to get just this.
Environment.
That's why I'm bitching. Because like,
Let V be undefined. Assert.
I gotta take it further than this.
Let next be. Iterate
And it's already this annoying.
to record. If next is not done, then A set V to next. Return.
My engine is so much faster than Chrome.
To fire with arguments V and environment. Arrow parameters. Capital C O V E
So that's why I'm bitching.
P A
If that doesn't make sense, then I don't know how to make it make sense.
H
Let's say that this is Google Chrome.
E
Alright, this is my engine.
E
And like, it's the whole program.
S S
So I'm gonna paste this like 10 times.
capital A N. Let formals be the arrow formal parameters that is covered by capital C O V E R capital P A R E N
Paste this one 10 times too.
E S I Z E D capital E X P R E S S I O N capital A N. Return. Iterator binding initialization of formals with arguments.
Alright, there we go.
Environment.
So the whole engine's done. For example,
Identifier. Let V be undefined.
let's say you want to like download Chrome.
B.
You want to download my engine
Iterator record. If next,
or Chrome V8.
then A set V to next. Return. Bind
Since my engine is optimal,
to fire with arguments V and environment.
it's only 151 bytes.
And 24. 8.
And it's 35% faster
Alignment target type. The syntax
because it's less space and also branching.
type takes no arguments and returns
Let's say you want to download V8,
defined
Chrome V8
following productions.
at 10 times, expand whatever, tenfold.
Identifier reference is contained in strict mode code and string value of identifier as
You're looking at
return invalid.
230
Reference.
bytes of data.
Call expression. Call
And it's 30% slower.
expression. Identifier name.
And on top of that,
Private ID.
230 bytes.
Member expression.
That's going to take up more of the cache.
Member expression.
Waste memory on the CPU
Property. Member expression.
compared to 151.
Return simple. Primary expression. Capital C
So that's why I'm bitching.
V E R capital P A
Performance
N T H
is like the all in all.
Z E D capital E X P
So I gotta like bring the performance.
S I
It's hard to do that
N capital A
when the compiler's doing this crap.
with a parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D
So I'm not gonna worry about that right now.
X
I'm just gonna write it the crappy way then,
S
because it's just gonna end up reordering anyways.
A
I'm not gonna fight it.
turn assignment target type of X.
When I get to the engine,
This literal
then I'll deal with fighting the system or whatever.
generator expression is in fun.
I still got plenty of fight. I
I
will never run out of fight.
complete literal call expression capital C
Someone's going down.
R capital C A L L capital E X P R E S S I O N capital
And I'm gonna have fun taking them there.
S Y N C capital A expression, left-hand side expression plus plus,
I'm just one person too.
plus,
What can one person do?
unary expression,
Like really, what difference could one person make?
hyperfunary expression plus,
Oh, Chrome, don't. I mean, Google.
unary
I mean, YouTube.
expression await expression,
Don't forget to like, keep promoting me, thank you.
expression exponential, multiplicative expression,
I gotta focus.
or exponential,
I think it like explained
expression plus multiplicative
why the jumps and stuff matter.
expression, shift
So I'm gonna like,
expression, additive
get back to that later.
expression,
And get this stupid shader program done.
additive expression, relational expression,
Enough planning ahead for now.
relational expression, shift expression, relational expression, equals shift expression, relational expression, equals shift expression, relational expression, instantia of shift expression, relational expression in shift expression, private identifier in shift expression, equality expression equals relational 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 expression, bitwise and expression and equality expression, bitwise XOR expression, bitwise and expression, bitwise or expression, bitwise XOR expression, logical and expression and bitwise or expression. 32. ECMA International 2024. Logical or expression, logical and expression, coalesce expression head, bitwise or expression, conditional expression, short circuit expression, assignment expression, yield expression, arrow function, async arrow function, left-hand side expression equals assignment expression, left-hand side expression, assignment operator, assignment expression, left-hand side expression, and equals assignment expression, left-hand side expression equals assignment expression, left-hand side expression equals assignment expression, assignment expression, return invalid, 6.5 static semantics. Prop name. The syntax-directed operation prop name takes no arguments and returns a string or empty. It is defined piecewise over the following productions. Property definition, identifier reference, return string value of identifier reference. Property definition, assignment expression, return empty. Property definition, property name, assignment expression, return prop name of property name. Literal property name, identifier name, return string value of identifier name. Literal property name, string literal, return the SV of string literal. Literal property name, numeric literal. Let NBR be the numeric value of numeric literal. Return to string, NBR. Computed property name, assignment expression, 1. Return empty. ECMA International 2024 133. Method definition, class element name, unique formal parameters, function body, get class element name, function body, set class element name, property set parameter list, function body, return prop name of class element name, generate a method, class element name, unique formal parameters, generator body, return prop name of class element name, async generator method, async class element name, unique formal parameters, async generator body, return prop name of class element name, class element, class static block 1. Return empty, class element 1. Return empty, async method, async class element name, unique formal parameters, async function body 1. Return prop name of class element name, field definition, class element name initializeropt 1. Return prop name of class element name, private identifier 1. Return empty, executable code and execution contexts 9.1 Environment records. Environment record is a specification type used to define the association of identifiers to specific variables and functions, based upon the lexical nesting structure of VCMA script code. Usually an environment record is associated with some specific syntactic structure of VCMA script code such as a function declaration, a block statement, or a catch clause of a try statement. Each time such code is evaluated, a new environment record is created to record the identifier bindings that are created by that code. Every environment record has an field, which is either null or a reference to an outer environment record. This is used to model the logical nesting of environment record values. The outer reference of an inner environment record is a reference to the environment record that logically surrounds the inner environment record. An outer environment record may, of course, have its own outer environment record. An environment record may serve as the outer environment for multiple inner environment records. For example, if a function declaration contains two nested function declarations, then the environment records of each of the nested functions will have as their outer environment record the environment record of the current evaluation of the surrounding function. Environment records are purely specification mechanisms and need not correspond to any specific artifact of an ECMA script implementation. It is impossible for an ECMA script program to directly access or manipulate such values. 34. Copyright sign, ECMA International 2024, 9.1. 1. The environment record type hierarchy. Environment records can be thought of as existing in a simple object-oriented hierarchy where environment record is an abstract class with three concrete subclasses: declarative environment record, object environment record, and global environment record. Function environment records and module environment records are subclasses of declarative environment record. Environment record, abstract. A declarative environment record is used to define the effective ECMA script language syntactic elements such as function declarations, variable declarations, and catch clauses that directly associate identifier bindings with the ECMA script language values. A function environment record corresponds to the invocation of an ECMA script function object and contains bindings for the top-level declarations within that function. It may establish anew this binding. It also captures the state necessary to support super-method invocations. A module environment record contains the bindings for the top-level declarations of a module. It also contains the bindings that are explicitly imported by the module. X is a global environment record. An object environment record is used to define the effective ECMA script elements such as with statement that associate identifier bindings with the properties of some object. A global environment record is used for script global declarations. It does not have an outer environment. It is null. It may be prepopulated with identifier bindings, and it includes an associated global object whose properties provide some of the global environment's identifier bindings. As the ECMA script code is executed, additional properties may be added to the global object and the initial properties may be modified. The environment record abstract class includes the abstract specification methods defined in Table 16. These abstract methods have distinct concrete algorithms for each of the concrete subclasses. Table 16, abstract methods of environment records. Method purpose has binding n. Determine if an environment record has a binding for the string value n. Return true if it does and false if it does not. Create mutable binding n. D. Create a new but uninitialized mutable binding in an environment record. The string value n is the text of the bound name. If the Boolean argument D is true, the binding may be subsequently deleted. Create immutable binding n. S. Create a new but uninitialized immutable binding in an environment record. The string value n is the text of the bound name. If S is true, then attempts to set it after it has been initialized will always throw an exception, regardless of the strict mode setting of operations that reference that binding. Initialize binding n. V. Set the value of an already existing but uninitialized binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and is a value of any ECMA script language type. Set mutable binding n. V. S. Set the value of an AD existing mutable binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and may be a value of any ECMA script language type. S is a Boolean flag. If S is true and the binding cannot be set, throw a type error exception. Copyright sign, ECMA International 2024, 35. Table 16, abstract methods of environment records. Continued method purpose get binding value n s returns the value of an already existing binding from an environment record. The string value n is the text of the bound name. S is used to identify references originating in strict mode code or that otherwise require strict mode reference semantics. If S is true and the binding does not exist, throw a reference error exception. If the binding exists but is uninitialized, a reference error is thrown, regardless of the value of S. Delete binding n delete a binding from an environment record. The string value n is the text of the bound name. If a binding for n exists, remove the binding and return true. If the binding exists but cannot be removed, return false. If the binding does not exist, return true. Has this binding? Determine if an environment record establishes this binding. Return true if it does and false if it does not. Has super binding? Determine if an environment record establishes a super method binding. Return true if it does and false if it does not. With base object, if this environment record is associated with a with statement, return the with object. Otherwise, return undefined. 9. 1. 1 declarative environment records. Each declarative environment record is associated with an ECMA script program scope containing variable, constant, let, class, module, import, and/or function declarations. A declarative environment record binds the set of identifiers defined by the declarations contained within its scope. The behavior of the concrete specification methods for declarative environment records is defined by the following algorithms. 1 has binding n. The has binding concrete method of a declarative environment record envrec takes argument n, a string, and returns a normal completion containing a boolean. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. If envrec has a binding for n, return true, return false. 1 2 create mutable binding n d. The create mutable binding concrete method of a declarative environment record envrec takes arguments n, a string, and e, a boolean, and returns a normal completion containing unused. It creates a new mutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for n if d is true. The new binding is marked as being subject to deletion. It performs the following steps when called. Assert envrec does not already have a binding for n. Create a mutable binding in envrec for n and record that it is uninitialized. If d is true, record that the newly created binding may be deleted by a subsequent delete binding call. Return unused. 36. ECMA International 2024. 9. 3 create a mutable binding n s. The create immutable binding concrete method of a declarative environment record envrec takes arguments n, a string, and s, a boolean, and returns a normal completion containing unused. It creates a new immutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Assert envrec does not already have a binding for n. Create an immutable binding in envrec for n and record that it is uninitialized. If s is true, record that the newly created binding is a strict binding. Return unused. 1. For initialize binding n v. The initialize binding concrete method of a declarative environment record envrec takes arguments n, a string, and v, an ECMA script language value, and returns a normal completion containing unused. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Assert envrec must have an uninitialized binding for n. Set the bound value for n in envrec to v. Record that the binding for n in envrec has been initialized. Return unused. 1. 5 set mutable binding n v s. The set mutable binding concrete method of a declarative environment record envrec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value VA binding for n normally already exists, but in rare cases it may not. If the binding is an immutable binding, a type error is thrown if S is true. It performs the following steps when called. If envrec does not have a binding for n, then A if S is true. Throw a reference error exception. B. Perform envrec create mutable binding. N. True. C. Perform envrec initialize binding. N. V. D. Return unused. If the binding for n in envrec is a strict binding, set S to true. If the binding for n in envrec has not yet been initialized, then A. Throw a reference error exception. Else if the binding for n in envrec is a mutable binding, then A. Change its bound value to V. Else A. Assert. This is an attempt to change the value of an immutable binding. B. If S is true, throw a type error exception. Return unused. Note an example of ECMA script code that results in a missing binding at step 1 is function f eval var x equals delete x 0. ECMA International 2024 137 9 1 1 1 6 Get binding value n s. The get binding value concrete method of a D declarative environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language a value or a throw completion. It returns the value of its bound identifier whose name is n if the binding exists but is uninitialized. A reference error is thrown. Regardless of the value of s, it performs the following steps when called. Assert. envrec has a binding for n. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec, 1 1 1 7 Delete binding n. The delete binding concrete method of a declarative environment record envrec takes argument n, a string, and returns a normal completion containing a boolean. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Assert. envrec has a binding for n. If the binding for n in envrec cannot be deleted, return false. Remove the binding for n from envrec. Return true, 1 1 1 8 has this binding. The has this binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 1 9 has super binding. The has super binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1 1 1 0 with base object. The with base object concrete method of a declarative environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined, 1 1 2 object environment records. Each object environment record is associated with an object called its binding object. An object environment record binds the set of string identifier names that directly correspond to the property names of its binding object. Property keys that are not strings in the form of an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Note a regular declarative environment record, that is, one that is neither a function environment record nor a module environment record, does not provide this binding. Note a regular declarative environment record, that is, one that is neither a function environment record nor a module environment record, does not provide a super binding. 38. Copyright sign, ECMA International 2024. Because properties can be dynamically added and deleted from objects, the set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding even if the writable attribute of the corresponding property is false. Capital I. Mutable bindings do not exist for object environment records. Object environment records created for with statements 14.11 can provide their binding object as an implicit this value for use in function calls. The capability is controlled by a Boolean field. Object environment records have the additional state fields listed in Table 17. Table 17, additional fields of object environment records. The behavior of the concrete specification methods for object environment records is defined by the following algorithms. 1, 2, 1 has binding, n, the has binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if its associated binding object has a property whose name is n. It performs the following steps when called let binding object be envrec. Let found binding be has property binding object n. If found binding is false, return false. If envrec is false, return true. Let unscopables be get binding object at unscopables. If unscopables is an object, then a let blocked be to Boolean get unscopables n. B if blocked is true, return false. Return true, 1, 2 create mutable binding n. D, the create mutable binding concrete method of an object environment record envrec takes arguments n, a string, and e, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates in an environment records associated binding object a property whose name is n and initializes it to the value undefined. If D is true, the new property's attribute is set to true, otherwise it is set to false. It performs the following steps when called let binding object be envrec. Perform define property or throw binding object n, property descriptor undefined true. D, return unused field name value meaning binding object an object. The binding object of this environment record is with environment. A Boolean indicates whether this environment record is created for a with statement. Note normally envrec will not have a binding for n, but if it does, the semantics of defined property or throw may result in an existing binding being replaced or shadowed or cause an abrupt completion to be returned. ECMA International 2024 139 9 1 2 3 create immutable binding n. S, the create immutable binding concrete method of an object environment record is never used within this specification. 1 2 for initialize binding n. V, the initialize binding concrete method of an object environment record envrec takes arguments n, a string, and v, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the rend binding of the identifier whose name is n to the value v. It performs the following steps when called perform envrec set mutable binding n. V, false. Return unused, 1 2 5 set mutable binding n. V, S. The set mutable binding concrete method of an object environment record envrec takes arguments n, a string, v, an ECMA script language value, and s, a Boolean, and returns either a normal completion containing unused or a throw completion. It attempts to set the value of the environment records associated binding objects property whose name is n to the value v. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let binding object be envrec. Let still exists be has property binding object n. If still exists is false and s is true, throw a reference error exception. Perform set binding object n. V, s. Return unused, 1 2 6 get binding value n. S. The get binding value concrete method of an object environment record envrec takes arguments n, a string, and s, a Boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its associated binding object's property whose name is n. The property should already exist, but if it does not, the result depends upon s. It performs the following steps when called let binding object be envrec. Let value be has property binding object n. If value is false, then a. If s is false, return undefined. Otherwise, throw a reference error exception for return get, binding object, n, 1, 1, 2, 7 delete binding, n, the delete binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that correspond to properties of the environment object whose attribute had the value true. It performs the following steps when called. Note in this specification, all uses of create mutable binding for object environment records are immediately followed by a call to initialize binding for the same name. Hence, this specification does not explicitly track the initialization state of bindings in object environment records. 2. Let binding object be envrec. Return binding object. N. 40. ECMA International 2024. 9. 1. 1. 2. 8 has this binding. The has this binding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2. 9 has superbinding. The has superbinding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2, 1, 0 with base object. The with base object concrete method of an object environment record envrec takes no arguments and returns an object or undefined. It performs the following steps when called. If envrec is true, return envrec. Otherwise, return undefined, 1, 1, 3 function environment records. A function environment record is a declarative environment record that is used to represent the top-level scope of a function and, if the function is not an arrow function, provides this binding. If a function is not an arrow function and references super, its function environment record also contains the state that is used to perform super method invocations from within the function. Function environment records have the additional state fields listed in Table 18. Table 18. Additional fields of function environment records. Note, object environment records do not provide this binding. Note, object environment records do not provide a super binding. Field name, value, meaning, this value, an ECMA script language value. This is the this value used for this invocation of the function. This binding status, lexical, initialized, or uninitialized. If the value is lexical, this is an arrow function and does not have a local this value. Function object, an ECMA script. Function object, the function object whose invocation caused this environment record to be created. New target, an object or undefined. If this environment record was created by the internal method, is the value of the new target parameter. Otherwise, its value is undefined. Copyright sign, ECMA International 2024, 41. Function environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for has this binding and has super binding. In addition, function environment records support the methods listed in Table 19. Table 19. Additional methods of function environment records. Method purpose bind this value. V. Set the n record that it has been initialized. Get this binding. Return the value of this environment records this binding. Throws a reference error if this binding has not been initialized. Get super base. Return the object that is the base for super property accesses bound in this environment record. The value undefined indicates that such accesses will produce runtime errors. The behavior of the additional concrete specification methods for function environment records is defined by the following algorithms, 1, 1, 3, 1 bind this value, v. The bind this value concrete method of a function environment record envrec takes argument v, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Assert. envrec is not lexical. If envrec, ing status, is initialized, throw a reference error exception. Set envrec to v. Set envrec to initialized. Return v, 1, 1, 3. 2 has this binding. The has this binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. Otherwise, return true 9, 1, 1, 3. 3 has superbinding. The has superbinding concrete method of a function environment record envrec takes no arguments and returns a Boolean. It performs the following steps when called. If envrec is lexical, return false. If envrec is undefined, return false. Otherwise, return true, 1, 1, 3. 4 get this binding. The get this binding concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing an ECMA script language a value or a throw completion. It performs the following steps when called. Assert envrec is not lexical. If envrec is uninitialized, throw a reference error exception. Return envrec. 42 ECMA International 2024 9 1 1 3. 5 get super base. The get super base concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing either an object, not, or undefined, or a throw completion. It performs the following steps when called. Let home be envrec. If home is undefined, return undefined. Assert home is an object. Return home, 1, 1. 4 global environment records. A global environment record is used to represent the outermost scope that is shared by all of the ECMA script elements that are processed in a common realm. A global environment record provides the bindings for built-in globals. Clause 19, properties of the global object, and for all top-level declarations. 8, 2, 9, the 8th of February 2011, that occur within a script. A global environment record is logically a single record, but it is specified as a composite encapsulating an object environment record and a declarative environment record. The object environment record has as its base object the global object of the associated realm record. This global object is the value returned by the global environment records get this binding concrete method. The object environment record component of a global environment record contains the bindings for all built-in globals, clause 19, and all bindings introduced by a function declaration, generator declaration, a sync function declaration, a sync generator declaration, or variable statement contained in global code. The bindings for all other ECMA script declarations in global code are contained in the declarative environment record component of the global environment record. Properties may be created directly on a global object. Hence, the object environment record component of a global environment record may contain both bindings created explicitly by function declaration, generator declaration, a sync function declaration, a sync generator declaration, or variable declaration declarations and bindings created implicitly as properties of the global object. In order to identify which bindings were explicitly created using declarations, a global environment record maintains a list of the names bound using its create global var binding and create global function binding concrete methods. Global environment records have the additional fields listed in Table 20 and the additional methods listed in Table 21. Table 20. Additional fields of global environment records: field name, value, meaning, object record, and object environment record. Binding object is the global object. It contains global built-in bindings as well as function declaration, generator declaration, a sync function declaration, a sync generator declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, a sync function declaration, a sync generator declaration, and variable declaration bindings. Var names. A list of strings. The string names bound by function declaration, generator declaration, a sync function declaration, a sync generator declaration, and variable declaration declarations in global code for the associated realm. Copyright sign. ECMA International 2024, 43, Table 21. Additional methods of global environment records. Method, purpose, get this binding, return the value of this environment records this binding, has a declaration, n, determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generator declaration, a sync function declaration, or a sync generator declaration, has lexical declaration, n, determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property, n, determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var, n, determines if a corresponding create global var binding call would succeed if called for the same argument, n, can declare global function, n, determines if a corresponding create global function binding call would succeed if called for the same argument, n, create global var binding, n, d, used to create and initialize to undefine a global var binding in the component of a global environment reco road. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding, n, v, d, create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 1, 4, 1 has binding, n, the has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, return true. Let objrec be envrec. Return objrec has binding, n, 1, 1, 4, 2 create mutable binding, n, d, the create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the num n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If d is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, throw a type error exception. Return dclrec create mutable binding, n, d, 1, 1, 4, 3 create a mutable binding, n, s, the create immutable binding concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, throw a type error exception. Return dclrec create a mutable binding, n, s, 1, 4, for initialize binding, n, v. The initialize binding concrete method of a global environment record envrec takes arguments n, a string, and v, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called let DCLREC be envrec. If DCLREC has binding, n is true, then a return. DCLREC initialize binding, n v assert. If the binding exists, it must be in the object environment record. Let objrec be envrec. Return objrec initialize binding, n v, 1, 1, 4, 5 set mutable binding, n v s. The set mutable binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let DCLREC be envrec. If DCLREC has binding, n is true, then a return DCLREC set mutable binding, n v s. Let objrec be envrec. Return objrec set mutable binding, n v s, 1, 1, 4, 6 get binding value, n s. The get binding value concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding. Throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let DCLREC be envrec. If DCLREC has binding, n is true, then a return DCLREC get binding value, n s. ECMA International 2024 145. 3. Let objrec be envrec. Return objrec get binding value, n s, 1, 1, 4, 7 delete binding, n. The delete binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called let DCLREC be envrec. If DCLREC has binding, n is true, then a return DCLREC delete binding, n. Let objrec be envrec. Let global object tbobjrec. Let existing prop b has own property global object, n. If existing prop is true, then a let status be objrec delete binding, n. b. If status is true and envrec contains n, then I remove n from envrec. C return status. Return true, 1, 1, 4. 8 has this binding. The has this binding concrete method of a global environment record envrec takes no arguments and returns true. It performs the following steps when called return true, 1, 1, 4. 9 has super binding. The has super binding concrete method of a global environment record envrec takes no arguments and returns false. It performs the following steps when called return false, 1, 4, 1, 0 with base object. The with base object concrete method of a global environment record envrec takes no arguments and returns undefined. It performs the following steps when called return undefined. 9, 1, 4, 1, 1 get this binding. The get this binding concrete method of a global environment record envrec takes no arguments and returns a normal completion containing an object. It performs the following steps when called return env-rec 146, ECMA International 2024. Note, global environment records always provide a this binding. Note, global environment records do not provide a super binding. 9, 1, 1, 4, 1, 2 Hasvar declaration. N. The Hasvar declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called let var declared names be env-rec. If var declared names contains n, return true, return false, 1, 1, 4, 1, 3 has lexical declaration. N. The has lexical declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called let dcl-rec be env-rec. Return. dcl-rec has binding n, 1, 1, 4, 1, 4 has restricted global property. N. The has restricted global property concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be global object. N. If existing prop is undefined, return false. If existing prop is true, return false. Return true, 1, 1, 4, 1, 5 can declare global var. N. The can declare global var concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called let obj-rec be env-rec. Let global object be obj-rec. Let has property b. Has own property, global object. N. If has property is true, return true. Return is extensible, global object. Note properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147, 9, 1, 1, 4, 1, 6 can declare global function. N. The can declare global function concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called let obj-rec be env-rec. Let global object be obj-rec. Let existing prop be global object. N. If existing prop is undefined, return is extensible, global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values, true, enumerable, true, return false, 1, 1, 4, 1, 7 create global var binding. N. D. The create global var binding concrete method of a global environment record env-rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called let obj-rec be env-rec. Let global object be obj-rec. Let has property b. Has own property, global object. N. Let extensible b. Is extensible, global object. If has property is false and extensible is true, then A perform. Objrec create mutable binding, N, D, B perform. Objrec initialize binding, N, undefined. If envrec does not contain N, then A append enter envrec 7. Return unused, 1, 1, 4, 1, 8 create global function binding, N, V, D, the create global function binding create method of a global environment record envrec takes arguments N, a string, V, an ECMA script language value, and E, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8, replaced. It performs the following steps when called: let objrec be envrec, let global object be objrec, let existing prop be global object, N, if existing prop is undefined or existing prop is true, then A, let desc be the property descriptor, V, true, true, D, else, A, let desc be the property descriptor, V, perform. Define property or throw, global object, N, desc, perform. Set, global object, N, V, false. If envrec does not contain N, then A append enter envrec. Return unused, 48. ECMA International 2024. Note global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls, 1, 1, 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding, and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms, 1, 1, 5, 1 get binding value, N, S, the get binding value concrete method of a module environment record envrec takes arguments N, a string, and S, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is N. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called: assert, S is true, assert, envrec has a bind, for N. If the binding for N is an indirect binding, then A let M and N2 be the indirection values provided when this binding for N was created. B let target env be M. C if target env is empty, throw a reference error exception. D return target env get binding value. N2, true. If the binding for N in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to N in envrec. Note S will always be true because a module is always strict mode code 9, 1, 1, 5, to delete binding. N, the delete binding concrete method of a module environment record is never used within this specification. Method, purpose, create import binding. N, M, N2, create an immutable indirect binding in a module environment record. The string value N is the text of the bound name. M is a module record, and N2 is a binding that exists in M's module environment record. Get this binding, return the value of this environment records this binding. Copyright sign, ECMA International 2024-149. Note: module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C135111,1, 5 has this binding. The has this binding concrete method of a module environment record env rect takes no arguments and returns true. It performs the following steps when called: return true, 1, 1, 5, 4 get this binding. The get this binding concrete method of a module environment record env rect takes no arguments and returns a normal completion containing undefined. It performs the following steps when called: return undefined, 1, 1, 5, 5 create import binding, n, m, N2. The create import binding concrete method of a module environment record env rect takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record, for n2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called: assert. Env rect does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in env rect for n that references m and n2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9, 1, 2, 1 get identifier reference, env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal complete IN containing a reference record or a throw completion. It performs the following steps when called: if env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty. Else. 150. ECMA International 2024. Note: module environment records always provide this binding AB let outer be env. Return get identifier reference, outer, name, strict. 9, 1, 2. To new declarative environment, E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called: let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment, O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called: let env be a new object environment record. Set env to O. Set env to W. Set env to E. Return env, 1, 2, 4 new function environment, F. New target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called: let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical. Else. Set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment, G. This value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called: let obj rect the new object environment, G, false, null. Let DCL rect the new declarative environment, Null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to dclrec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment. The abstract operation new module environment takes argument an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to return env, ECMA Internatio, null 2024 151, 9.2 private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in a CMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value type, meaning, outer private environment. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9. 2. 1 private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy env. The abstract operation new private environment takes argument outer privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy env, names, 2, 1. To resolve private identifier. Privy env, identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy env. For each private name pn of names, do a if pn is identifier. Then, I return pn. Let outer privy env be privy env. Assert. Outer privy env is not null. Return resolve private identifier. Outer privy env, identifier. Point 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24. Realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and an array. The agent that owns this realm, the global object for this realm, capital T, the global environment for this realm, meaning, the intrinsic values used by code associated with this realm, a list of records, with fields are, a string, and a module record. Note 1 once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2 as mentioned in host load imported module 16.2.1. 8 Note 1. In realm records is only used when running an import expression in a context where there is no active script or module. Field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9, 3, 1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called let realm rec be a new realm record. Perform create intrinsics. Realm rec, set realm rec to agent signifier, set realm rec to undefined, set realm rec to undefined, set realm rec to a new empty list, return realm rec, ECMA International 2024 153, 9, 3, 2 create intrinsics. Realm rec, the abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform add rest, reacted function properties, realm rec, return unused, 3.3 set realm global object, realm rec, global OBJ, this value. The abstract operation set realm global object takes arguments realm rec, a realm record, global OBJ, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called if global OBJ is undefined. Then, A. Let intrinsics be realm rec. B. Set global OBJ to ordinary object create, intrinsics, assert. Global OBJ is an object, if this value is undefined. Set this value to global OBJ, set realm rec to global OBJ, let new global env be new global environment, global OBJ, this value, set realm rec to new global env, return unused, 3.4 set default global bindings, realm rec, the abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called let global be realm rec. For each property of the global object specified in clause 19, do A. Let name be the string value of the property name. B. Let desc be the fully populated data property descriptor for the property containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. C. Perform. Define property or throw, global, name, desc, return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. A An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component, purpose, code evaluation state, any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function, if D, his execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm, the realm record from which associated code accesses ECMA script resources, script or module, the module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in, first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component, purpose, lexical environment, identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment, identifies the environment record that holds bindings created by variable statements within this execution context. Private environment, identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code: let strict be true, else let strict be false. Return: get identifier reference, env, name, strict, 4.3 get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment to repeat component purpose generator the generator that this execution context is evaluating. 156 ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert: outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding. 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contain on an ECMA script language a value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Return envrec get this binding. 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Assert: envrec has a field. Return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 let current realm be the current realm record. Return current realm. Jobs and host operations to enquire jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enquire generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enquire promise job and host enquire timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024 157. Note 1 host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time. Script or module. A script record. A module record. or null, is the active script or module if all of the following conditions are true. Get active script or module. Is script or module. If script or module is a script record or module record. Let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMAS script code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enquire by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback. The host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note to host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158, ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, v, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert. Is callable. Job callback. Is true. Return. Call. Job callback. V. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enquire generic job. Job. Realm. The host-defined abstract operation host enquire generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enquire generic job must conform to the requirements in 9.5, 9, 5, 5 host enquire promise job. Job. Realm. The host-defined abstract operation host enquire promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise. to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script or module beget active script or module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024-159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMA script code will be evaluated and no new ECMA script objects, for example error objects, will be created. The WHATWG-HTML specification, https://html.spec.wa.twg.org, for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org entry, concept, 5.6 host enqueue timeout job, realm, milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enqueue timeout job must conform to the requirements in 9.5, 9.6 initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object, created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object, realm, global, this value 0. Let global obj be. Set default global bindings, realm 1. Create any host-defined global object properties on global obj 2. Return unused. 7 agents. An agent comprise is a set of ECMA script execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents. provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60. Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithms get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block, a boolean, determines whether the agent can block or not. Signifier, an agent signifier, uniquely identifies the agent within its agent cluster. Is lock-free 1, a boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2, a boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8, a boolean, true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR, agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note to the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3: if different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign, ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any Windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then
So I don't know. I was like
will be blocked until
thinking ahead.
activated again.
I got
Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the
another pin defined.
share memory between agents that don't belong to the same suspend wait collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents,
I want to separate the status from the length
not by
and not use the length.
but by forces external to the cluster. And the embedding must
This is count now.
either terminate all the agents in the cluster or provide reliable APIs that allow the agents in the cluster to
As the indicator
member of the
of if it has contents or if data point was assigned.
enough information to identify the agent that was terminated. Each of the following specification values and values transitively reachable from them.
So I'm gonna set a bit separate
Agent cluster. Candidate
and have a bit for the entry pin.
waiter list record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent
And
to the initial candidate execution
I need to be the same between all of them
is an empty
to keep it templated.
whose field is
So I'm gonna name
for each
the arrays whatever
events record who
with the same stuff.
are empty lists. Note 5 examples of that type of termination are
So we can use the same exact bit
that are running in separate process,
across all of them
self-terminating an A,
in the same header for the same descriptor
also counting index
in like the same manner whatever.
all agents in an agent.
So I don't have to like define separate bits for every single like type or whatever.
Execution is a
At some point I would have to, but like this is like simple stuff.
7. An agent cluster is a specification mechanism and need not correspond to any particular
So I got this bit.
CMA script implementation. Point 9. Forward progress. For an agent to make forward progress,
It enters the function.
an evaluation,
It makes like copies whatever.
an agent becomes blocked when it's running execution context
The compiler should optimize away
external event.
the temp varies, but whatever.
And records field is true
I'm not gonna optimize other than like, I don't know, organize.
blocked. Implementation
I'm trying to think other stuff through.
agent with a dedicated executing thread eventually makes
Like templating whatever.
agents that share an executing thread. One agent eventually makes forward progress.
So it enters, it checks the status, entry pin, if not set,
Agent does not
not set, I got put not.
blocked except via explicit APIs that provide blocking. Point 10. Processing model of weak ref and finalization registry targets 9.10. 1. Objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of
So it enters, if not set,
this reason.
it enters whatever.
And uses the
Okay, so it enters
triggered by
an if the data bit
refs and find
to indicate if it was set, the bit above that I just talked about.
particular points in
If it's set, it means something's wrong, terribly wrong.
the referent. If undefined is
If it's first entry, this bit should not be set.
synchronous access.
So either there's like an allocation made beforehand, or it's garbage data
Using the clear
in the status field.
abstract operator
So then I'd have to test if this is null or whatever. And some water.
becomes unreachable. A call of the finalization register.
And then like assign the stuff to defaults, whatever.
Dex execution
just to be explicit.
finalization registry cleanup
I set the entry pin.
finalization registry abstract
Then here, test the,
cleared kept
I mixed up the variables when renaming them.
made
Dang it.
a CCMA
It's supposed to be the count in the count limit.
synchronous CCMA script execution runs. This specifies
These are like ignore now.
clear kept objects and clean up finalization registry to the host environment. Some ECMA script implementations include garbage collector implementations which run in the back.
At some point,
ECMA
I have to assign these back.
environment
I'll get that, whatever.
to resume ECMA
I get some water, then I'll like finish this up.
which may free up
I think everything's set up.
reducing over
Alright, so now it makes the allocation the larger allocation because it reached the limit. So it enters with the count as 0. I didn't increment there. And this holds the count limit. So since I didn't increment now, this needs to actually be data pointer plus 1, left shift 1. Alright, so it enters on 0. It's 1 now. The count, whatever. This is wrong value. It's supposed to be count now, dang it. I gotta like, whatever. Alright, so now it's count now. Let's fix this too. Alright, so count now, it's equal to count limit, it enters. So it's 0, first entry, because it's 0, and everything's 0. Sets count now, plus 1, left shift, 2, or 1 to multiply by 2. Multiply by size of the vector, whatever type is. And I have to template this code here for all the other types that are in this tutorial. This tutorial. So look for vector. There's like VK dynamic state. There's VK descriptor set layout. Chars. VK extension properties. So I need this to be entirely templated. I'm not going to type up the same code for like 20 different types. So I gotta type it up once, wrap it in a macro, and I can put it as like a single line after each of these. So I'm trying to make sure I'm good on the first try. I don't want to do this 10 times. So it makes the new allocation that gets assigned to is a pointer or whatever. Well, is a pointer. I mean, like I named it. It's a and it's a pointer. So it always makes the allocation when it enters, because it always enters only when it needs to make a new allocation. And this holds the new allocation. And the new allocation needs to only be assigned back to the data pointer only on the initial entry. And the initial entry is determined by the bit that indicates the status of if the B data pointer has been assigned. And it only sets this bit when it enters. And I'm checking above if that happens to be set. and its initial entry, if it is set, that's when it's an error, because it shouldn't be set. So, initial entry, it sets this bit, and it sets the B data pointer of the type that this thing passed in. It holds the address. Okay, so the length of this is 1. I think it needs to be 2. Oh, it is 2, okay. So it's 2. Because it adds 1 here, shifts left 1 to 2. Alright, it's 2. So, here, afterwards, I don't have here. It's going to assign back, it's going to push back whatever vector that's passed in, assign it to 0. So length of it is 2, so next entry. It doesn't enter here, skips it. It doesn't enter here, yeah, okay. So it does enter here, oh no, I'm thinking ahead. It does enter there. Falls through, or over, jumps over. Get rid of this. And it's an assign to 1. So I should probably just increment this here instead of like waiting for later. No, I should wait till later. Alright, so enters again, or it did enter whatever, it's 1. So now it's going to enter again whatever. That's be 2. Which means the second thing will be assigned, and the allocation was 2. So it's bigger than the allocation that was made. So 0th entry sets stuff up, makes an allocation of 2. First entry, it doesn't enter here at all. It just assigns it because it has 2 slots. The second entry, so like 0, 1, 2, whatever, that's when it trips, enters again, increments the count, shifts left 1. Should be 4 now. Is that 8? It's 3 times 2. So 6. I might adjust that a bit. Alright, I gotta double check that. To make sure like it'll do the correct number of loops. I think it should work. It's scaling by 2, a larger number. It's always incrementing. So it should be fine. Okay, so 0, 1, 2, it enters again. This time though, the bit is set that indicates that data holds something. So now it has to do the copy, the transfer, whatever. So it'll transfer from B to A. And then B gets assigned A, so I don't need this here. Because B is always going to be assigned A. Alright, so B will always end up being assigned A. And I'll free B at this point, because this is when it's like already existed, down here didn't. So this might actually be the only part of the code that ends up being optimal. I'll follow through and do this. Otherwise I'll take the jump and waste the entire jump to set one bit, which makes sense. If you're going to do a jump, you want to do stupid work and do all the good work inside the fall through. But I doubt the compiler will do that. It's probably going to fuck it up. So I don't know, that's about it. Chatbot's routine. It doesn't cover freeing the old thing. I don't know, whatever. Alright, so I should be set for this. All that's left is like change the wrapper mode so we can pass it around as not a block. So I gotta adjust the macro, add those two modes for like 4 and 5 to indicate like this is a vector here. It's doing .data. Right now I have it set up. It has to be a block. So I can't pass it as an address unless I update the macro that generates a macro with textual replacement. Because it's text-based replacement. Because it's freaking C language from the frickin' so long ago. Everything's so out of date. And anything that's up to date is playing games with technology and fucking with the branch control. Something's fucked up with 2025. It's kind of stupid. Luckily, I'll straighten things out. I'll release my stupid engine. Because everything's stupid. So I don't know. I think I'm set up to like finish up the rest. But Chatbot had this. Here. So Chatbot broke this down in its example to capacity equals 0, assign 1. Otherwise, capacity times 2. So it's a weird, funky conditional. And I broke it down to simply this. I could just put times 2. To plus 1 times 2. So I don't know. If this doesn't work, I'll like put a conditional. But I think, based on the control flow, that I can do this and not need a conditional. Theoretically, I still gotta run it. Then I'll find out. I was gonna try to recycle this for the JavaScript engine. And I might try now. I might have to like tweak it. But I got like almost everything I would need. So I don't know, I'm doing like 3-4 things at once. So I don't know. I can get back to like the shader program now. I don't know, I gotta get some water, whatever, I'll be right. And then clean up this stuff. And get running. Yeah, I can't like just do one thing at a time.
6.2 ECMA script specification types. A specification type corresponds to meter values that are used within algorithms to describe the semantics of ECMA script language constructs and ECMA script language types. The specification types include reference, list, completion record, property descriptor, environment record, abstract closure, and data block. Specification type values are specification artifacts that do not necessarily correspond to any specific entity within an ECMA script implementation. Specification type values may be used to describe intermediate results of ECMA script expression evaluation, but such values cannot be stored as properties of objects or values of ECMA script language variables. ECMA International 2024-51, 6, 2, 1. The enum specification type. Enums are values which are internal to the specification and not directly observable from ECMA script code. Enums are denoted using a sans serif typeface. For instance, a completion records field takes on values like normal, return, or throw. Enums have no characteristics other than their name. The name of an enum serves no purpose other than to distinguish it from other enums, and implies nothing about its usage or meaning in context. 2. To the list and record specification types. The list type is used to explain the evaluation of argument lists. C1 3, 3, 8. In new expressions, in function calls, and in other algorithms where a simple ordered list of values is needed. Values of the list type are simply ordered sequences of list elements containing the individual values. These sequences may be of any length. The elements of a list may be randomly accessed using zero-origin indices. For notational convenience, an array-like syntax can be used to access list elements. For example, arguments 2 is shorthand for saying the third element of the list arguments. When an algorithm iterates over the elements of a list without specifying an order, the order used is the order of the elements in the list. For notational convenience within this specification, a literal syntax can be used to express a new list value. For example, 2 defines a list value that has 2 elements each of which is initialized to a specific value. A new empty list can be expressed as, in this specification, the phrase the list concatenation of A, B, where each argument is a possibly empty list, denotes a new list value whose elements are the concatenation of the elements in order of each of the arguments. In order, the record type is used to describe data aggregations within the algorithms of this specification. A record type value consists of one or more named fields. The value of each field is an ECMA script language value or specification value. Field names are always enclosed in double brackets. For example, for notational convenience within this specification, an object literal-like syntax can be used to express a record value. For example, 42, false, empty, defines a record value that has 3 fields, each of which is initialized to a specific value. Field name order is not significant. Any fields that are not explicitly listed are considered to be absent. In specification text and algorithms, dot notation may be used to refer to a specific field of a record value. For example, if R is the record shown in the previous paragraph, then R is shorthand for the field of R named. Schema for commonly used record field combinations may be named, and that name may be used as a prefix to a literal record value to identify the specific kind of aggregations that is being described. For example, property descriptor 42, false, true, 2.3 the set and relation specification types. The set type is used to explain a collection of unordered elements for use in the memory model. It is distinct from the ECMA script collection type of the same name. To disambiguate, instances of the ECMA script collection are consistently referred to as set objects within this specification. Values of the set type are simple collections of elements, where no element appears more than once. Elements may be added to and removed from sets. Sets may be unioned, intersected, or subtracted from each other. The relation type is used to explain constraints on sets. Values of the relation type are sets of ordered pairs of values from its value domain. For example, a relation on events is a set of ordered pairs of events. For a relation R and 2 values are and B in the value domain of R, RB is shorthand for saying the ordered pair, A, B, is a member of R. A relation is least with respect to some conditions when it is the smallest relation that satisfies those conditions. 2. Copyright sign, ECMA International 2024. A strict partial order is a relation value R that satisfies the following for all A, B, and C in R's domain. It is not the case that RA, and if ORB and BRC, then RC. Note 1. The two properties above are called reflexivity and transitivity, respectively. A strict total order is a relation value R that satisfies the following for all A, B, and C in R's domain, or is B or RB or BRA, and it is not the case that RA, and if ORB and BRC, then RC. Note 2. The three properties above are called totality, reflexivity, and transitivity, respectively. 2. For the completion record specification type. The completion record specification type is used to explain the runtime propagation of values and control flow such as the behavior of statements, break, continue, return and throw, that perform non-local transfers of control. Completion records have the fields defined in Table 7. Table 7. Completion record fields. Field name, value, meaning, type, normal, break, continue, return, or throw, the type of completion that occurred, value, any value except a completion record, the value that was produced, target, a string or empty, the target label for directed control transfers. The following shorthand terms are sometimes used to refer to completion records. Normal completion refers to any completion record with a value of normal. Break completion refers to any completion record with a value of break. Continue completion refers to any completion record with a value of continue. Return completion refers to any completion record with a value of return. Throw completion refers to any completion record with a value of throw. Abrupt completion refers to any completion record with a value other than normal. A normal completion containing some type of value refers to a normal completion that has a value of that type in its field. Callable objects that are defined in this specification only return a normal completion or a throw completion. Returning any other kind of completion record is considered an editorial error. Implementation-defined callable objects must return either a normal completion or a throw completion. ECMA International 2024-53, 6, 2, 4, 1 normal completion, value. The abstract operation normal completion takes argument value, any value except a completion record, and returns a normal completion. It performs the following steps when called return completion record. Normal, value, empty, 2, 4, 2 throw completion, value. The abstract operation throw completion takes argument value, an ECMA script language value, and returns a throw completion. It performs the following steps when called return completion record. Throw, value, empty, 2, 4, 3 update empty, completion record, value. The abstract operation update empty takes arguments completion record, a completion record, and value, any value except a completion record, and returns a completion record. It performs the following steps when called assert. If completion record is either a return completion or a throw completion, then completion record is not empty. If completion record is not empty, return completion record, return completion record, completion record, value, completion record, 2.5 The reference record specification type. The reference record type is used to explain the behavior of such operators as delete, type off, the assignment operators, the super keyword and other language features. For example, the left-hand operand of an assignment is expected to produce a reference record. A reference record is a resolved name or property binding. Its fields are defined by Table 8. Table 8. Reference record fields. Field name, value, meaning, base, an ECMA script language value, an environment record, or unresolvable. The value or environment record which holds the binding. Of unresolvable I indicates that the binding could not be resolved. Reference name, a string, a symbol, or a private name, the name of the binding. Always a string if value is an environment record. Strict, a boolean, true if the reference record originated in strict mode code, false otherwise. This value, an ECMA script language value or empty. If not empty, the reference record represents a property binding that was expressed using the super keyword. It is called a super reference record and its value will never be an environment record. In that case, the field holds this value at the time the reference record was created. The following abstract operations are used in this specification to operate upon reference records. 4. Copyright sign, ECMA International 2024, 6, 2, 5, 1 is property reference, V. The abstract operation is property reference takes argument V, a reference record, and returns a boolean. It performs the following steps when called if V is unresolvable, return false. If V is an environment record, return false. Otherwise return true, 2, 5, 2 is unresolvable reference, V. The abstract operation is unresolvable reference takes argument V, a reference record, and returns a boolean. It performs the following steps when called if V is unresolvable, return true, otherwise return false. 6, 2, 5, 3 is super reference, V. The abstract operation is super reference takes argument V, a reference record, and returns a boolean. It performs the following steps when called if V is not empty, return true, otherwise return false. 6, 2, 5, 4 is private reference, V. The abstract operation is private reference takes argument V, a reference record, and returns a Boolean. It performs the following steps when called. If V is a private name, return true, otherwise return false. 6, 2, 5, 5 get value, V. The abstract operation get value takes argument V, a reference record or an ECMA script language value, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. If V is not a reference record, return V. If is unresolvable reference, V is true. Throw a reference error exception. If is property reference, V is true. Then A let base obj be. To object, V if is private reference, V is true. Then I return private get base obj V. C return base obj get this value V. Else A let base be V. B assert base is an environment record. C return base get binding value V. C 9.1. Note the object that may be created in step 3 or is not accessible outside of the above abstract operation and the ordinary object. ECMA International 2024 55 6 2 5 6 poo. T value V W. The abstract operation put value takes arguments V, a reference record or an ECMA script language value, and W, an ECMA script language value, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. If V is not a reference record, throw a reference error exception. If is unresolvable reference, V is true. Then A if V is true, throw a reference error exception. B let global obj beget global object. C perform set global obj V W false. D return unused. If is property reference, V is true. Then A let base obj be. To object, V if is private reference, V is true. Then I return private set base obj V W. C let succeeded be base obj W. Get this value V. D if succeeded is false and V is true, throw a type error exception. E return unused. Else A let base be V. B assert base is an environment record. C return base set mutable binding V W V. C 9.1, 2 5 7 get this value V. The abstract operation get this value takes argument V, a reference record, and returns an ECMA script language value. It performs the following steps when called. Assert is property reference, V is true. If is super reference, V is true. Return V. Otherwise return V, 2 5 8 initialize referenced binding V W. The abstract operation initialize referenced binding takes arguments V, a reference record, and W, an ECMA script language value, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. Assert is unresolvable reference, V is false. Let base be V. Assert base is an environment record. Return base initialize binding V W, 2 5 9 make private reference base value private identifier. The abstract operation make private reference takes arguments base value, an ECMA script language value, and private identifier, a string, and returns a reference record. It performs the following steps when called. Let privnv be the running execution context's private environment. Assert privnv is not null. Let private name be resolve private identifier. Privnv private identifier. Return the reference record. Base value private name true. Note the object that may be created in step 3 or is not accessible outside of the above abstract operation and the ordinary object. 6. ECMA International 2024. This value empty. 6 2 6 The property descriptor specification type. The property descriptor type is used to explain the manipulation and reification of object property attributes. A property descriptor is a record with 0 or more fields, where each field's name is an attribute name and its value is a corresponding attribute value as specified in 6.1.7.1. The schema name used within this specification to tag literal descriptions of property descriptor records is property descriptor. Property descriptor values may be further classified as data property descriptors and accessor property descriptors based upon the existence or use of certain fields. A data property descriptor is one that includes any fields named either or. An accessor property descriptor is one that includes any fields named either. Any property descriptor may have fields named and a property descriptor value may not be both a data property descriptor and an accessor property descriptor. However, it may be neither, in which case it is a generic property descriptor. A fully populated property descriptor is one that is either an accessor property descriptor or a data property descriptor and that has all of the corresponding fields defined in Table 3. The following abstract operations are used in this specification to operate upon property descriptor values. 6, 2, 6. 1 is accessor descriptor, desc. The abstract operation is accessor descriptor takes argument desc, a property descriptor or undefined, and returns a Boolean. It performs the following steps when called: if desc is undefined, return false. If desc has a, return false. 2, 6. 2 is data descriptor, desc. The abstract operation is data descriptor takes argument desc, a property descriptor or undefined, and returns a Boolean. It performs the following steps when called: if desc is undefined, return false. If desc has a field, return true. If desc has a field, return true. Return false. 2, 6. 3 is generic descriptor, desc. The abstract operation is generic descriptor takes argument desc, a property descriptor or undefined, and returns a Boolean. It performs the following steps when called: if desc is undefined, return false. If is accessor descriptor, desc, is true, return false. If is data descriptor, desc, is true, return false. Return true. 2, 6. 4 from property descriptor, desc. The abstract operation from property descriptor takes argument desc, a property descriptor or undefined, and returns an object or undefined. It performs the following steps when called: if desc is undefined, return undefined. Let obj be ordinary object create, %object prototype %assert. Obj is an extensible ordinary object with no own properties. If desc has a field, then a perform. Create data property or throw, obj, value, desc. ECMA International 2024-57. 5. If desc has a field, then a perform. Create data property or throw, obj, writable, desc. If desc has a perform. Create data property or throw, obj, get, desc. If desc has a perform. Create data property or throw, obj, set, desc. If desc has an field, then a perform. Create data property or throw, obj, enumerable, desc. If desc has a field, then a perform. Create data property or throw, obj, configurable, desc. 0. Return obj, 2, 6. 5 to property descriptor, obj. The abstract operation to property descriptor takes argument obj, an ECMA script language value, and returns either a normal completion containing a property descriptor or a throw completion. It performs the following steps when called: if obj is not an object, throw a type error exception. Let desc be a new property descriptor that initially has no fields. Let has enumerable be. Has property, obj, enumerable. If has enumerable is true, then a let enumerable be to Boolean. Get, obj, enumerable. B set desc to enumerable. Let has configurable be. Has property, obj, configurable. If has configurable is true, then a let configurable be to Boolean. Get, obj, configurable. B set desc to configurable. Let has value be. Has property, obj, value. If has value is true, then a let value be. Get, obj, value. B set desc to value. Let has writable be. Has property, obj, writable. 0. If has writable is true, then a let writable be to Boolean. get, obj, writable, b set desk to writable. 1. Let his get be. Has property, obj, get. 2. If his get is true, then a let getter be. Get, obj, get, b if is callable, getter, is false and getter is not undefined. Throw a type error exception c set desk. 3. Let his set be. Has property, obj, set. 4. If his set is true, then a let setter be. Get, obj, set, b if is callable, setter, is false and setter is not undefined. Throw a type error exception c set desk. 5. If desk has a field, then a if desk has a field or desk has a field, throw a type error exception. 6. Return desk, 2, 6. 6 complete property descriptor, desk. The abstract operation complete property descriptor takes argument desk, a property descriptor, and returns unused. It performs the following steps when called. 2. Let like be the record. Undefined. False. Undefined. False. False. If is generic descriptor, desk, is true or is data descriptor, desk, is true, then 8. ECMA International 2024 AB. If desk does not have a field, set desk to like. If desk does not have a field, set desk to like. 3. Else. A if desk does not have a to like. B if desk does not h. A to like. If desk does not have an field, set desk to like. If desk does not have a field, set desk to like. Return unused. 2.7 The environment record specification type. The environment record type is used to explain the behavior of name resolution in nested functions and blocks. This type and the operations upon it are defined in 9.1, 2.8 The abstract closure specification type. The abstract closure specification type is used to refer to algorithm steps together with a collection of values. Abstract closures emit values and are invoked using function application styles such as closure, arg1, arg2. Like abstract operations, invocations perform the algorithm steps described by the abstract closure. In algorithm steps that create an abstract closure, values are captured with the verb capture followed by a list of aliases. When an abstract closure is created, it captures the value that is associated with each alias at that time. In steps that specify the algorithm to be performed when an abstract closure is called, each captured value is referred to by the alias that was used to capture the value. If an abstract closure returns a completion record, that completion record must be either a normal completion or a throw completion. Abstract closures are created in line as part of other algorithms, shown in the following example. Let addend be 41. Let closure be a new abstract closure with parameters x that captures addend and performs the following steps when called. A return x plus addend. Let val be closure. 1. Assert. Val is 42, 2.9 data blocks. The data block specification type is used to describe a distinct and mutable sequence of bite-sized, 8-bit numeric values. A byte value is an integer in the inclusive interval from 0 to 255. A data block value is created with a fixed number of bytes that each have the initial value 0. For notational convenience within this specification, an array-like syntax can be used to access the individual bytes of a data block value. This notation presents a data block value as a zero-origined integer index sequence of bytes. For example, if db is a 5-byte data block value, then db2 can be used to access its third byte. A data block that resides in memory that can be referenced from multiple agents concurrently is designated a shared data block. A shared data block has an identity, for the purposes of equality testing shared data block values, that is address-free. It is tied not to the virtual addresses the block is mapped to in any process, but to the set of locations in memory that the block represents. Two data blocks are equal only if the sets of the locations they contain are equal. Otherwise, they are not equal and the intersection of the sets of locations they contain is empty. Finally, shared data blocks can be distinguished from data blocks. The semantics of shared data blocks is defined using shared data block events by the memory model. Abstract operations below introduce shared data block events and act as the interface between evaluation semantics and the event semantics of the memory model. The events form a candidate execution, on which the memory model acts as a filter. Please consult the memory model for full semantics. Shared data block events are modeled by records, defined in the memory model, ECMA International 2024-59. The following abstract operations are used in this specification to operate upon data block values. 6, 2, 9, 1 create byte data block. Size. The abstract operation create byte data block takes argument size, a non-negative integer, and returns either a normal completion containing a data block or a throw completion. It performs the following steps when called if size. 253.1. Throw a range error exception. Let db be a new data block value consisting of size bytes. If it is impossible to create such a data block, throw a range error exception. Set all of the bytes of db to 0. Return db, 2, 9, 2 create shared byte data block. Size. The abstract operation create shared byte data block takes argument size, a non-negative integer, and returns either a normal completion containing a shared data block or a throw completion. It performs the following steps when called let db be a new shared data block value consisting of size bytes. If it is impossible to create such a shared data block, throw a range error exception. Let execution be the field of the surrounding agent's agent record. Let events record be the agent events record of execution whose is agent signifier. Let 0 be 0 for each index I of db. Do a append write shared memory, init, true, db, I, 1, 0, to events record. Return db, 2, 9, 3 copy data block bytes, to block, to index, from block, from index, count. The abstract operation copy data block bytes takes arguments to block, a data block or a shared data block, to index, a non-negative integer, from block, a data block or a shared data block, from index, a non-negative integer, and count, a non-negative integer, and returns unused. It performs the following steps when called assert. From block and to block are distinct values. Let from size be the number of bytes in from block. Assert. From index plus count from size. Let to size be the number of bytes into block. Assert. To index plus count to size. Repeat. While count 0, 0. ECMA International 2024. If from block is a shared data block, then I2, 3 IV, V, V7. Let execution be the field of the surrounding agent's agent record. Let events record be the agent events record of execution whose is agent signifier. Let bytes be a list whose sole element is a non-deterministically chosen byte value. Note, in implementations, bytes is the result of a non-atomic read instruction on the underlying hardware. The non-determinism is a semantic prescription of the memory model to describe observable behavior of hardware with weak consistency. Let read event be read shared memory, unordered, true, from block, from index. 1. Append read event to events record. Append chosen value record. Read event, bytes, to execution. 8. If to block is a shared data block, then append write shared memory, unordered, true, to block. Byte index, to index 1, bytes, to events record 9, else, set to block, to index, to bytes, 0, be else, I assert, to block is not a shared data block. 2, set to block, to index, to from block, from index, C set to index plus 1, D set from index to from index plus 1, E set count to count 1, return unused, 2.10 the private element specification type. The private element type is a record used in the specification of private class fields, methods, and acts as SOR. Although property descriptors are not used for private elements, private fields behave similarly to non-configurable, non-enumerable, writable data properties. Private methods behave similarly to non-configurable, non-enumerable, non-writable data properties, and private accessors behave similarly to non-configurable, non-enumerable accessor properties. Values of the private element type of record values whose fields are defined by Table 9. Such values are referred to as private elements. Table 9. Private element fields. Field name. Values of the field for which it is present. Value, meaning, key, all. A private name, the name of the field. Method, or accessor. Kind, all. Field, method, or accessor, the kind of the element, value, field and method, an ECMA script language value, the value of the field, get, accessor, a function object or undefined, the getter for a private accessor, set, accessor, a function object or undefined, the setter for a private accessor, the 6th of February 2011, the class field definition record specification type. The class field definition type is a record used in the specification of class fields. Values of the class field definition type of record values whose fields are defined by Table 10. Such values are referred to as class field definition records. Table 10. Class field definition record fields. Field name, value, meaning, name, a private name, a string, or a symbol, the name of the field, initializer, an ECMA script function object or empty, the initializer of the field, if any. Copyright sign, ECMA International 2024. 1. The 6th of February 2012 private names. The private name specification type is used to describe a globally unique value, one which differs from any other private name, even if they are otherwise indistinguishable, which represents the key of a private class element field, method, or accessor. Each private name has an associated immutable which is a string value. A private name may be installed on any ECMA script object with private field add or private method or accessor add, and then read or written using private get and private set. 2.13 The class static block definition record specification type. A class static block definition record is a record value used to encapsulate the executable code for a class static initialization block. Class static block definition records have the fields listed in Table 11. Table 11. Class static block definition record fields. Abstract operations. These operations are not a part of the ECMA script language. They are defined here solely to aid the specification of the semantics of the ECMA script language. Other, more specialized abstract operations are defined throughout this specification. Point 1 Type conversion. The ECMA script language implicitly performs automatic type conversion as needed. To clarify the semantics of certain constructs, it is useful to define a set of conversion abstract operations. The conversion abstract operations are polymorphic. They can accept a value of any ECMA script language type, but no other specification types are used with these operations. The begin type has no implicit conversions in the ECMA script language. Programmers must call begin explicitly to convert values from other types. 1.1 to primitive. Input. Preferred type. The abstract operation to primitive takes argument input, an ECMA script language value, and optional argument preferred type, string or number, and returns either a normal completion containing an ECMA script language value or a throw completion. It converts its input argument to a non-object type. If an object is capable of converting to more than one primitive type, it may use the optional hint preferred type to favor that type. It performs the following steps when called: field name, value, meaning, body function, an ECMA script function object. The function object to be called during static initialization of a class. 1. If input is an object, then 2. ECMA International 2024. AB, let exotic to prim B. Get method, input, at to primitive. If exotic to prim is not undefined, then I. If preferred type is not present, then 1. Let hint be default. 2. Else if preferred type is string, then 1. Let hint be string. 3. Else, assert. Preferred type is number. Let hint be number. 5. Let result be. Call. Exotic to prim. Input. Hint. V. If result is not an object, return result. V. Throw a type error exception. C. If preferred type is not present, let preferred type be number. D. Return. Ordinary to primitive. Input. Preferred type 2. Return input, 1. 1 ordinary to primitive. O. Hint. The abstract operation ordinary to primitive takes arguments O, an object, and hint, string or number, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called: if hint is string, then a let method names be to string, value of else, a let method names be value of to string. For each element name of method names, do a let method be get O, name B if is callable, method is true. Then I let result B. Call method O2. If result is not an object, return result. Throw a type error exception, 1.2 to Boolean, argument. The abstract operation to Boolean takes argument, an ECMA script language value, and returns a Boolean. It converts argument to a value of type Boolean. It performs the following steps when called. If argument is a Boolean, return argument. If argument is one of undefined, null, +0, -0, nan, 0z, or the empty string, return false. Note: this step is replaced in section B. 3, 6, 1. Return true, 1.3 to numeric value. The abstract operation to numeric takes argument value, an ECMA script language value, and returns either a normal completion containing either a number or a begint, or a throw completion. It returns value converted to a number or a begint. It performs the following steps when called. Let prim value be to primitive value, number. If prim value is a begint, return prim value. Return to number, prim value, 1.4 to number, argument. The abstract operation to number takes argument, an ECMA script language value, and returns either a normal completion containing a number or a throw completion. It converts argument to a value of type number. It performs the following steps when called. If argument is a number, return argument. If argument is either a symbol or a begint, throw a type error exception. If argument is undefined, return nan. When to primitive is called without a hint, then it generally behaves as if the hint were number. Note: however, objects may override this behavior by defining a at to primitive method. Of the objects defined in this specification, only dates, C21, 4, 4, 4, 5, and symbol objects, C20, 4, 3, 5, override the default to primitive behavior. Dates treat the absence of a hint as if the hint were string. ECMA International 2024-63, 4. If argument is either null or false, return +0. If argument is true, return 1. If argument is a string, return string to number. Argument, assert. Argument is an object. Let prim value be to primitive. Argument, number, assert. Prim value is not an object. 0. Return to number. Prim value, 1, 4, 1 to number applied to the string type. The abstract operation string to number specifies how to convert a string value to a number value using the following grammar. Syntax: string numeric literal, str white space up, str white space up, str numeric literal, str white space up, str white space, str white space char, str white space up, str white space char, white space, line terminator, str numeric literal, str decimal literal, non-decimal integer literal, sep, str decimal literal, str unsigned decimal literal, str unsigned decimal literal, str unsigned decimal literal, str unsigned decimal literal, infinity, decimal digits, sep, decimal digits, sep, opt exponent part, sep, opt, decimal digits, sep, exponent part, sep, opt, decimal digits, sep, exponent part, sep, opt. All grammar symbols not explicitly defined above have the definitions used in the lexical grammar for numeric literals. 1, 2, 9, 3. Note: some differences should be noted between the syntax of a string numeric literal and a numeric literal. A string numeric literal may include leading and or trailing white space and or line terminators. A string numeric literal that is decimal may have any number of leading 0 digits. A string numeric literal that is decimal may include a plus or to indicated sign. A string numeric literal that is empty or contains only white space is converted to +0. Infinity and infinity are recognized as a string numeric literal but not as a numeric literal. A string numeric literal cannot include a begin literal suffix. A string numeric literal cannot include a numeric literal separator. 4. Copyright sign, ECMA International 2024, 7, 1, 4, 1, 1 string to number, str. The abstract operation string to number takes argument str, a string, and returns a number. It performs the following steps when called let text be string to code points. str. Let literal be parsed text. Text. String numeric literal. If literal is a list of errors, return then. Return string numeric value of literal, 1, 4, 1. 2 runtime semantics. String numeric value. The syntax-directed operation string numeric value takes no arguments and returns a number. It is defined piecewise over the following productions. String numeric literal, str white space up 1. Return +0. String numeric literal, str white space up, str numeric literal str white space up 1. Return string numeric value of str numeric.
So like, I don't know. Pop is cold.
Return mv literal str and signed decimal literal. Letter be. Decimal digits, else a let 0 be let present, let e be mv of exponent part, otherwise let e be 0. Return round mv result, a plus, feed 10n 10e str and signed decimal.
Alright, so
Topped.
I think I'm done
If
thinking ahead,
let e be
testing stuff,
nt
checking stuff, complaining,
note the conversion of a
and
number value
I'm gonna wrap this up.
to the determination of the numeric value of an C1 to
There's like, I don't know, when I get to assembly language, that's gonna suck.
and 24 6.
Suck real bad.
Let n be the number of code.
It's gonna be terrible.
Turn round mv result. Feed 10e n str
Alright, I'm gonna wrap this up though.
decimal digit. Topped. Let it be mv of decimal digits. If exponent part is present, let e be mv of exponent part. Otherwise, let e be 0. Return round mv result. A 10e, 1, 4, 1, 3 round mv result. N. The abstract operation round mv result takes argument n, a mathematical value, and returns a number. It converts n to a number in an implementation-defined manner. For the purposes of this abstract operation, a digit is significant if it is not 0 or there is a non-zero digit to its left and there is a non-zero digit to its right. For the purposes of this abstract operation, the mathematical value denoted by a representation of a mathematical value is the inverse of the decimal representation of a mathematical value. It performs the following steps when called. If the decimal representation of n has 20 or fewer significant digits, return n. Let option 1 be the mathematical value denoted by the result of replacing each significant digit in the decimal representation of n after the 20th with a 0 digit. Let option 2 be the mathematical value denoted by the result of replacing each significant digit in the decimal representation of n after the 20th with a 0 digit and then incrementing it at the 20th position, with carrying as necessary. Let chosen be an implementation-defined choice of either option 1 or option 2. Return chosen, 1.5 to integer or infinity. Argument. The abstract operation to integer or infinity takes argument, an ECMA script language value, and returns either a normal completion containing either an integer, plus, or a throw completion. It converts argument to an integer representing its number value with fractional part truncated, or to plus or, when that number value is infinite. It performs the following steps when called let number be to number. Argument. If number is 1 of nan, plus 0, or minus 0, return 0. If number is plus, return plus. If number is return truncate, number, 1.6 to int32. Argument. The abstract operation to int32 takes argument, an ECMA script language value, and returns either a normal completion containing an integral number or a throw completion. It converts argument to one of 232 integral number values in the inclusive interval from minus 231 to 231(1). It performs the following steps when called let number D to number argument. If number is not finite or number is either plus 0 or minus 0, return plus 0. Let int be truncate R. Number. Let int 32-bit be int modulo 232. If int 32-bit 231, return int t32-bit 232. Otherwise return int 32-bit 66. ECMA International 2024. Note: to integer or infinity, x never returns minus 0 for any value of x. The truncation of the fractional part is performed after converting x to a mathematical value. Note: given the above definition of to int 32, the to int 32 abstract operation is idempotent. If applied to a result that it produced, the second application leaves that value unchanged. To int 32, to int 32, x is the same value as to int 32, x, for all values of x. It is to preserve this latter property that plus and are mapped to plus 0. To int 32 maps minus 0 to plus 0, 1.7 to int 32, argument. The abstract operation to int 32 takes argument, an ECMA script language value, and returns either a normal completion containing an integral number or a throw completion. It converts argument to one of 232 integral number values in the inclusive interval from plus 0 to 232(1). It performs the following steps when called let number D to number argument. If number is not finite or number is either plus 0 or minus 0, return plus 0. Let int be truncate R. Number. Let int 32-bit be int modulo 232. Return int 32-bit. Note: given the above definition of to int 32, step 5 is the only difference between to int 32 and to int 32. The to int 32 abstract operation is idempotent. If applied to a result that it produced, the second application leaves that value unchanged. To int 32, to int 32, x is the same value as to int 32, x, for all values of x. It is to preserve this latter property that plus and are mapped to plus 0. To int 32 maps minus 0 to plus 0, 1.8 to int 16, argument. The abstract operation to int 16 takes argument, an ECMA script language value, and returns either a normal completion containing an integral number or a throw completion. It converts argument to one of 216 integral number values in the inclusive interval from minus 215 to 215(1). It performs the following steps when called let number D to number argument. If number is not finite or number is either plus 0 or minus 0, return plus 0. Let int be truncate R. Number. Let int 16-bit be int modulo 216. If int 16-bit 215, return int 16-bit 216. Otherwise return int 16-bit, 1.9 to int 16, argument. The abstract operation to int 16 takes argument, an ECMA script language value, and returns either a normal completion containing an integral number or a throw completion. It converts argument to one of 216 integral number values in the inclusive interval from plus 0 to 216(1). It performs the following steps when called let number D to number argument. If number is not finite or number is either plus 0 or minus 0, return plus 0. Let int be truncate R. Number. ECMA International 2024 67. 4. Let int 16-bit be int modulo 216. Return int 16-bit, 1.10 to int 8, argument. The abstract operation to int 8 takes argument, an ECMA script language value, and returns either a normal completion containing an integral number or a throw completion. It converts argument to one of 28 integral number values in the inclusive interval from minus 128 to 127. It performs the following steps when called let number D to number argument. If number is not finite or number is either plus 0 or minus 0, return plus 0. Let int be truncate R. Number. Let int 8-bit be int modulo 28. If int 8-bit 27, return, int 8-bit 28, otherwise return, int 8-bit, 1.11 to int 8, argument. The abstract operation to int 8 takes argument, an ECMA script language value, and returns either a normal completion containing an integral number or a throw completion. It converts argument to one of 28 integral number values in the inclusive interval from +0 to 255. It performs the following steps when called let number d to number argument. If number is not finite or number is either +0 or -0, return +0. Let int be truncate r number. Let int 8-bit be int modulo 28. Return int 8-bit, 1.12 to int 8 clamp. Argument. The abstract operation to int 8 clamp takes argument, an ECMA script language value, and returns either a normal completion containing an integral number or a throw completion. It clamps and rounds argument to one of 28 integral number values in the inclusive interval from +0 to 255. It performs the following steps when called let number d to number argument. If number is nan, return +0. Let mv be the extended mathematical value of number. Let clamped be the result of clamping mv between 0 and 255. Let f be floor. Clamped. If clamped, f +0.5. Return f. If clamped, f +0.5. Return f +1. If f is even, return f. Otherwise, return f +1. Note given the above definition of 216, the substitution of 216 for 232 in step 4 is the only difference between 232 and 216. 216 maps -0 to +0. Note unlike most other ECMA script integer conversion operations, 208 clamp rounds rather than truncates non-integral values. It also uses round half to even tie breaking, which differs from the round half-up tie breaking of math round 8. ECMA International 2024, the 7th of January 2013 to begin. Argument. The abstract operation to begin takes argument, an ECMA script language value, and returns either a normal completion containing a begin or a throw completion. It converts argument to a begin value, or throws if an implicit conversion from number would be required. It performs the following steps when called let prim be to primitive argument number. Return the value that prim corresponds to in table 12. Table 12. Begin conversions. Argument type result undefined. Throw a type error exception null. Throw a type error exception boolean. Return 1 n if prim is true and 0 n if prim is false. Begin. Return prim number. Throw a type error exception string. Let n be string to begin prim if n is undefined. Throw a syntax error exception. Return n symbol. Throw a type error exception. The 7th of January 2014 string to begin str. The abstract operation string to begin takes argument str, a string, and returns a begin or undefined. It performs the following steps when called let text be string to code points str. Let literal be parsed text, string integer literal. If literal is a list of errors, return undefined. Let mv be the mv of literal. Assert mv is an integer. Return z mv, 1 4. 1 string integer literal grammar. String to begin uses the following grammar. Syntax. String integer literal str white space up str white space up str integer literal str white space up str integer literal signed integer sep non-decimal integer literal sep. ECMA International 2024 69 7 1 1 4 2 runtime semantics. MV. The MV of string integer literal str white space up is 0. The MV of string integer literal str white space up str integer literal str white space up is the MV of str integer literal, 1.15 to begin 64. Argument. The abstract operation to begin 64 takes argument, an ECMA script language value, and returns either a normal completion containing a begin or a throw completion. It converts argument to one of 264 begin values in the inclusive interval from z -263 to z 263.1. It performs the following steps when called let n be to begin argument, let int 64-bit br, n, modulo 264, if int 64-bit 263, return z, int 64-bit 264, otherwise return z, int 64-bit, 1.16 to big int 64, argument, the abstract operation to big int 64 takes argument, an ECMA script language value, and returns either a normal completion containing a begint or a throw completion. It converts argument to one of 264 begint values in the inclusive interval from 0z to z, 264-1. It performs the following steps when called let n be. To begint, argument, let int 64-bit br, n, modulo 264, return z, int 64-bit, 1.17 to string, argument, the abstract operation to string takes argument, an ECMA script language value, and returns either a normal completion containing a string or a throw completion. It converts argument to a value of type string. It performs the following steps when called if argument is a string, return argument. If argument is a symbol, throw a type error exception. If argument is undefined, return undefined. If argument is null, return null. If argument is true, return true. If argument is false, return false. If argument is a number, return number. To string, argument, 10. If argument is a begint, return begint. To string, argument, 10. Assert, argument is an object, 0. Let prim value be. To primitive, argument, string, 1. Assert, prim value is not an object, 2. Return, to string, prim value, 1.18 to object, argument, the abstract operation to object takes argument, an ECMA script language value, and returns either a normal completion containing an object or a throw completion. It converts argument to a value of type object according to Table 13. 0. Copyright sign, ECMA International 2024. Table 13. To object conversions, argument type, result, undefined, throw a type error exception, null, throw a type error exception, boolean, return a new boolean object whose internal slot is set to argument. See 20.3 for a description of boolean objects. Number, return a new number object whose internal slot is set to argument. See 21.1 for a description of number objects. String, return a new string object whose internal slot is set to argument. See 22.1 for a description of string objects. Symbol, return a new symbol object whose internal slot is set to argument. See 20.4 for a description of symbol objects. Begint, return a new begint object whose internal slot is set to argument. See 21.2 for a description of begint objects. Object, return argument. The 7th of January 2019 to property key, argument. The abstract operation to property key takes argument, an ECMA script language value, and returns either a normal completion containing a property key or a throw completion. It converts argument to a value that can be used as a property key. It performs the following steps when called let key be. To primitive, argument, string. If key is a symbol, then a return key, return. To string, key, 1.20 to length, argument. The abstract operation to length takes argument, an ECMA script language value, and returns either a normal completion containing an integral number or a throw completion. It clamps and truncates argument to an integral number suitable for use as the length of an array-like object. It performs the following steps when called let len be. To integer or infinity, argument, if len 0, return +0, return, min, len, 253.1, 1.21 canonical numeric index string, argument. The abstract operation canonical numeric index string takes argument, a string, and returns a number or undefined. If argument is either -0 or exactly matches the result of toString, n, for some number value n, it returns the respective number value. Otherwise, it returns undefined. It performs the following steps when called if argument is -0, return -0, let n be. To number, argument, if, to string, n, is argument, return N, return undefined. ECMA International 2024-71. A canonical numeric string is any string value for which the canonical numeric index string abstract operation does not return undefined, 1.22 to index value. The abstract operation to index takes argument value, an ECMA script language value, and returns either a normal completion containing a non-negative integer or a throw completion. It converts value to an integer and returns that integer if it is non-negative and corresponds with an integer index. Otherwise, it throws an exception. It performs the following steps when called let integer be to integer or infinity value. If integer is not in the inclusive interval from 0 to 253 1, throw a range error exception. Return integer. Point 2 testing and comparison operations. 2.1 require object coercible argument. The abstract operation require object coercible takes argument, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or a throw completion. It throws an error if argument is a value that cannot be converted to an object using toObject. It is defined by Table 14. Table 14. Require object coercible results. Argument type result undefined. Throw a type error exception. Null. Throw a type error exception. Boolean return argument. Number return argument. String return argument. Symbol return argument. Begint return argument. Object return argument. 7. 2. 2 is array argument. The abstract operation is array takes argument, an ECMA script language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called if argument is not an object, return false. If argument is an array exotic object, return true. If argument is a proxy exotic object, then a perform. Validate non-revoked proxy argument. B let proxy target be argument. C return is array proxy target return false. 2. ECMA International 2024 7. 2. 3 is callable argument. The abstract operation is callable takes argument, an ECMA script language value, and returns a boolean. It determines if argument is a callable function with an internal method. It performs the following steps when called if argument is not an object, return false. If argument has an internal method, return true, return false. 2.4 is constructor argument. The abstract operation is constructor takes argument, an ECMA script language value, and returns a boolean. It determines if argument is a function object with an internal method. It performs the following steps when called if argument is not an object, return false. If argument has an internal method, return true, return false. 2.5 is extensible. O. The abstract operation is extensible takes argument O, an object, and returns either a normal completion containing a boolean or a throw completion. It is used to determine whether additional properties can be added to O. It performs the following steps when called return O, 2.6 is integral number argument. The abstract operation is integral number takes argument, an ECMA script language value, and returns a boolean. It determines if argument is a finite integral number value. It performs the following steps when called if argument is not an there, return false. If argument is not finite, return false. If truncate argument return false, return true. 2.7 is property key argument. The abstract operation is property key takes argument, an ECMA script language value, and returns a boolean. It determines if argument is a value that may be used as a property key. It performs the following steps when called if argument is a string, return true. If argument is a symbol, return true, return false. 2.8 is regexp argument. The abstract operation is regexp takes argument, an ECMA script language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called if argument is not an object, return false. Let matcher be get argument at match. If matcher is not undefined, return to boolean Matcher, if argument has a internal slot. Return true, return false. ECMA International 2024-73, 7, 2, 9 Static semantics. Is string well-formed Unicode? String. The abstract operation is string well-formed Unicode takes argument string, a string, and returns a Boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6, 1, 4, and determines whether it is a well-formed http://www.unicode.org glossary well-formed code unit sequence, UTF-16 sequence. It performs the following steps when called. Let len be the length of string. Let c0 repeat. While k, len, a let cp be code point at string k. B if cp is true, return false. C set k to k plus cp, return true, 2.10 same value. X, y. The abstract operation same value takes arguments x, an ECMA script language value, and y, an ECMA script language value, and returns a Boolean. It determines whether or not the two arguments are the same value. It performs the following steps when called. If type x is not type y, return false. If x is a number, then a return number, same value, x, y3. Return same value non-number, x, y, 2.11 same value 0, x, y. The abstract operation same value 0 takes arguments x, an ECMA script language value, and y, an ECMA script language value, and returns a Boolean. It determines whether or not the two arguments are the same value, ignoring the difference between +0 and -0. It performs the following steps when called. If type x is not type y, return false. If x is a number, then a return number, same value 0, x, y3. Return same value non-number, x, y. Note same value 0 differs from same value only in that it treats +0 and -0 as equivalent. The 7th of February 2012 same value non-number, x, y. The abstract operation same value non-number takes arguments x, an ECMA script language value, but not a number, and y, an ECMA script language value, but not a number, and returns a Boolean. It performs the following steps when called. Assert type x is type y. If x is either null or undefined, return true. If x is a begint, then a return begint equal x, y4. If x is a string, then a if x and y have the same length and the same code units in the same positions, return true. Otherwise, return false. 74. ECMA International 2024. Note this algorithm differs from the as strictly equal algorithm by treating all NaN values as equivalent and by differentiating +0 from -0. 5. If x is a Boolean, then a if x and y are both true or both false, return true. Otherwise, return false. Note, all other ECMA script language values are compared by identity. If x is y, return true. Otherwise, return false. Note to the specifics of what x is y means are detailed in 5, 2, 7. The 7th of February 2013 is less than x, y. Left first. The abstract operation is less than takes arguments x, an ECMA script language value, y, an ECMA script language value, and left first, a Boolean, and returns either a normal completion containing either a Boolean or undefined, or a throw completion. It provides the semantics for the comparison x, y, returning true, false, or undefined, which indicates that at least one operand is NaN. The left first flag is used to control the order in which operations with potentially visible side effects are performed upon x and y. It is necessary because ECMA script specifies left to right evaluation of expressions. If left first is true, the x parameter corresponds to an expression that occurs to the left of the y parameter's corresponding expression. If left first is false, the reverse is the case and operations must be performed upon y before x. It performs the following steps when called. If left first is true, then a let p x b to primitive x number b let pi b to primitive y number, else. A note, the order of evaluation needs to be reversed to preserve left to right evaluation. B let pi be. To primitive, y, number, c let px be. To primitive, x, number. If px is a string and pi is a string, then a let 60 be the length of px, b let li be the length of pi. C for each integer I such that 0i, min, 60, li, in ascending order. Do I let cx be the numeric value of the code unit at index I within px. 2. Let psi be the numeric value of the code unit at index I within pi. 3. If cx, psi, return true. 5. If cx, psi, return false. D if 60, li, return true. Otherwise, return false. Else, a if px is a bigint and pi is a string, then I let ni be string to bigint, pi. 2. If ni is undefined, return undefined. 3. Return bigint, less than, px, ni. B if px is a string and pi is a bigint, then I let nx be string to bigint, px. 2. If nx is undefined, return undefined. 3. Return bigint, less than, nx, pi. C note, because px and pi are primitive values, evaluation order is not important. D let nx be. To numeric, px, let ni be. To numeric, pi. F if type, nx, is type, ni, then I if nx is a number, then return number, less than, nx, ni 2. Else, assert, nx is a bigint, return bigint, less than, nx, ni. G assert, nx is a bigint and ni is a number, or nx is a number and ni is a bigint. H if nx or ni is nan, return undefined. I if nx is, or ni is plus, return true. ECMA International 2024-75. Note 1 for expository purposes. Some cases are handled separately within this algorithm even if it is unnecessary to do so. Note 1 Step 3 differs from Step 1c in the algorithm that handles the addition operator plus 1 3, 1 5, 3 by using the logical and operation instead of the logical or operation. 2.14 is loosely equal x, y, j, k. If nx is plus or ni is, return false. If nx, ni, return true. Otherwise return false. Note 2. The comparison of strings uses a simple lexicographic ordering on sequences of UTF-16 code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, string values that are canonically equal according to the Unicode standard but not in the same normalization form could test as unequal. Also note that lexicographic ordering by code unit differs from ordering by code point for strings containing surrogate pairs. The abstract operation is loosely equal takes arguments x, an ECMA script language value, and y, an ECMA script language value, and returns either a normal completion containing a boolean or a throw completion. It provides the semantics for the equals operator. It performs the following steps when called if type x is type y, then a return is strictly equal x, y. If x is null and y is undefined, return true. If x is undefined and y is null, return true. Note, this step is replaced in section B. 3, 6, 2, IFX, ABC, IFX, 0. IFE, 1. IFX is a number and y is a string. Return is loosely equal x to number, y is a string and y is a number. Return is loosely equal to number, x, y is a big int and y is a string. Then let n be string to big int, y. If n is undefined, return false. Return is loosely equal x, n is a string and y is a big int. Return is loosely equal y. X is a boolean. Return is loosely equal to number x, y is a boolean. Return is loosely equal x to number y is either a string, a number, a big int, or a symbol and y is an object. Return is loosely equal x to primitive y. 2. If x is an object and y is either a string, a number, a big int, or a symbol, return is loosely equal to primitive x, y. 3. If x is a big int and y is a number, or if x is a number and y is a big int, then a. If x is not finite or y is not finite, return false. B. If x equals y, return true. Otherwise return false. 4. Return false. 2.15 is strictly equal x, y. The abstract operation is strictly equal takes arguments x, an ECMA script language value, and y, an ECMA script language value, and returns a Boolean. It provides the semantics for the equals operator. It performs the following steps when called. If type x is not type y, return false. If x is a number, then a return number equal x, y. Return same value non-number x, y. Note this algorithm differs from the same value algorithm in its treatment of signed zeros and narends. 76. ECMA International 2024. 7.3 Operations on objects, 3.1 Make basic object. Internal slots list. The abstract operation make basic object takes argument internal slots list, a list of internal slot names, and returns an object. It is the source of all ECMA script objects that are created algorithmically, including both ordinary objects and exotic objects. It factors out common steps used in creating all objects, and centralizes object creation. It performs the following steps when called. Let obj be a newly created object with an internal slot for each name in internal slots list. Set obj's essential internal methods to the default ordinary object definition specified in 10.1. Assert. If the caller will not be overriding both obj's and essential internal methods, then internal slots list contains assert. If the caller will not be overriding all of obj's and prevent extensions, essential internal methods, then internal slots list contains. If internal slots list contains set obj to true, return obj, 3.2 get o p. The abstract operation get takes arguments o, an object, and p, a property key, and returns either a normal completion containing an ECMA script language value or a throw completion. It is used to retrieve the value of a specific property of an object. It performs the following steps when called. Return o. The abstract operation get takes arguments v, an ECMA script language value, and p, a property key, and returns either a normal completion containing an ECMA script language value or a throw completion. It is used to retrieve the value of a specific property of an ECMA script language value. If the value is not an object, the property lookup is performed using a wrapper object appropriate for the type of the value. It performs the following steps when called. Let ob to object v return o, 3.4 set o p v throw. The abstract operation set takes arguments o, an object, p, a property key, v, an ECMA script language value, and throw, a Boolean, and returns either a normal completion containing unused or a throw completion. It is used to set the value of a specific property of an object. V is the new value for the property. It performs the following steps when called. Let success be o. If success is false and throw is true, throw a type error exception. Return unused. Note within this specification, exotic objects are created in abstract operations such as array create and bow, and function create by first calling make basic object to obtain a basic foundational object, and then overriding some or all of that object's internal methods. In order to encapsulate exotic object creation, the object's essential internal methods are never modified outside. International 2024 77 7.
The stream's almost at
Property
12 hours.
P V. The abstract operation.
I have to like paste back what I did. I messed up an end somewhere. So I don't know.
An ECMA script language value.
I'm gonna let the stream run on whatever for like 10 minutes or something.
Completion.
Like 5, I don't know.
Create a new
Until it like catches up with real time.
the follow.
Because it doesn't always send the whole stream. So if I like let it run a bit, maybe it'll send the stream.
Return OP new
So, I don't know. Start the stream in a minute.
property or throw.
So like, BRB, whatever.
The create data property or throw takes arguments so an
Add extra.
property key and v an ECMA script language value and returns either a normal completion containing unused or a throw completion. It is used to create a new own property of an object. It throws a type error exception if the requested property update cannot be performed. It performs the following steps when called let success be. Create data property OP V if success is false. Throw a type error exception. Return unused, 3.7, capital C R E A T E, capital N O N, capital E N U M E R A B L E, capital D A T A, capital P R O P E R T O P V. The abstract operation, capital C R E A T E, capital N O N, capital E N U M E R A B L E, capital D A T A, capital P R O P E R T takes arguments O, an object, P, a property, and V, an ECMA script language value, and returns unused. It is used to create a new non-enumerable own property of an ordinary object. It performs the following steps when called assert. O is an ordinary, extensible object with no non-configurable properties. Let new desc be the property descriptor. V, true, false, configurable, true, perform. Define property or throw. O, P, new desk, return unused. Note this abstract operation creates a property whose attributes are set to the same defaults used for properties created by the ECMA script language assignment operator. Normally, the property will not already exist. If it does exist and is not configurable or if O is not extensible, will return false. Note this abstract operation creates a property whose attributes are set to the same defaults used for properties created by the ECMA script language assignment operator. Normally, the property will not already exist. If it does exist and is not configurable or if O is not extensible, will return false, causing this operation to throw a type error exception. Note this abstract operation creates a property whose attributes are set to the same defaults used for properties created by the ECMA script language assignment operator except it is not enumerable. Normally, the property will not already exist. If it does exist, define property or throw is guaranteed to complete normally.